India's highways, setting standards, building frameworks, and shaping the way our nation moves.
As President of Indian Roads Congress, I underscore our organization's role as a thought leader and technical authority. With a 90 years legacy of developing highway codes and standards, we facilitate discussions amidst experts through conferences, seminars, and workshops. This vibrant knowledge sharing network ensures that our engineering guidelines reflect the latest research and best practices for India's sustainable road development.
A century ago, India's roads were few and far between.
Check, hello, check. Check, hello, check one. Hello, check, check. Hello, check 1, 2, 3. Hey, hey, check. All right, everyone, a very good morning to all of you. I hope everybody is having a great morning. Is it a boring one? No? All right, so today we are going to have 4 technical sessions over here, and we are going to start with the first one, technical session 14, presentation by the Officer of Works Department, Government of Odisha, and the session will be chaired by Shri D.O. Taude, former member, National Highways Authority, India, convener, IRC B8 committee. May I please request you, sir, to kindly request you, sir, join us on the dais. The session will be co-chaired by Dr. U.C. Sahu, Professor, Indian Institute of Technology, Bhubaneswar, and member of IRC Technical. May I please request you, sir, to kindly join us on the dais. And now, to welcome both our chairperson and co-chairperson, may I please request on stage Purnamasi, Pragya Purnamasi, Superintending Engineer, Works Department, Odisha. May I please request you, ma'am, to kindly come to the dais and welcome our chairperson and co-chairperson with a flower bouquet. And ladies and gentlemen, we can give them a round of applause. Clapping make noises. I cannot hear any noise. Thank you so much, madam. And let's start the technical session 14 by inviting all our presenters to the dais, starting with Dr. Subhranshu Swai, Superintending Engineer, Civil Cum Roads, Bhubaneswar. Engineer Sundar Madhav Padhi, Chief Construction Engineer, Khordha R&B Circle. Dr. Gayatri Patel, Superintending Engineer, Works Department, Government of Odisha. Engineer Lopamudra Mohanty, Superintending Engineer, Bridge Design, PWD Odisha. Engineer Gyan Prakash Nayak, Superintending Engineer, RDQP, PWD, Government of Odisha. May I please request all our presenters to kindly join us on the dais. And now may I kindly request Shri D.O. Taude, sir, to kindly start the session with his opening remarks. Please, sir.
Good morning, everybody. Co-chairman of this session, Professor Sahu, IIT Bhubaneswar, my colleague panelist. It is indeed a matter of very lot of satisfaction that the state government officers are writing a wonderful articles. I have seen that, this good subject, and dedicated session has been kept for it. So we should also thanks IRC for giving a dedicated session for the PWD officers, host state, but unfortunately officers from the PWD or the other institutions, if organizer can request them to take a benefit of the, lot of trouble have been taken by them. One article is written on and so it's a lot of research work has been done, and it is being presented for the benefit of audience. So we are missing the audience. If someone can make an appeal, at least there should be 100 people to listen this wonderful session. There are different topic, but asset management, your state has been doing wonderful work in asset management as well as bridge inventory. Dr. N.C. Paul, we are working on one B.Ed committee. He has always been praising the work being done by the works department officers, and Sarangi, the then Director General, and he's my colleagues. He's from Odisha. So a lot of appreciation, and till recently, this department was headed by engineers. Like Gujarat, Maharashtra, Odisha was headed by the engineering secretary. I think Mr. Nalin Pradhan, and he was a principal secretary for a long time. I do not know when this administrative post of secretary has been given away to the bureaucrats, but it was a very good practice being followed in Maharashtra, Odisha, and Gujarat. Only Gujarat is left with the engineering secretary. Then second presentation is on Shri Setu. I think it is the iconic gateway to the heritage city of Puri by engineer Sundar Madhav Padhi. Then third is again highly technical, the design aid for buckling load isotropic plates under linearly varying compression in plate loading by Dr. Gayatri Patel. I think Gayatri Patel is sitting this way, yeah. Fourth, seismic induced ponding in 3-span simply supported highways by engineer Lopamudra Mohanty. And fourth is condition assessment and rehabilitation of strategic for the bridges in Odisha. I'm equally anxious to listen to you. This is a good work done by all of you in making a presentation. So I request Professor Shao if he has to make any comments. Just introductory 1 minute.
Thank you, sir. It's my honor to co-chair the session with you. So, as you have mentioned clearly that these are very important presentation and field-oriented presentations. So, it's I'm very happy to know that the state government engineers are working on problems related to bridges and roads numerically, statistically, and other analytical tools they are using to design their structures. So let us start the session. We are already late.
So now I call upon my first panelist, Dr. Subhranshu Swain, correct? Yes, properly pronounced. And his topic is asset management in Odisha. Mr. Subhranshu, I think they have Swain. I think that introduction is not given. He is a superintending engineer in the office of Engineer and Chief Civil Cum Roads, Bhubaneswar. Mr. Swain, you have 12 minutes. You have only 12 minutes, and we are starting 30 minutes late. You can finish in 10 minutes. We are highly... No. Take your 12 minutes.
Respected Chairman, sir. Respected Co-Chairman, sir. Sorry, am I audible? Yeah, thank you. delegates on the dais and off the dais. I am really thankful to the IRC team to provide me an opportunity to talk with you and to share the experience rather with you regarding this Odisha Road Asset Management System. I am fortunate to be a part of this system. It was inaugurated in 2014 and I am associated with the system since 2015. And this asset management system, as rightly pointed out by our chairman, sir, has been developed by the vision of Dr. N.C. Pal, Engineer M.R. Mishra, sir, and with able guidance and guidance of CRRI team. Basically, I must acknowledge the inputs provided by Dr. Pradeep Kumar and his team for development of the system. To start with it, this system actually covers what is ORAMS overview, key features, technical steps that we are following, supporting technologies and methodologies, challenges, recommendations that we have faced and we have overcome, and the case study. Case study means the recent assignment that have been entrusted to CRRA team. So basically, ORAMS is nothing but it's a digital platform developed for systematically maintaining, upgrading, and operating physical assets cost effectively. The drivers, as we all know, the requirement is to know the exact position, the exact location, extent, and condition of the assets. Budget scenario, yes, limited budget scenario for preservation, hence justification for demands. Then best utilization of public fund, transparency, decision making, and feedback. These are the actual guidelines which, these are the guiding factors or drivers of ORAMS. So basically ORAMS covers these 6 modules, that is road information system, which actually covers the inventory information and the condition information of road. Then bridge information system, which contains the information of bridges, where it is located, what is the inventory and what are the conditions. And again, I must acknowledge here that the bridge evaluation division of CRRA, they are our pioneer partners, they are helping hands. They are doing the condition assessment of about 304 bridges. A detailed presentation is going to be made by my friend Gyano on this bridge information system. Then payment management system, traffic information system. I must acknowledge IIT Bhubaneswar, who are associated with us for collecting information of about 300 traffic count stations across the state. They have also collected about 50 locations where Excel road survey have been conducted. Then the WebGIS platform, where we can visualize what are the road network we are having. Currently, Odisha is having about 35,000 kilometers of road network, out of which 4,400 kilometers roughly is state highways, 2,700 kilometers MDRs, and rest 25,000 roughly around are ODRs. So this is actually presented over the GIS platform in our WebGIS. If time permits, with the chair's permission, if they allow, I will give you a glimpse of ORAMS website. This is the structure of ORAMS. Actually, if I can show you this person actually shows the inventory information that we are collecting. For collection of inventory, we depend on our field people or the different crossed informations that are collected using some standardized reports. Some formats are shared with the field people. They populate the information. They share these information through email to the central repository. We then convert the information to CSV format and then upload into the database. The database is basically ORAMS uses Oracle database and an application of Bentley called Exor, and we also use the special database of ISRI. And then these information are then pushed to the TIG, that is the Transportation Intelligence Gateway, which actually generates a report for SDM4 input, and these input are fed into the SDM4 software to produce the life cycle analysis of the roads and the maintenance requirement of the roads. These are the basic softwares that we are using, that ArcGIS desktop, ArcGIS servers, Oracle database, and SDM4. Apart from these COTS softwares, we also have some bespoke applications that have been customized to represent the reports of ORAMS. This is the server arrangement. How we have in-house servers in Nirman Soda, where these data are kept, and we are connected through the internet, and the information are available to the public. The key features of ORAMs are centralized data management, condition monitoring, then prioritize models. We have incorporated the PCI values that IRC 82 recommends under the guidance of Dr. Pradeep Kumar sir. And yes, these information are available geospatially to visualize, and mobile data collections are being done. This is what is the pictorial representation of what I have told right now. Then the data-driven maintenance planning and budgeting, ORAMS enables an objective and data-backed approach to identify, analyze and prioritize maintenance needs. The optimal use of available funds we are doing by selecting appropriate intervention, that is routine, preventive or rehabilitation requirement, applying cost benefit analysis by SDM4, and then monitoring the IRI parameters. These are the technical steps actually involved. We generally collect the comprehensive data from the field. The data are basically the inventory information, the condition information, and then traffic and different Excel loads and payment condition. Similarly, the data, after collecting the data need to be refined and they need to be fed into the system. So data preparation, network segmentation is the crucial step. Then the payment iteration model is generated using SDM4. Then based on this SDM4, we find out the maintenance rehabilitation strategies. Some strategies are incorporated to find out the economic evaluation. These steps are discussed as we discussed. Road inventory geometric data we are collecting, traffic data about 300 traffic count stations data we have collected through automated traffic counter and classifiers. Similarly, Excel load data have been collected for 50 locations throughout the state where we find there is a industrial activity going on or mining activity going on with the help of our IIT team. Then the payment structural condition were evaluated using the FWD vehicle of CRRI. NSB surveys have been conducted by using the vehicles of CRRI. Then payment cross details are collected from the field, and environment climatic data are also collected through our field divisions. These are, it's a picture showing the NSB vehicle of FWD vehicle of CRRI. Then the data preparation, yes, for data, yes, whenever you conduct any kind of survey, there is a possibility of error and some cleaning operation may be required. And for that, once data is collected, we go for a rigorous validation, cleaning and then formatting, and then it fed into the system so that the input for SDM4 can be generated. Then the eliminating inconsistency and segmenting the road network to homogeneous section. It is the basic parameter which is required for homogeneous sectioning. If we will do homogeneous sectioning, then SDM4 analysis can be done. Then payment iteration modeling as discussed using SDM4. Maintenance requirement, yes, once the road network is segmented into homogeneous sections and their conditions are assessed, next critical step is to define appropriate maintenance and rehabilitation strategies. These strategies are selected based on current payment condition. So a well-defined set of MR ensures maintenance requirement options ensures that each road sections receive the most cost-effective and technically suitable intervention at the right time. So basically we focus on the routine maintenance, preventive maintenance or structural overlay. The routine maintenance like crack sealing, pothole patching, edge maintenance, drain cleaning, and the triggering frequency is typically annually or seasonal irrespective of payment distress level. Similarly, the preventive maintenance is planned at a regular interval before the payment reaches its structural failure. It is intended to restore the surface characteristics and slow down further deterioration. The microsurfacing, slurry seal, fog seal, these are covered under the preventive maintenance. The triggering parameters are typically the IRI, the rod depth, and PCI values that recommended in IRC 82. Structural overlays, yes, thin structural overlays or thick structural overlays wherever is required based on the IRI parameter, the PCI values we are calculating. And then we perform the economic evaluation through SDM4. The NPV factors, the IRR factors and VCRs are found out. Based on that, prioritization do happen. And based on these findings, we go for the budget requirement assessment and accordingly budget is allocated. Strategy. For each strategy, the following technical and economic parameters are defined. The triggering indicators for IRI and based on the current market rates, we find out the treatment cost. These are the supporting technologies. Actually, we go for functional condition assessment using IRC SP16 is followed, IRC 130 is also followed. Structural evaluation, the Abdoldi code of IRC 115 we follow. Traffic, AVCC or automatic vehicle count classifier or traffic count classifier is used. Axle load we are collecting, layer thickness as discussed we are collecting it from field, and then GIS based inventory mapping is done. Challenges, yes, we have to strengthen our organization by continuously giving them training on ORAMs. What are the parameters we have to look after, how the reports have to be populated, how it is to be maintained and stayed. This has to be trained to our people. It's a continuous practice. Again, we have to conduct regular training on SDM4, ORAMs use, similarly prioritize cost benefit, how to recognize what is my priority, my basically the NPV value, the IRR value, one need to understand how we are going to use it for prioritizing our road network. Similarly, continuous monitoring through NSB FWD, we are thankful to CRRA, actually they have been doing this condition assessment and strength assessment of roads using NSB FWD since 2014. To go ahead with the case study, we have assigned this activity of 14,016 kilometer, roughly 22,866 lane kilometer of road with CRRI. They have conducted the condition assessment. They have conducted the strength assessment using FWD, and inventory informations also at some point of time we have collected from the field side, and also CRRI is helpful in conducting this information. Then the broad objective that have been assigned to them is to do the technical services for updating ORAMs also, and development of annual maintenance plan using SDM4. The basic methodology that have been followed is the information, collection of information using NSB, the condition assessment, then the strength assessment and PCI value. Yes, IRC 82 2023 has been referred to. It is a product developed by CRRI's Pradeep Kumar sir. They have actually very helpful in getting the PCI value, and based on that PCI rating have been done. Then for any road stage having PCI value less than 80, they have conducted the FWD data. These information are fed into ORAM system, and then along with the traffic information, axle load information, we have developed the annual maintenance plan. Roughly about for maintenance proposed for on-constraint budget scenario, it was around 1400 crore. This IRC 82 has been followed. Based on the findings of CRRI, the condition assessment, the routine maintenance requirement was about 5%, the preventive maintenance was 9%, minor rehabilitation 24%, and periodic maintenance was 61%. The preventive maintenance, then these are the maintenance treatment that we have adopted for SDM4 analysis. The sample PMS output looks like that from stage X to Y. This is the kind of treatment that is required, what is the cost of it, and what is the IRR value. Similarly, the routine maintenance output is like
2
this.
minutes, only
Yes,
2 minutes.
Finishing it up. So these are the sample output. This is some pictures from our field survey, the mobilization meetings that have been conducted. Apart from the above, we have assigned, as we have discussed, about 304 bridges condition assessment was also assigned to CRRI. How we have developed 304, actually there are 4,900 bridges across the state under PWD, but while doing a Reiki kind of survey, our field people reported that about 258 bridges are in distress condition and 46 are in old, more than 30 years old. So these bridges have been identified and they have been given to CRRI for their detailed condition assessment. Some pics from the condition assessment of bridges. So this is what I want to tell. I must acknowledge CRRI team, IIT team, Bentley team and ISRI India for the support they have provided. If time permits, sir, can I show our website or?
Yes, yes, you can show. Take 1 minute.
1 minute. Thank you, sir. It's not happening. It's not happening.
Internet
Oh,
connectivity.
internet connection issues.
छोड़ दीजिए. Let us.
ठीक है.
Okay, thank you.
Thank you, sir.
So, Mr. Swine, it's really, your project is based on the study conducted or investigation done by CRRI. So I really thanks Dr. Pradeep Kumar for a wonderful study, and definitely I just take a 1 minute to share my previous experience. Our assessment was road based on the bar chart prepared by the works department. If red color is shown, means road is in bad, green is good. Periodical renewals were decided based on the bar chart. If I'm used to go to see the road, that is all right. Otherwise, whatever action tells her this section is in bad condition, he is my authority to tell me. Pandey sir and my colleagues are there. They were in our office, our based on your assessment. But the road inventory, when National Highway, Mr. Gadkari talks about the demonetization or equity dilution, some outside part concessionaires are coming to take over the roads. They are maintaining the road very scientifically. If I consider that road is in bad condition, unless it is proved scientifically based on the IRI, then some cracking, percentage cracking, he will never agree for taking over the maintenance. Otherwise, in our days, 25 millimeter bituminous concrete or 25 millimeter HDBC is recommended by the chief engineer NH. So we must, and my friend Mr. Salunke, the secretary PWD is here. He has been doing road, I think during last many years, he has done a lot of research on it. He has prepared the document, and Maharashtra has also adopted the scientific evaluation of the road. And with the basis of scientific inventory only, we able to assess our requirement of the future maintenance within the limited resources. So this is being an important subject. I request, the floor is open for few questions. If someone has something to add. Anybody can raise some queries. Two secretaries are talking. Secretary of the Government of India and Secretary of Maharashtra PWD has raised the hands. The person who are Pandey sahab, de dijiye to.
Chairman sir, I found that the periodical renewal that they have actually done in some of those roads while discussing the bifurcation of the various types of renewal and the maintenance work they are doing. The thickness of the wearing coat was 30 millimeter bituminous concrete. So I would like to know whether it is varying with the terrain conditions or the drainage conditions or any other parameters, or it is constant that they are adopting all over the state. And what is the advantage or the likely renewal cycle with this intermediate thickness instead of 25 or 40 mm if they are using 30 mm? Thank you.
Sir, whenever we are thinking of renewal quote, actually we are going for this FWD also. So whenever the FWD data is baking up with the minimal cross thickness, we are adopting that only. I don't think 30, if they are providing 30, must be the structural evaluation data must be baking it up with that. But throughout the road, we are not, throughout the network, we are not exactly following 30 mm. It is generally backed up with this FWD findings.
Hello. Yeah. Just one question, whether it was restricted to bituminous payments or you have covered the concrete payments as well?
So the present assessment is on bituminous payment.
Okay.
But
But since you are doing the, I mean, lot of survey data and collection and analyzing it is, I mean, insisted sometimes, many times, the ministry and NHI, everybody, that NSB should be collecting the 3D data for crack measurements. How effective it is when you are collecting a 3D data of the crack of a pavement? I mean, the depth of the crack. How can it be assessed and analyzed for assessing the condition of the pavement itself?
sir,
How much it is distressed and how much rectification or what kind of rectification it is required just based on the NSP data. Whether you would like to revalidate with the physical inspections or it can be done with NSP data. Just that's it, the clarification I would like to know. Are your views on that I would like to know. Thank you.
so actually, as I told earlier, this activity is purely based on our condition evaluation of this flexible payment. And yes, regarding the depth of the crack, I think the system is not equipped enough to find the depth of the crack. But if Bhubaneswar sir, Pradeep Kumar sir or Pal sir may highlight on it.
Yeah, thank you, sir, for this question. Actually, presently, we have developed the PCI model, which is not considering the severity level. So what you are talking about the depth of the cracks. So in the present form, we are just seeing the extent of the crack, not the depth of the cracks. But if you go the international practice, the ASTM standard, so it covers the severity level also, that is the depth of the crack. But presently, to start with the PCI value, we are not considering the depth of the crack. So this is the present scenario.
I request Mr. Salunke to share his experience as it is a, so you can take a mic and share your experience. They have done extensive work in Maharashtra and it is an in-house study.
Sir, in Maharashtra, we do not do NSV assessment. महाराष्ट्र में हम लोग प्योरली फिजिकल असेसमेंट ही करते हैं.
Dr. Paul, do you want to raise some queries or supplement?
Sir, just to supplement what you have initially also told, the initial model was based on Excel spreadsheet and strip map concept of red, green, yellow, on which our maintenance funding was done. Subsequently, this automated survey and SDA modeling has been carried out, and this IRC 82 maintenance requirement modified published in 2023. That's a research work of Dr. Pradeep Kumar. If you see that code, that entire code is based on PCI related thing, and the PCI has been evaluated first time quantifically. Earlier it was qualitative PCI, good, very good like this. First time this is a quantification of PCI based on 5 or 7 distress parameter, cracking, rotting, leveling, edge break, all those things. So in addition to PCI functional requirement and structural evaluation FWD data, we decide whether the overlay required or a wearing course is there. And these specifications are purely based on IRC 82-23 recommendation. That's all.
Okay, sir. Thank you. Now we will switch over to our next presentation. Presentation by Engineer Lopamudra Mohantu. The subject, seismic induced ponding in 3-span simply supported highway bridge. You have 10 to 12 minutes only. Please.
respected dignitaries on and up the dais, a very good morning to all of you. As you see on the screen, today I am going to present on the topic seismic induced pounding in 3-span simply supported highway bridges. So, as we all know that bridges are the main lifeline of our highway network, and in India mostly the simply supported bridges are found, reinforced concrete bridges are found. So, these bridges are generally much more vulnerable to the seismic induced damages and collapse because they are having a discontinuity in the form of expansion gap. So, today in this topic, I am going to present about the pounding phenomenon, then the objective of our study, and also I am in this paper I am presenting the numerical modeling of a RC breeze, 3-span breeze, simply supported breeze, existing breeze. And through that numerical modeling, in OpenSeas the modeling has been done, and through that model I can analyze the seismic analysis of bridges such as frequency analysis, nonlinear time history analysis, parametric study also have been done, and also the fragility function using the IDA approach has been also done, which is a probabilistic approach to find out the probability of pounding in different bridges. First of all, we should know what is the process of pounding. Generally, the pounding is induced in the bridges due to the out of phase vibration and also due to the differences in dynamic characteristic of different component of the bridges. And whenever the seismic vibration occur due to the insufficient at rest separation in the bridges, and that means whenever the expansion gap is not sufficient to accommodate the relative displacement of the component, then pounding occurs. And generally in case of multi-span bridges, this pounding phenomenon occur due to the multi-span simply supports, then lack of continuity, spatially variation in the ground motion, different fundamental frequencies of the different peer or different components, and also due to soil structure interactions. And the structural damages in bridges generally are in the form of concrete swelling at the joints and also local deck damage, and the damage to the column bends and damage to the restrainer and bearing also, and abutment also there is abutment, near the abutment also there is much more damage and collapse, and mostly plastic deformation and local cracking and crushing occurs. These are the structural damages. Whenever a seismic vibration will be given to a spatial breeze. So, these are the typical seismic induced damages to breeze after some known in the past previous earthquakes. So, these are the picture of some damages like near the expansion joint, near the abutment, and also some restrainer failure, and this picture is for the breezes of China in the Wenchuan earthquake in 2008. Also many earthquakes are, if we find out from the history, we can find out many earthquakes in which a lot of breeze collapse and a lot of breeze damages occurred. Mostly in 2008 in Wenchuan earthquake in China, the collapse occurred due to pounding between the girder and the abutment, and the adjacent girder are the blocking stock. And also in Chi earthquake in 1999 in Taiwan, the collapse occurred due to the hammering at the expansion joints in some bridges. And also damage occurred to the shear keys and bearing and anchor bolts. And in Northridge earthquake in 1994 in Los Angeles also, pounding occurs. The picture shows the pounding failure of the bridges, some bridges in Los Angeles in 1994. The first picture shows the collapse or damage near the abutment, deck and the abutment, and the second picture shows the fall down of the deck itself due to the damage in bearing. And these are the pictures of the bridges from India in Bhuj, 2001 Bhuj earthquake in Gujarat. The first picture shows the Surajbadi highway bridge and the second is the India bridge of NS8A. And in these cases the pounding failure also occurs and the pounding of adjacent simply supported spans and failure of girder ends, superstructure dislocation and bearing damage occur. Mostly these are formed due to pounding. So the main objective of this study is to found the pounding response under different seismic condition and various gap size. Gap means the expansion gap size. If the expansion gap size varies, then accordingly the response varies. And second objective of the study is to effect of non-linearity in piers, bearing and abutment on pounding. Third one is the pounding probability. So what is the probability of pounding in terms of deck relative displacement by fragility analysis also. Fragility analysis which includes IDA method. So in this paper I have modeled existing bridge of our strait in Kendrapada. This is the bridge of Gobbari bridge near Millan More, which is having 3 span of 35-meter span. It is a simply supported bridge and is having a rocker bearing, roller rocker bearing, and the box girder superstructure is there. This bridge is designed in open seas. The finite element model of this particular existing bridge has been done in open seas and the analytical and numerical analysis have been done. These are the detailed description of the existing bridge, which is a 3-span simply supported bridge. 2-cell box girder deck are found, and in this case the expansion joint is only 40 mm. 6 bearings on each pier cap resting over 6 pedestals are found. Then carriageway over the bridge is having a 7.5 meter, the total width is 8.45 meter. And for column, the concrete grade is M25 and the steel grade is Fe 500. Pile foundation with rectangular pile cap of size 12.3 and 12.3 meter has been used. And fixed and expansion type bearings has been alternatively used in the bridge. So the 3D and Fe modeling of this existing bridge has been done in open seas. And these are done, the modeling, total modeling is done in one-dimensional elements, 3D modeling. And the non-linearity also incorporated in the model in bearings, in pier column, in abutment, and a specialized impact element having 0 length has been incorporated in the model. And some assumption has been done, like the assumptions are piers to be fixed at the bottom, bridge decks to behave linearly with rigid edges. The edge of the deck has been assumed to be rigid. And in the model, the mass of the bridge deck, girder and all other components of the superstructure are combined in nodes. So description of this 3D model is here: pier, pier cap, bearing and abutments. In pier, it is elastic force beam column element method element. The open seas different elements are there which are very much suitable to model the bridge and having nonlinear characteristic also. The pier cap is elastic beam column element in the model. Then bearing, 2 nodal link elements. So these are the modeling of pier and caps. Then modeling of bearing has also been done, which is alternative hinged support and also fixed support. These are the modeling of the bearings. This is the diagram representing of the bridge model showing bearing and impact element. This is the modeling of pounding. The pounding has been modeled by using a zero length impact 3D element, and the stiffness parameter has been used, energy distribution has been used also. This is the FE model of the breeze. Then seismic analysis of the breeze has been done for 3 models B1, B2, B3, which are having the time period difference, the T1, T2, T3. Then frequency analysis has been done, different modes has been calculated. This is the nonlinear time history analysis of the breeze. In this analysis, as we are we find that this shows, the graph shows the displacement versus time graph, and the displacement versus relative displacement with the pounding force also we can found. And the probability of damage of the deck edge is more also lesser with respect to gap size, and with respect to the PGA value or the value of the seismic vibration, the value of the pounding also differ. These are the history curve analysis. The size of, this is the most important case, the effect of size of expansion gap on pounding we can analyze from using this model, where the pounding force varies with the gap size. Effect of time period on pounding. Then fragility function analysis. The fragility function analysis is the probability analysis in which we can find out the probability of the pounding with the different parameters. This is the idea for breeze model. 3 models are there for breeze model B1. IDA curves are been found, which can be used to the extent of probability, or how much will be the probability, the percentage of pounding in case of bridges with respect to relative displacement also. These are the IDA curves for the 2 models B1 and B2. So fragility function on basis of IDA method, this is the most important curve which has been found out in the study. This is the pounding probability with respect to different value of the, with respect to a PGA value, that seismic acceleration value, and different gap size has been here, 30 mm, 40 mm, 50, 60, up to 80 mm expansion gap have been provided in the model, and the analytical analysis has been done in OpenSeas.
Lopamudra, just conclude your, yeah, that's
Okay.
conclude.
So the main conclusion in the model and the analysis, the main conclusion is that the expansion gap of 40 mm, we have analyzed the model for all the gap size. So the expansion gap of 40 mm is not sufficient for a long breeze having span more than 35 meter, even in areas having probably lower the PGL at 0.3 G values. And the maximum pounding force and damage increase with a decrease in expansion gap of size up to about 50 millimeter, and it is independent of the expansion gap of size when smaller than 50 mm. And maximum pounding force linearly increases with increase in peak ground acceleration, that is OPBS. When the ground motion, the value of the impact seismic and vibration will increase, then obviously the pounding force will increase. Then to reduce the damage due to pounding, the gap of multispan simply supported bridge should be more than 50 meter. It is the conclusion from the analysis of the study. Then the chance of pounding increases with the increase in pier heights. Whenever the pier height increases, the pounding force also increase, and with decrease in the ratio of the time period of the 2 piers, that is P2, P1, the fundamental period is shorter period, P2 is the fundamental period of the longer period, the chances of pounding will increase. And from this conclusion also we have some future scope by using this model. In the present study, the structural interaction and the soil structure interaction has been missed in the study, so that can be incorporated in future study. And also the breeze can further be examined for spatially varying ground motion and skew bridges.
Okay, I think you can now finish.
Thank you.
Okay, thank you. Very good presentation. You can stand there. Basha sir has some suggestion, or he want to enter. Can you give someone a mic to Basha sir? Till the mic is given, Lopamudra, it's a very good presentation. fundamentally we had a feeling technically that 1 millimeter of expansion gap is required for 1 meter of span. If it is a span is 35 meter, 35 millimeter gap could have been enough. You provided 40. Fundamentally we go. So you have proved that with your analytical that 50 millimeter gap is required. So the expansion joint provision, so whether 40 millimeter, 50 millimeter, it's good. Discussion is required, deliberation is required. I think this is a good subject you have given to IRC also. So they can, what should be the expansion joint gap for the bridges if my bridge is 50 millimeter, 50 meter, gap could be 60 if you go with the analytical, with your theory, ponding theory, then could be a larger expansion joint is provided. This is a good study, sir, with this.
Yeah, just I will add what the chairman has said. I mean, honestly speaking, you should have sent this paper for the publication in the journal, because this needs a very wide and wider audience. And secondly, we are very old persons. I mean, in our time, we used to determine the expansion joint based on the span length and expansion coefficient of expansion contraction. Okay, so you have given a new, light that expansion joint is not mere contraction and expansion. It has got strong relationship with earthquake. And my suggestion is that this study should be carried out, because we are in zone 3, mind it. So just imagine if in zone 3 you are recommending for a 35 meter span, 50 millimeter gap, what would happen in zone 5? So these, the relationship of this span, relationship of type of structure, simple supported or continuous, relationship of the different types of foundations, and above all, the different types of, category, zone 1, zone 2, zone 3, zone 4. So it needs a quite big research area. Yes. Kindly continue this, and my hearty compliments.
Thank you, sir.
For an eye-opening paper. Thank you.
Thank you, sir.
Sir, excuse me. Sir, I am BM Thakur. I am SC in Public Works Department in Himachal. I want just one clarification that in the lecture it is said that 50 mm gap should be there. It is irrespective of span or more than 35 meter?
No,
suppose if spans are 15 meter or 19 meter, same gap is required, 50 mm? Or it can be lesser, for lesser spans?
No, sir, actually...
This is a case study of 35 meter span. This is based on the analytical study she has done for a span of 35 meter, and she has established 50 millimeter. If I am correct, then that is for...
If span is of 50 meter or 60 meter, then we need larger gap. Okay, thank you.
So let me supplement to what he answered. Actually, her model is based on a twin cell box superset, twin cell box 3D element up to a typical pan of simply supported. We have continuous 3D continuous end diaphragm pump, and we have inclined superstructure, guided superstructure, various span. Her parametric study on this variety of span and from zone 1 to zone 5 with soil interaction is her current work. I think that will be continuing and will be contribution to IRC.
Hello. First of all, I must thanks to the new dimension of research which you have taken up. You have restricted your research up to expansion joints only, and you have also shown the various probabilities. I would suggest that the distresses of any structure occurs when the natural frequency of the structure and the whether traffic or seismic vibrations or amplitudes caused by them matches with the structural, natural frequency, then distress occurs. So whether this dimension can also be further studied and extended, that what should be the natural frequency of each component of the bridge with respect to the seismic vibrations or amplitudes or the traffic which is going to ply on the traffic, then probably we can redesign our structures, or we can give guidance to the IRC for defining the minimum dimensions of the structures, so that the loss of distresses could be reduced. So this concept is being used in the design of foundations for vibrational loads, and there is a specific MTech course in the MSCT Bhopal which I have attended, that's what I am suggesting this. This is a very fundamental study and can help in a big way for restoring the, arresting the divergence in the structures. Thank you so much.
Thank you, sir. Now we can switch over to our third presentation. Presentation by Engineer Sundar Madhav Padi, Chief Construction Engineer, Khurda, R&B Circle. Mr. Padi is presently Superintending Engineer of Bhubaneswar, was earlier Superintending Engineer of Bhubaneswar R&B Circle. He also worked as an Executive Engineer in Puri, Odisha Bridge Construction Corporation. So with this brief, what he has, Mr. Padi, you can proceed with. Mr. Padi, you have strictly 10 minutes. Please.
Thank you, sir. Sir, namaskar to all, sir. Respected Chairman, sir, Co-Chairman, sir, respected delegates on and off the stage. Actually, I am feeling very honored and privileged to be here to present before you regarding a topic which is very close to my heart, and that too before Dr. Pal sir and Dr. Sri M.R. Misra sir. Sir, before taking most time, I am coming to the topic. Sir, actually this project, before discuss, without any nitty-gritty of the technical details, I will first tell why this project was necessary in Puri. Sir, actually Puri, it is a abode of Lord Jagannath, and people, lakhs of pilgrims from throughout the world and from the country are coming to the Puri, and particularly in Saturday and Sundays, if you can see, it is the Bordanda, including all that connecting roads to Bhubaneswar, it is really horrible, it is very congested. So there was a thought how to avoid this congestion, because people are coming to have darshan of Lord Jagannath, but for those people, the local people who are generally doing their jobs, to and fro movement for the local people is very became difficult. So there was a plan to segregate the pilgrims who are only coming from the darshan from the local people. So this was a major idea behind this. Already, sir, I have told this. This point, sir. Actually, this is the comparative analysis from route 1 and route 2. In route 1, this is the generally route, is an old route. We are going from Harakushthampur Chaka through Batamangala, Ottanala, Bardand, and then to Temple of Lord Jagannath. But by introducing Sri Setu with trumpet interchange along NH 316, the travel time is already mentioned here, sir. It is travel time has been reduced, though though it is a slightly longer route, but the travel time is reduced, and particularly during peak hours, the travel time can be reduced up to 1 hour. Because people, after traveling this, again they have to stand in queues for hours together for have a darshan. So to provide them a seamless and a thorough movement without interruption of the local traffic, this project has been planned nicely, sir. So here we can say that the trumpet interchange has been introduced along NH 316, so that the traffic of the NH will not be interrupted by providing this after construction of this project. We have provided ascending loops, descending loops, service roads through NH, and so slip roads, acceleration and deceleration zones along this trumpet interchange for smooth movement of people to and from the temple. And people can also directly go to those people who are directly want to go to sea beach, they can use the national highway. But those people who are coming from Bhubaneswar and are trying to go to have a darshan of Lord, they can take the Sri Setu slip road, and then after this they have to enter this, sir. So there is a after multi-level car parking, and the end of this project, this car parking is a provision of 1,400 four-wheelers parking provision. So there is a drop-up and pick-up point near this only, sir. If people will come from buses, they have drop up near this Jagannath Vallabh Pilgrim Center, the name of this multi-level car parking. And those who are coming with four-wheelers, they can enter at the second floor level of the Jagannath Pilgrim Center, Jagannath Vallabh Pilgrim Center. They have a parking facilities there. And after parking the vehicle in the multi-level car parking, they can use this route, sir. One Sri Marg is there, which is from this starting from this Jagannath Pilgrim Center near the roundabout and ending to the north Dwar of Lord Jagannath Temple. So these three Setu is not only one project. If we can combine, integrate three projects, Sri Setu, Jagannath Vallabh Pilgrim Center and Sri Marg, then the real project or functionality can be realized, sir. So this is another view, sir. So from this trumpet interest, from this roundabout and JBPC, one can go parallelly to Bardand. One road is there, Sri Marg, which is a parallel road to Bardand, and where the Bardand, one can go through the Singhadwar or the east gate, and while one is going through this Sri Marg, they can enter into the through the north gate of Lord Jagannath. So this is the idea behind this project, sir, to have a seamless service of the people. And then, sir, actually based upon the...
You have 2 minutes.
Okay, sir. Sir, actually based upon the site conditions, we have provided some components, like when the trumpet interchange is there, actually the soil condition was very poor. So we have proposed for a ground improvement, sir. So ground improvement we provided because liquefaction was there. So PVD provided. So with mandrel we have reached this PVD up to 8 to 10 meter depth, so that the pore water pressure can be reduced by drainage of the saturated layer up to the, so that the consolidation can be accelerated. Because, sir, we have only 6 month period for completion of this embankment area, but depending upon the soil condition, the natural consolidation requirement, time requirement was more. So we have provided PVD for a ground improvement, so that we have completed this within 180 days, that is 6 month period, sir. Also, we have in that area we have provided a gabion structure instead of concrete fascia, because to accommodate differential settlements. And also we have watched the settlement process and settlement time and pore water pressure by installation of piezometers up to the top of the construction. This is about, sir, we have provided in the triangular pattern 1 to 1.5 meter prefabricated vertical drain provided, sir. These are the, sir, this is the gabion structure we have provided in the trumpet interchange. Then, sir, after a gabion structure, the gabion wall, this is the, sir, gabion wall, nothing else that. And a geogrid is also provided. Geogrid provided, sir. Non-woven geotextile also provided along with the gabion wall. Other structural component like boasting girder bridge, sir, 162 meter span boasting girder bridge we have provided along the NH 316, because, sir, while we have applied for no objection certificate from NHAI, they have said that they will not allow any intermediate pier in between their national highway. So we have provided boasting girder with 62 meter span, sir. Then also the roundabout portion, what we have said earlier, we have provided voided slab superstructure in that area. Then, sir, also the embankment structure with sufficient relief vents we have provided. And another major challenge in this project was, sir, we have to keep the heritage importance of the city along with provision of Kalingan architecture in so many places. That was a major challenge. One image is also missing. We have provided one viewing tower come welcome gate, in that project, which is in the finishing stage, sir. In that, we have provided two huge towers in either end of the road and connected with the interconnecting slab at the two levels, and we provided a temple-like structure with the beautiful Kalingan architecture by using Khondolite stones. And also in Jagannath Vallabha Pilgrim Center also, we have used Khondolite stone with murals, models to depict Kalingan architecture in many places.
Mr. Paddy,
Sir.
just now.
Okay, sir. So, the main idea behind this is only to decongestion the Puri town and smooth darshan of Lord Jagannath. And I think after construction of this project, the purpose has been solved to a large extent. Thank you, sir.
Thank you, Mr. Paddy. Very good presentation on the bridge constructed. That is, NHA stand was correct. Today you provided a 62 meters span. That is in the public interest. So you have a total 62-meter span under the bridge. So definitely that structure, that road will never get congested. So you have taken a right decision. I should have suggested you to take a 70-meter. It's a long time. Your road might have to be widened to 8 lane in future. So if you are providing the wider span, means scope for the, and this gateway to the temple of Lord Jagannatha. So whatever you do, that will not be adequate. So it is a good. Your structure looks elegant, so my compliment. With this brief remark, if anyone has any comments or any suggestion.
Mr. Paddy, a small point. You have mentioned that your Bhadak part was consisting of a voided slab structure, which is a circular in plan. So it is not a simple structure at all. So have you adopted any particular software or tool for calculating this detail of the product structure? Thank you.
Sir, sir, may I audible, sir?
Hello, Mr. Paddy. Sir. What is the height of the Gavin wall we have given there?
Sir, height we maximum adapted 9 meters, sir. 9 meters.
Sir. Then in between the Gavin wall and the subgrade and the road, you have given what is the gap you have given for the seepage and other and trap of the water and other thing. What is the gap you have given there?
Sorry, sir.
For the Gavin wall and the subgrade, you must.
Mic, sir, closer.
What is the gap you have given? What geotextile membrane you have given?
Sir.
In between the cabins and the road structure, so subgrades and sub-base, base, bitumen scores, whatever the thing, that the gap you must have given for the infiltration of the water or the rainwater through the gabions or to the below the gabions.
Sure.
Up to the must have taken to the subgrade level, scour depth level below that.
Yes,
What
sir.
is the width you have kept and the width of that gap where you have given the geotextile membrane?
Sir, Gabion wall and the embankment structure, embankment portion, we have provided non-woven geotextile for drainage of the water. Also, geogrids we have provided on each layer at top and the bottom. Because Gabion wall provided on either side of the road, sir, embankment road, and non-woven geotextile were provided for drainage to act as a separation as well as a drainage layer, sir.
No, that
Sir.
thing is essential, but what is the width of the that membrane you have given?
Sir, width of the membrane.
You are not following me, I think.
Sir.
I will talk to you.
Okay, sir. Thanks.
Now we'll switch over to our fourth presentation. Dr. Gayatri Patel. Gayatri Patel has done PhD. She is presently Additional Chief Engineer Design, ENC Construction it is the ENC Civil Roads Division Zone. She has worked in various divisions. She was also Assistant Engineer of National Highway under National Highway Division, Jarsaguda. And she was a Superintending Engineer at Bhubaneswar, Superintending Engineer Building Design, and now Additional Chief Engineer Design in ENC office. With Gayatri, you can proceed. You have 10 minutes.
Respected Chairman Sir, Co-Chairman Sir, and all the dignitaries present over here, my namaskar to all of you. Thank you very much IRC for giving me this opportunity to present this paper at this forum. Today I am going to present on design aids for buckling load of isotropic plates under linearly varying compressive in-plane loading. This is one of my research paper. Recently I have presented here in the 64th annual technical session in Institution of Engineers, Odisha. These are the contents. As all of you know, plate element is a thin, flat structural element and it derives its strength and stability from its geometric shape, and it is designed to distribute loads and forces efficiently. It provides high structural stiffness, supports stability and durability, withstand significant stress and deformation. Thin plates allows lighter construction and efficient material use. These are some of the applications of plate elements. Plate elements are widely used in all civil, mechanical, aerospace and marine engineering structures. In civil engineering, it is used as wide-span roofs, plate girders, bridge deck, and members of trusses, arch ribs, thin wave plates of girders, and in folded plate girders structures. Then come to the significance of this study. In practical field applications, these structures are often subjected to different type of non-uniform load due to the earth pressure, temperature, water pressure, wind loads, earthquake loads, etc. And as a result of which this structure experiences non-uniform in-plane stresses for which large transverse displacement occurs, and it leads to buckling failure. As buckling failure is a very primary key design consideration for ensuring the safety and integrity of the structure, it is critical because it can lead to the sudden collapse without prior material yielding. Then review of literature. Many researchers have presented exact solutions on buckling, starting from Timoshenko and Gere in the year 1961 to Wang et al. In the year 2007, considering different type of loads, uniform loads, partial edge load and linearly varying load, and using different analytical and computational method. In composite material also, many researchers have presented the buckling load results, considering all these three types of loading, and they have considered also different type of methods. This literature reviews reveals that the most of the research works have focused on development of suitable methods or models for obtaining the critical buckling loads. And in order to fill the above research gap, various design charts in the non-dimensional form are developed to find out the critical buckling load at the time of preliminary design. Here, in this study, a rectangular plate element of dimensions A and B and thickness H has been considered here with linearly varying in-plane load applied at the two opposite ends, x is equal to 0 and A. And here the linearly varying load is expressed in the equation form Nx is equal to N0 1 minus gamma y by B. Here gamma is the load factor. By changing the gamma value from 0, 0.5 and 1, we can get the three types of linearly varying load. As when gamma equal to 0, it becomes uniform load, gamma 0.5 it is trapezoidal, and when gamma equal to 1, the load from converges to a triangular load. Then the governing equation for buckling is K minus P kg Q equal to 0, where this is an eigenvalue equation and the lowest of the eigenvalue is the critical buckling load PCR. Here K and Kg are the element stiffness matrix and geometric stiffness matrix. Element stiffness matrix derived using the material property, and geometric stiffness matrix derived using the load component. Here load has been considered three types of load: uniform load, triangular load and trapezoidal load. In order to solve this eigenvalue equation, an 8-noded isoparametric element has been considered with 5 degrees of freedom, and the non-dimensional parameter has been considered as PCR B square by D, where D is the flexural rigidity of the element. It depends upon the material properties. Here we have considered two types of support conditions: simply supported, all sides simply supported, and all sides clamped. This is the representation of the procedure developed in the flowchart method. Then come to the result and discussions part. Here in finite element method, a convergence study has been conducted to know the mesh size of the element. And here the buckling load of simply supported and both the support conditions has been taken into consideration, considering an uniform load, and the results are presented starting from mesh size 4 into 4 to 12 into 12. And it is observed that the result converges at a mesh size of 10 into 10, and with the further increase of the mesh size, the result does not significantly alter. So a mesh size of 10 into 10 has been considered throughout the analysis. Then come to the validation. As all of in the literature review we have seen, many researchers have published buckling results. So we have compared the results of Kang and Lisa. The paper has been published in the year 2005. They have considered the linearly varying in-plane load for plate element. That result I have compared with my present FEM code, and it is seen that the results are well compared with the previous study. So the computer code is validated, and all the further results have been computed using this code. Then these are the design charts. These design charts have been presented in graphical representation, buckling load in y-axis and aspect ratio as x-axis, that is lambda versus A by B. And here we have considered three types of thickness ratio, B by H, 10, 20 and 100. In order to include all the dimensions, any kind of dimension and thickness, we have taken into consideration three types of thickness ratio. And also we have considered three types of loading, as I have shown in my previous slides: uniform, trapezoidal and triangular. This is for simply supported boundary conditions, and this is for clamped boundary conditions. So total 6 design charts have been developed, and from these design charts the buckling load has been calculated, and it is the lambda value has been compared with our practical field examples. The validation, how we have done the validation. We have considered 6 examples, 6 practical examples with 3 each boundary conditions, and we have taken the difference dimensional value of length, width and thickness, then converted into the non-dimensional form, as our design charts have been drawn in non-dimensional form. Then 6 practical examples of 2 each concrete, aluminum and steel have been considered. All the dimensional value have been converted into non-dimensional form, and the aforementioned dimensional values with those aforementioned non-dimensional value, by linear interpolation we have to calculate the lambda value, and using the expression lambda d by b square we can obtain the PCR value considering the actual dimension of the example. This is the conversion of PCR. Lambda is our non-dimensional value and D is the flexural rigidity, and with that design chart we can calculate the critical buckling load of any material, that means aluminum and concrete also. The design chart have been developed considering steel as a material. Thereafter the value of PCR of these examples are calculated using the computer code, and both are compared. Here we can see that in the last column, the deviation percentage of the PCR value as obtained from the design chart and the code is within 5% limit. So, the conclusion is the suggested design charts will be very much helpful for the designers to determine the critical buckling load of simply supported and clamped plate of any dimension, any isotropic material and any type of linearly varying in-plane load with minimum error at the time of preliminary design without going through the tedious computations. And this innovative approach of creating design charts can also be prepared for plates of other boundary conditions, for cell panel also, and with different type of loading also. I have prepared design charts for clamped cylindrical panel also, and this paper has been published in International Journal of Structural Engineering. Here also we have considered 10 examples and all the deviation percentages within 5%. These are my publications. This is the conference, these are the conference papers. Thank you.
Thank you, Gayatri. Really very highly technical presentation. And as you have already published in the International Journal, I suggest you, Mr. Sarangi, you can send it to a journal of ING IBSc. We are quarterly, we are issuing, publishing, and highly technical issues are discussed there.
Yes, sir.
Very highly technical.
Yes, sir.
Again, I'm a governing council member for Indian Institution of Bridge Engineers.
Yes, sir. Yes, sir.
My friend Paul is also connected. So there also we'll see that there will be wider discussion on your paper. If it is accepted by institution like an IRC, these charts can be adopted. This should be become a part of our standards, subject to wider discussion, deliberation, acceptance by the authorities. You are doing wonderful job, but it should not restrict it to the journals and the discussion. Again, I repeat the statement of my friend Basha sir. It should have been published in the IRC journal. So there was a wider discussion amongst the senior members of the bridge fraternity. But nevertheless, it's a wonderful presentation, sir.
Sir, we are just discussing that her paper is based on in-plane loading, buckling under in-plane loading for isotropic case. She has taken, the stiffness he has taken ETQ by 12, 1 minus nu square is purely for isotropic case. In case of bridges actually, whether it is a well cap or a pile cap, they are the plate actually, thick plate. Like in our standard code design, the pile diameter is 1, we are giving a minimum 1.8 as pile thickness. But if the basis of this thickness are based on certain criteria, what I will suggest to her, take these as living example, pile cap, well cap, under in-plane loading, lateral, that will be mostly from the water current and other lateral loading, and try to design those, what could be the thickness under critical bowling for maximum amount of this lateral in-plane loading, in addition to the vertical loading. That could be applicable to our IRC codes.
Yes, sir. Yes.
Basha sir.
Actually, my compliment to you, only thing that as already the chairman has expressed, my view is the same.
Sir.
This must come to practice. And I tell you, way back in 1984, I remember I was assistant engineer in the PWD, and we have checked the design of well cap on Brahmani Bridge near Patrapur Ghat, which was the superstructure was post-tension pre-stressed balance cantilever. It was done by Gammons, and the well diameter was 9 meters, and we have checked the well cap on the plate theory. Yes, so sir. This has got a very, and in your conclusion you have already said that it is not restricted to steel. Yes, you are sir. Comparing to concrete, you are to aluminium.
Yes,
so
sir,
you must, so the thing is that, as rightly said by the chairman, these theories, I mean, I remember very categorically that during that point of time, Gammon used to have that kind of a structure throughout the country, and the well cap was designed as the plate theory. Mind it, in Odisha at that point of time, up to 1984, we have never approved a well cap with plate theory. This was the first, way back in 84, but again we have forgotten. So now it should come back. That is my suggestion.
Thank you, sir. Thank you. Now we are running out of time. If someone have only one question, one intervention or recommendation like that. Okay, thank you very much. So our last presentation by Mr. Gyan Prakash Nayak, Condition Assessment and Rehabilitation Strategies for Bridges in Odisha. Some case studies, yes, really, that is very important. By the time he takes the mic, Mr. Gyan Prakash Nayak is a superintending engineer under research, development and quality promotions wing under the Works Department, Government of Odisha. He is working in areas of quality inspection, of infrastructure project, non-destructive testing method for evaluation of structures, testing and analysis of material and mixes, and condition assessment of structures. Mr. Nayak.
Good morning to all. I will start my presentation with warm welcome to all my colleagues and respect to all my seniors. What I will say, this is our body and we do the routine checkup or health checkup to know what are the diseases present or what are the issues present. Do we carry out routine checkups or not? We do. But for the structures and bridges which are the lifeline of the highway network, generally we don't carry out such kind of assessment, which should have been carried out from time to time. So, condition assessment, it is not a new activity. Already there is a code, IRC SP 35, which stipulates the methods and different types of techniques and different testing methodologies to find out what are the different assessment techniques, how to make the condition assessment and other things. However, due to lack of resources and due to some other issues, we are unable to carry out the condition assessment in routine manner. So I'll go. So bridges, as I had told, the bridges are the lifeline of highway networks, and they cannot be just constructed and forgotten. So they need to be assessed from time to time so that we can keep an inventory of that. We can manage the system in a BMS, that is bridge management system, and maintain a bridge information system. Like the condition assessment in regular interval is required for determination of essential components of the bridges, and particularly aged and deteriorated bridges are required to be assessed from time to time. So what are the different steps involved in the bridge maintenance management? First step is inspection and identification of distress. We have to carry out a visual inspection or with drone based survey or remote. There are different remote sensing techniques through which we can find out that inspection and identification of distress. Then we have to determine the severity and extent of the distress. Then we have to find out what is the cause of the distress. But because until and unless we find out the cause of the distress, we cannot go into the rehabilitation strategy. For that, there are several non-destructive techniques and destructive techniques are available. We will discuss in details in later slides. Then we have to go for condition rating of the elements and overall rating of the bridge, and then we will find out the maintenance strategy. After all the distress mapping and finding out what the disease the bridge has, then we will check out the maintenance strategy, where we will find out the different rehabilitation and repair strategies, or the bridge has to be dismantled, or different other strategies as per our budget provision. Then we will prioritize as per our budget, and finally we will monitor the performance. There are different components of the bridges, like substructure, as all of you know. This is foundation, substructure and superstructure. But there are different combinations, like in superstructure there are twin cell boxes, there are arches, there are girder types of bridges. Similarly, in substructure there are different types of combination, and foundation we can go for a shallow foundation or deep foundation. So we need to investigate all those things. These are the things, what are the components to be inspected and what are the different types. And while investigating or inspecting, there are the different types of cracks or distresses we generally observe. Like we generally observe that there are in many cases, expansion joint and drainage sprout are not functioning. Due to that, there is falling, there is corrosion, there is delamination, and there are structural cracks like flexure crack, shear crack, all those things. These are the different codal guidelines which are available in our country, or IRC guidelines for inspection of bridges. This is IRC SP 18, IRC SP 35. IRC SP 40 generally provides the details recommendations, though inspection is also a part, and IRC SP 52 is the bridge inspector manual. So these are the different methods which have been stipulated under IRC guidelines. You can get it from IRC 35, SP 35 also. Visual condition assessment, we can use the NSB and MBIU system. And I am going to tell that we have got one new MBIU under RDQ viewing, through which we have inspected. With CRRI we have inspected, and we are also doing the independent inspection. It can be used with drones, robots, terrestrial laser scanning, LiDAR technique. These are the different techniques, non-destructive or destructive testing.
Mr. Naik, you have only 7-8 minutes. You switch over to case studies.
Yes, sir.
Case study, because if you have any particular case study, we are very interesting to know the case studies. Proceed, but finish in now 8 minutes.
And this is the recent policy guideline which has been released by the government of Odisha. So, as sir has told, I am going into the case studies. So actually we are different. Odisha, as you all know, has a large coastline with crisscrossing rivers, and we are also prone to different cyclonic storms and natural calamities, due to which we can perhaps get different types of distress in bridges. So actually, to mapping all those things and get a bridge information system in 2015, Odisha Road Asset Management System was initiated, in which BIS is a module in which bridge inventory system and bridge condition assessment, all those things data are kept. But from 2015 to 2023, after ORAMS was initiated, we generally did not get such kind of data. So as per the initiative of Dr. N.C. Pal sir, we tied up with CRRI for 304 numbers of old and distressed bridges, out of which there are 52 numbers of major bridges and 252 numbers of minor bridges throughout Odisha, to which CRRI did the preliminary inspection and detailed inspection, and after that vibrational analysis and load studies are also carried out. These are the different inspections carried out by CRRI and our team actually. This is the MBI of Odisha, and this is the different bridges in which we are carried out the condition assessment. This is one bridge over Pipili Konark Road, Puri, where both the MBIs are entered. So these are the different types of structures we encountered during the condition assessment. Some are like this, you can see masonry pier with twin well type structure, column type of dual column type of piers with connecting your wall type of structure, and balance cantilever type of superstructure, and all those things actually you can see. This is slab type of bridge. These are the inspection of typical major bridges. And you can see all those old bridges actually, they are constructed with M20 or M25 grade superstructure with well foundation with M15 grade, which are standing still till date. Though no routine maintenance or no routine condition monitoring were done, only vegetation growth, expansion joint and drainage sprout issues have been encountered. So there are 304 bridges, but I have taken some of the bridges where actually now the rehabilitation work is in progress. One is Dhenkanal Kamakhya Road in Dhenkanal Bridge. You can see these are the different issues observed during the inspection. That is vegetation growth, bearing locks, there are bearing lock, foreign materials and wooden locks are left in between the bearings. Bearings have been displaced, expansion joint and drainage sprout are not working properly. Damaged and displaced bearings, several cracks on internal and external of the box, and you can see in the photos also, there are different photos. It is the hinge joint actually, and this is the actually different photos, like the bearing, the tie bar is missing, link is missing, and different issues. See, there are several issues like the expansion joint has been clogged, or expansion joint has been blocked or not functioning. Something utility line has been taken alongside the cantilever portion of the deck, due to which there is your spalling has started and leaking of water is there, which is very deleterious for concrete. Similarly for Ramial bridge actually, as I had told actually, we can see from its upper surface or picture that this bridge is in a very good condition. It is not a very old bridge. This bridge is in a very good condition from the top layer. But while we investigated, we witnessed that the poor quality, poor workmanship of concrete is there, honeycombing is there, there is spalling, there is reinforcement corrosion, severe corrosion, everything is there. So actually that has been detailedly provided by the CRRI. Similarly for Mahanadi, over Kalarda bridge over Cuttack 2 division, the bridge is with PSC girder and RCC deck slab, both the abutment. Similar case, the vegetation, expansion joint blockage and drainage sprout blockage. And here actually NDT and core samples are extracted. It was done for all other bridges also. I am showing that NDT and core samples are extracted to for detailed investigation. I can show this is a long span bridge. It is more than 25 meter. However, elastomeric bearings has been provided, due to which the bulging and cracking of elastomeric bearing has been observed in this case. These are the inspection photos actually, and in some cases, this is the actually, here the eccentric pier was also observed. We have taken the core and we have taken the carbonation actually, done the carbonation, all those things. Similarly in Rusicula also, which is actually masonry pier, we have a masonry pier here. And see the masonry pier, the walls are actually exposed. We have a here metallic bearings. They are 60 or 70 years old, but metallic bearings are still in place and there are no issues. There are some cracks over the metallic bearings and spalling of concrete. These are similar types of case what we have encountered. We have encountered actually spalling of concrete, reinforcement corrosion. In some cases, actually in some of the cases, actually the existing wearing coat has been overlaid without scarifying the existing layer. So that dead load is increasing over the structure, and similar kinds of issues like leaching of and other things, poor quality of concrete, those things have been observed. And many of the cases, as these are old and distressed bridges, carbonation has occurred up to 35 mm or 40 mm has been occurred, which is actually the full cover concrete has been carbonated. This is one slab type of bridge, though it is already in distressed condition. Vehicles are moving over it, so it was blocked. Similarly, cracking, there is blockage. In some places, due to non-routine maintenance activities, the bearings have been damaged, and its bolts and other parts have been misplaced. Bearings have been disaligned. This is the spalling of concrete in the deck slab cantilever deck portion. So these are all carried out. These are the bearings actually. Many of the places bearings have not been properly installed, or orientation is poor, or tie bars are missing. So these are in dangerous condition. What we found out. So these are all case studies regarding CRRI actually. We did with CRRI. This is one bridge actually, HL bridge over river Tel Turkel. What we have done recently with our in-house team and RDQP, with RDQP, a mobile bridge inspection unit. Actually, it started with one crack in the P1, Pier 1 to Pier 2 structure, where a large crack was observed. Accordingly, the team was mobilized and we did a detailed investigation. Accordingly, after detailed investigation, a distress mapping sheet was prepared, span by span manner. And in the different spans, actually, different types of cracks or everything, those are observed. Actually, in Pier 1 and Pier 2, large shear crack, splitting separation of web and soffit portion, breaking of closed loop stirrups, disintegration of concrete, those were observed. This is a trestles type of abutment in one side and plain type of abutment in other side. Actually, one span was added in 1978 after the flood. And these are the different types of distresses observed, and this has been mapped. This is the actual core test results. Actually, in those times mixed design was done in M20 grade or M25 grade. In this M25 grade, concrete has been used in the articulation spans or suspended spans, and M20 has been used in substructure and superstructure other part, and M15 grade twin well type foundation has been used. We carried out some sample core studies and non-destructive testing. We found out that the pier strength is more than M30 grade and the superstructure strength is more than M25 grade. Actually, we carried out sample cores and we actually carried out span by span non-destructive testing and pier by pier non-destructive testing, that is rebound hammer UPV. In some cases also carbonation study was carried out. We found out that the average carbonation depth was around 31 to 32 mm. So overall structurally it is okay, but routine maintenance could have enhanced its life. Similarly, corrosion was also carried out. In the cantilever deck portion only corrosion was observed. In others still, whether though it was built with mild steel, no corrosion has been observed after 50 years. So these are the distress assessment. Only after distress assessment and those diagnosis of disease, we cannot stop. We carried out the rehabilitation measure. Actually, CRRI proposed us the rehabilitation measure in many of the cases. They formulated the BOQ and shared with us, like in poor quality of concrete, chipping of concrete, after chipping of concrete, provision of adhesives, then cleaning of the reinforcements, provision of anti-corrosive paint, pressure grouting, and your polymer modified concrete, application of polymer modified concrete, case to case basis jacketing, and all those things actually repair and modify. Also FRP laminates, they also provided in some cases FRP laminates and FRP wrapping for increase of shear and flexural strength of the structures. Now, in many of the structures, like those bridges what I have discussed in Ramial, Dhenkanal and Cuttack, already the work is under progress, and these are some of the photos where the work is under progress already. So we are carrying out the rehabilitation so that the bridge life can be enhanced. So I'll just conclude. I'll say that we have to do the condition assessment in routine manner so that we can get the data and we can minimize our maintenance cost, because with routine maintenance activity our life cycle cost can be minimized and the bridge life of the bridge can be extended, because at a later stage when we are diagnosing the disease, then it is very cost effective. In many cases rehabilitation cost exceed the original construction cost. We need to take care of those things. We can do that with routine kind of inspection, and IRC SP35 also provides 3 kind of inspection, that is routine, principal and special inspection. And this is the requirement or this is the need of the hour, so that can be done in timely manner. Thank you.
Thank you, Mr. Naik. So this is a really we were searching for such type of presentation by the PWD. Structural health monitoring has been a very widely accepted subject now. Nobody wants to neglect. Like our health, bridge is also in health, and recently we have many incidences of bridges under construction or bridges under service. So this is a very important, and really I congratulate PWD Odisha for taking initiative. I think you are, as far as bridge condition and monitoring and maintenance, you are ahead of many states. Many states. I cannot say you are all states, but maybe a few states may be equally going with you, but I really, it is the vision of earlier days, Mr. Basa, then your earlier secretaries from the engineering department, engineering side, then Dr. Paul, my friend Manoranjan, all your stalwart peoples are in the PWD, so that is the reason that you are taking advanced action. 14-15 I was in charge of your state. I was in charge chief engineer for the LWE works, some state works when Mr. Sarangi was RO here. I traveled many, and I'm very fascinating to see your works. And when your secretaries from engineering cadre, we get a lot of confidence that whatever problem you take to him, he will certainly support. Nobody will delay if you tell him that your bridge is going to be collapsed very soon. If you write that sir, bridge is in very bad conditions, technical secretary ENC will agree to it. So my really compliments, and this is a important topic, Mr. Naik, you have taken up. Our floor is open, please, but only 2 or 3 questions, not more.
Compliment Mr. Naik. Just I want to know, you said about the retrofitting versus new construction. In the bridges that the condition survey has been carried out in the state, have you recommended any such a threshold or number of bridges to be replaced in terms of age, deterioration, functional requirements?
Hello. Sir,
Hello.
actually, regarding replacement.
Mahala, product consultant, Delhi.
Hello. What we have, sir, witnessed actually, the old bridges are performing well. These 50-year-old bridges, they are performing well. From their course, their structural integrity, those are in very good condition. And now if we want to replace those bridges, which we have been constructed within last 5 or 10 years, those are performing very badly. Sir, there is a replacement of those bridges, not those 50-year-old bridges. With minor rehabilitation or repair measures or even retrofitting measures, we can enhance their performance actually. Like in Tel Turkel bridge actually, this bridge has, the issues what we have observed actually, that is majorly because of Vedanta or the industry coming up, then the SV loading and many of the overweight vehicles, what they have plied over the vehicle, due to that we have witnessed the distress. Because for 50 years there was no distress. we have witnessed the distress within last 1 to 2 or 3 years. So actually it was not designed for that kind of loading system. Now we have to think those old bridges, whether to retrofit, how to retrofit them so that they can carry out their life or they can perform to our nation for the next 100 years. So I am not a bridge guy actually. I know that it is a life of 100 years, but I think it can carry out for another 100 years. But the new bridges, what we are doing with higher grade of concrete like M40, M60 grades, we are also carrying out the mixed design activities. But those bridges actually are not performing whether due to lack of workmanship, whether due to lack of supervision or whether due to inadequacy of material. And one more thing is there ki we are using pozzolanic materials nowadays. This is a very dangerous phenomena, whether we are using pozzolana and we are actually compromising with the alkalinity passivity. That's CaOH2, calcium hydroxide, what we are getting actually, that provides a passive layer over the reinforcements, which provides a protection for corrosion. But now we are carrying out with fly ash, slag and all those things, and we are not thinking. We have to then make it impermeable. Then impermeability test we are not doing in mixed design. In the field we are not doing. It has to be very much impermeable so that corrosion activity cannot induce. But we are not taking into that account, and workmanship is very poor. So corrosion is initiating at a very early stage, and we are witnessing various kinds of issues throughout the time.
Was epoxy grouting considered and carried out in any of the bridges?
Sir?
Epoxy grouting.
Yeah, it has been carried out in some of the bridges actually. No, some of the recent bridges, not all.
Hello.
Sir, your question is not, nobody is able. So, एक तो mic लीजिए, and there are one-to-one question. I think we will have tea together. We will have tea together. That your question could.
So, this is Sunil. My question is.
Please wait. Mr. Mahalai has raised some question whether epoxy grouting was done. Whether epoxy grouting has been done.
Yeah, in that bridge what I have shown you, in Ramial bridge in Dhenkanal, and in some of the bridges where the poor quality of concrete is there, they are doing the epoxy grouting as per the recommendation of CRRI.
Okay.
My question to Mr. Nayak is about the bearings, and some of the photographs that I saw that the roller rocker kind of bearings were completely damaged. So what did you do for these? Did you replace even the type of the bearing, or did you find the manufacturer of exactly those kind of bearings? That is my question.
No,
actually, how was that replaced?
CRRI has recommended for replacement of bearings actually, lifting of the spans and replacement of bearing in some cases actually.
What type is my question? Of course, replacement is.
I have not gone through the details of BOQ actually. In some of the cases actually, I am majorly associated with the condition assessment of the stretch, and I don't remember actually what kind of actual suggestions some of the cases.
Sir, one last question, sir. This side, sir.
Okay.
Since this team panel is sitting, sir, my name is Arvind Chaudhary. I am from Bihar, sir. Mr. Sahu is there, the STA. We've known him sir, from a very long time. We have a problem, sir, in recent days. The upper catchment area in Nepal there's a very heavy rainfall. We have made some major bridges which the intermediate pier is getting synced. Even achieving the depth, everything is being done. Even then, because of the V gorge of some of the tributaries of Kosi, Parman and Bakra River all over the state, especially in the border areas, sir, recently we've seen that some of the pier sinks in between which comes under the V gorge. So to rehabilitate, as Mr. Nayak was talking about the rehabilitation, how do we rehabilitate this particular pier? Is 2 or 3 of bridges which are coming these days. We have a major problem. We like to, after jacketing and fixing up and cabling, we like to focus. I like to meet Mr. Sahu in person as well. And since this team panel is sitting, we like to have this. There's a major problems in coming, sir, because the upper catchment area has got a heavy rainfall.
Dear sir, we are discussing here the case studies of the Odisha PWD, what is the problem encountered and rehabilitation strategies adopted in the Odisha PWD. Yours is you can talk to this problem with Mr. Basa.
Right, sir.
And Dr. Paul is there.
Sir.
We are discussing case studies encountered by them. your case studies, we have replied to this. But again, across the team, we'll discuss your problem.
Right, sir.
So I will request
Sir, I just
Mike.
close with one line supplement. Just I close. Sir, what is the beauty of this study in Odisha? Out of 300 bridges, what we have observed so far, the old bridges which have been done in M15 concrete, M20 concrete, and with stone masonry substructure, twin wells, 70 years age, they are still standing without even sign of cracks. But most of the, and in the case it has shown in the bearing, it is 35-meter span. Elastomeric bearing has been given based on recent IRC recommendation, and we have seen the position of the elastomers. So maybe this thing need to be reviewed. Whereas the new concrete, new bridges built about 7-8 years back only with fly ash-based pozzolanic cement, but M30, 40, 50 grades are deteriorating so fast. We want to find out what could be the reason. And if you remember 70 years back, these are mild steel. We slowly converted to HYSD and TMT. What is the problem in this type of steel? That is the most of the summary. And another thing we have shown in one photograph, in the cantilever deck, we are taking utility. The moment you are taking utility punching, that is the part which is going for corrosion and spalling. Those practices need to stop. That's the most summary of the findings that we have got. Thank you.
Thank you, sir. Thank you for your suggestion. And this issue we'll discuss in B8 also, because this is your and my domain. I request my co-chairman, Professor Sahu.
Thank you, sir. So we have come to the end of 5 excellent presentations. So during the last 1.5 hours, I could feel that some very good presentations were going on. I was feeling that I am sitting amongst my students, and some very good, excellent presentations, technically sound presentations were going on. So there were a presentation on road asset management by Dr. Swai, where I have just one suggestion. Maybe can we include recycling into the asset management system? So that you can think. Maybe every time we are going for overlay and preventive maintenance, etc., maybe recycling we can think of implementing into the system. And other presentations by Mr. Padhi regarding this Sri Setu is a very good presentation where they have used very good traffic planning measures, as well as they have used ground improvement measures, void slab. All state-of-the-art technologies have been implemented in different constructions. Then very good finite element tools, some of the speakers they have used, and really they have come out with very good conclusions, and which as interactive sessions, and many audience they have asked and complimented, and then they have been asked to put their observations to IRC so that the same can be brought into the courts also. So after so many discussions, I think we can conclude. We are running out of time. So I now request our chairman, sir, to finally conclude.
So it was a wonderful session by all the panelists, 5 panelists. And thanks to all audience. Hall is almost full. Thank you, madam. You can proceed with concluding.
Thank you so much, sir, and thank you all our esteemed presenters for your insightful and informative presentations. We truly gain valuable perspectives on diverse aspects of engineering and infrastructure development in Odisha. With this, we conclude the technical session and begin the felicitation. And to do the honors to our presenters, may I please request our chair of the session, Sri D.O. Taude, sir, to kindly come forward to present some mementos to our presenters. Please. Yeah, I'll take the name. Dr. Subhranshu Swai, Superintending Engineer, Civil Cum Roads, Bhubaneswar. Thank you so much, sir, for sharing your knowledge with us. Engineer Sundar Madhav Padi, Chief Construction Engineer, Khordha R&B Circle. Thank you so much, sir, for your wonderful presentation. Dr. Gayatri Patel, Superintending Engineer, Works Department, Government of Odisha. Next we have Engineer Lopamudra Mohanty, Superintending Engineer, Bridge Design, PWD Odisha. And lastly, we are having Engineer Gyan Prakash Nayak, Superintending Engineer, RDQP, PWD, Government of Odisha. And now it's time for the felicitation of our chair and co-chair of the session. And to do the honors, may I please request on stage Engineer Dukhabandhu Behera, former Engineer-in-Chief, Works Department, Odisha. We had Sri D.O. Tavade sir as the chair of the session. So now it's time to felicitate him. So ladies and gentlemen, let's give it up for our chair of the session. And we had Dr. U.C. Sahu as the co-chair of the session. And now may I kindly request all our presenters, chairperson and co-chairperson to kindly come forward. We'll take a group photograph. I remember that. From last 3 days I'm doing that. Thank you so much, ladies and gentlemen. We'll move ahead with the technical session, next technical session after 15 minutes. Now it's time for a tea and coffee break. Please enjoy it. Thank you.
A century ago, India's roads were few and far between, rough, uneven, and often impassable. The First World War changed everything with growing motor transport. The nation felt the urgent need for stronger, well-connected roads. In 1927, the Trailhead Committee was formed, recommending a central body for road development. Thus, in 1934, the Indian Roads Congress was born. A collective of 73 engineers who dreamt of transforming India's journey. That day, IRC became the torchbearer of innovation, guiding the country from mud tracks to multi-lane expressways. Today, India stands proud with a 63 lakh kilometer road network, the second largest in the world. Our national highways, just 2.3% of this network, carry over 40% of total traffic, a testament to their strength and scale. At the heart of this transformation is the IRC, formulating standards, guiding policy, and enabling seamless mobility for every Indian.
Indian Road Congress serves as Ministry of Road Transport and Highways, translating national infrastructure targets into practical by formulating standards and rigorous guideline work through various technical committees. IRC established in 1934 as Apex Highway in 1990. It develops the codes specification for road bridges. These guidelines and codes ensure that policy comes from vision to on-the-ground execution.
From manual drawings to digital design, from conventional bitumen to eco-friendly mixes, IRC has evolved with time, embracing technology for greener, smarter, and safer. IRC champions recycling, waste plastic use, energy efficiency, and sustainable materials, paving the way for carbon-neutral infrastructure.
Indian Road Congress is the premier standards organization in the roads and highway sector in the country and has a very important role to play in achieving the vision of Viksit Bharat. Over the last few years, as the spurt of highway construction has happened, we have also faced a lot of concerns about quality insofar as construction is concerned. Some of these quality issues can be traced with design and specification issues. Some, of course, are the construction practices that are being followed. I am sure the wisdom that is contained within all the delegates and all those who are participants or part of the roads family would contribute to this exercise for taking this country forward into the new era of the roads.
At the forefront of modernization stands the Dwarka Expressway, a marvel of smart engineering, integrating AI-based traffic management and multimodal connectivity. Built at a cost of 5,360 crore rupees, it embodies the new India, faster, cleaner, and future-ready.
भारतीय सड़क कांग्रेस IRC का ट्रैफिक मैनेजमेंट सिस्टम स्थापित किया गया है जो यात्रा को अधिक सुरक्षित और कुशल बनाता है। स्मार्ट सेंसर और एनालिटिक्स के माध्यम से राजमार्गों का डिजिटलीकरण कर हम नागरिक केंद्रित भविष्य के लिए तैयार इंजीनियरिंग समाधान प्रदान कर रहे हैं जो जाम को कम करने और सड़क सुरक्षा बढ़ाने में सहायक होते हैं। IRC हर वर्ष देश के विभिन्न राज्यों में वार्षिक अधिवेशन आयोजित करती है जिसमें राजमार्ग और जो हमारे सुरंग है क्षेत्र में जुड़े अभियंता, ठेकेदार, सलाहकार, कंसेशनर, मशीनरी, सामग्री निर्माता यह अधिवेशन राष्ट्रीय और अंतर्राष्ट्रीय स्तर पर अपने उत्पादों, तकनीकों
Cutting through the mighty Himalayas, the Z-Road Tunnel ensures year-round connectivity to Sonamarg and beyond at 8,652 feet. This 6.4-kilometer lifeline strengthens border logistics and tourism, securing the nation and empowering its people.
इंडियन रोड कांग्रेस एक वो संस्था है जो कि देश भर की टनल्स में रूल्स, कोड्स, रेगुलेशंस बनाने की एक एपेक्स संस्था है। इसमें सभी तरह के इंजीनियर्स, कंसल्टेंट्स और सभी स्टेक होल्डर्स पार्टिसिपेट करते हैं और इसका एक बड़ा क्लासिकल उदाहरण जो सोनमर्ग से श्रीनगर की एक जेड मोड टनल है, 8,500 फीट की ऊंचाई पर बनी हुई ऑल वेदर टनल, ये इसका एक बड़ा कंट्रीब्यूशन IRC का मैं मानता हूँ जो भुवनेश्वर में 84th कन्वेंशन में आप सब लोग पधारे हैं कि आप लोग देश के निर्माण में, नई टेक्नोलॉजीज़ के निर्माण में बहुत बड़ी भागीदारी दे रहे हैं। आप सबको बहुत बहुत बधाई, बहुत बहुत शुभकामनाएं।
At 13,000 feet, the Salar Tunnel stands as India's highest bi-lane tunnel, crafted with cutting-edge techniques and the new Austrian tunneling method, dynamic support systems and SCADA-based monitoring. It ensures all-weather access to the border town of Tava, connecting not just land but lives. From 1934 to 2024, the Indian Roads Congress has led India's journey from dependence to dominance in road infrastructure. It continues to empower engineers, guide innovation, and uphold the dream of safe, sustainable, and smart highways for every Indian.
भुवनेश्वर में हो रहे IRC के कॉन्फ्रेंस के लिए मेरी हृदय से बहुत बहुत शुभकामनाएं। हमारा देश वर्ल्ड की 3rd लार्जेस्ट इकोनॉमी बनाने का मिशन आदरणीय प्रधानमंत्री जी ने हम सबके सामने रखा है और उसके लिए इंफ्रास्ट्रक्चर भी वर्ल्ड स्टैंडर्ड का बनाना पड़ेगा। आने वाले समय में हमारे सेक्टर में बहुत बदलाव हुए। इनोवेशन, एंटरप्रेन्योरशिप, साइंस, टेक्नोलॉजी, रिसर्च की और सक्सेसफुल प्रैक्टिसेस, इसको हम नॉलेज कहते हैं और कन्वर्शन ऑफ नॉलेज टू वेल्थ हमारा भविष्य है। कंस्ट्रक्शन टेक्नोलॉजी, कंस्ट्रक्शन इक्विपमेंट में भी लगातार बदलाव हुए। IRC ऐसी हमारी करंट ऑर्गेनाइजेशन है, ये बदलाव को इंडिकेट करके हमें भविष्य का मार्गदर्शन देती है। मेरा विश्वास है कि इस कॉन्फ्रेंस में शरीक होकर इसका नॉलेज के साथ साथ इसका अनुभव और इसका
Indian Roads Congress, the roads of the nation, for the progress of the nation. These roads are not just built with beauty. They are built with purpose, with planning, with precision, so that your families travel safely and comfortably. They are built with endless connectivity so that our businesses keep moving mile after mile. They are built to take us to every corner of our magnificent India and to serve those brave hearts who protect us and our magnificent India. Every road is a story of connection, progress, and dreams. And behind this grand vision stands the body shaping the future of Indian roads infrastructure, the Indian Roads Congress. For over 9 decades, the Indian Roads Congress, IRC, has been the guiding force for India's highways, setting standards, building frameworks, and shaping the way our nation moves.
ensures that our engineering guidelines reflect the latest research and best practices for India's sustainable road development.
A century ago, India's roads were few and far between, rough, uneven, and often impassable. The First World War changed everything with growing motor transport. The nation felt the urgent need for stronger, well-connected roads. In 1927, the Jaighar Committee was formed, recommending a central body for road development. And thus, in 1934, the Indian Roads Congress was born, a collective of 73 engineers who dreamt of transforming India's journey. From that day, IRC became the torchbearer of innovation, guiding the country from mud tracks to multi-lane expressways. Today, India stands proud with a 63 lakh kilometer road network, the second largest in the world. Our national highways, just 2.3% of this network,
Congress serves as Ministry of Road Transport and Highways, ECMO, translating national infrastructure targets into practical by formulating standards after rigorous back-end work through various technical committees. IRC established in 1934 as India's apex highway engineering body, it develops the codes and specifications for roads, bridges, and tunnels. These guidelines and codes ensure that our policy transforms vision to on-the-ground execution.
From manual drawings to digital design, from conventional bitumen to eco-friendly mixes, IRC has evolved.
All right, everyone, requesting all of you to kindly settle down. We are about to start our technical session 16. Ladies and gentlemen, please settle yourself. We are about to start the technical session 16, and please keep your phone on a silent mode. If the messages and the calls are not that important, kindly don't answer it. Thank you. Requesting everybody to kindly take their seats. We are about to start the technical session 16. All right, ladies and gentlemen, once again, good morning to all of you. I welcome you to the technical session 16, Rural Roads, Challenges and Success Stories. The session will be chaired by Sri Amit Shukla, Joint Secretary, Rural Connectivity, Ministry of Rural Development and Director General, NRITA. May I please request you, sir, to kindly join us on the dais. And the session will be co-chaired by Sri D.R. Meghwal, Secretary, PWD, Rajasthan. May I kindly request you, sir, to kindly join us on the dais. And to welcome our chairperson and co-chairperson, may I please request Madam Pragya Purnimasi, Superintending Engineer, Works Department, Odisha, to kindly come to the dais and welcome them with a flower bouquet. Starting with our chairperson, Sri Amit Shukla. We welcome you, sir. And our co-chair of the session, Sri D.R. Meghwal. Now, I invite all the presenters of the session to please come to the dais for the presentations. Dr. M.A. Reddy, Professor, IIT Kharagpur, STA Coordinator. Dr. Praveen Kumar, IIT Roorkee, PTA Coordinator. Dr. I.K. Pateria, Director, NRIDA. Dr. Suresh R. Dash, Associate Professor, IIT Bhubaneswar, STA Team Member. Sri Rishi Baderia, GM MPRRDA, Ujjain. Sri Saurav Jain, GM MPRRDA, Sagar 1. And last but not the least, Dr. Anjan Kumar S., Department of Civil Engineering, IIT Guwahati. May I request all our presenters to kindly join us on the dais. So with this, it's time to start our technical session 16, Rural Roads, Challenges and Success Stories. And may I please request Sri Amit Shukla ji to start the session with his opening remarks. Please, sir.
Good morning. A very warm welcome to the distinguished delegates, my co-chair in this technical session of the 84th IRC being held in this August premises. I also welcome all the representatives from states who have assembled here. This is a very important session. Rural roads, as you all know, constitute the bulk of the roads in the country. And PMGSY, Pradhan Mantri Gram Sadak Yojana, is one of the flagship programs being implemented by the Government of India for improving the rural roads in the country. We are in the 25th year of implementation of PMGSY, and it is very fitting that we have a dedicated session and in the presence of eminent experts who have contributed all along their journey, all along their academic pursuits towards the betterment of rural roads in the country. We had several standards built in to improve the PMGSY roads. This session will take it forward. We are continuously evolving, and there are challenges. There are challenges in terms of new traffic patterns, new requirements for moving on to post-2030 India. We have several key asks from the states which are getting transferred to IRC. So I'm grateful to IRC for inviting us here, me and my team. And the experts who are going to make a presentation today are first, development of accelerated payment test facility to evaluate payments of village roads by Dr. M.A. Reddy, Professor IIT Kharagpur, STA coordinator, then wet method for use of plastic in bituminous layer, Dr. Praveen Kumar, IIT Roorkee, is the PTA coordinator. Stage passing for quality assurance by Dr. I.K. Pateria, Director Project 2, Project 3, NRIDA. Then when rivers rise, sources of bridges and flash floods by Dr. Suresh R. Dash, Associate Professor, IT Bhubaneswar, STA team member. Maintenance management towards asset management by Sri Rishi Baderia, GM MPRRDA Ujjain, Sri Saurabh Jain, GM MPRRDA Sagarman. Then FDR in rural roads, achievements and field insights by Dr. Anjan Kumar S, Department of Civil Engineering, IIT Guwahati. So 10 minutes, sirs, madam. So there's no madam, sirs. 10 minutes have been allotted for this presentation. I'll request everybody to stick to that time schedule. And should we start? Yes. So I'll first invite Dr. M.A. Reddy to give his presentation. Thank you.
Chairman, co-chairman of this session, all the colleagues of today's presenters, and all the engineers and students and faculty and other members who have come from different places. Very good morning to all of you. So today I'll be presenting, I'll take this opportunity to present one indigenous technology that we have developed very recently with the help of NRRDA, that is development of accelerated test payment facility to evaluate the payments of village roads. It's a 5-year project. So normally what we do is, this is very conventional that we do lot of testing in the laboratory, lot of testing of different materials, that from subgrade to top layers, and then we say that it is doing well, and finally we transfer to directly to the payment. So during this process, there is always uncertainty that whether you may see some kind of premature failures. This is what happening in the recent times. We designed for 10 years or 5 years or 15 years, but failures are seen. There are various reasons for that, like material properties, climatic factors, load associated, quality in construction. Okay. But nevertheless, in spite of all these being same, the material properties, for example, we are evaluating the laboratory and all are in controlled conditions. That means we say that temperature is this much and sample preparation is this, like this standard procedure, and climate also. We don't, there is also different temperature or moisture. Everything is controlled, but which is not, it is far away from the reality, because once you construct, the temperature is not same. It goes to 70 degrees pavement temperature. There is a huge rainfall. The moisture levels are different. So we are far from the reality, and you know the testing conditions, the boundaries are entirely different. So therefore, when you compare the field performance, laboratory performance directly with field performance, you may get same performance what we expected, but you may not also. There is a lot of uncertainty that is associated if you directly use these materials, but this is a conventional practice that we've been following. So therefore, there should be some linkage between lab to field. Before you directly apply in the field, especially when your new materials are coming up, marginal, there should be a linkage. So what is the linkage? What worldwide they are doing is, there is a semi-field evaluation. In between this laboratory and field, there is a semi-field evaluation. So that means, what do you mean by semi-field evaluation? You may have to construct a small portion of a road with the same material which you are wanted to, we have already tested in the laboratory, then subjected to a real loading conditions, but in a faster manner. This is very important. Faster manner, same load, open to sky, it's subjected to all moisture, temperature, etc., and collect the data and see how it is performing. You analyze the data. This is what you mean by semi-field evaluation means. So that means there is a linkage between these two. So we are getting something in between. That is, we call it as accelerated payment test facility. I'll explain more about this. Accelerated payment test facility, defined by NCRC report, is a controlled, full-scale experimental approach used to evaluate the performance and structural behavior of the payment systems under simulated, accelerated, that is very important, actual traffic conditions. The primary goal is to produce the effect of traffic loading of 10 years or 5 years in few months in actual conditions. So therefore, you can also increase the load, whatever studies you wanted to do, you can do that. So therefore, this accelerated payment test facility was developed. If you see the history, it was 1909, but it did not took up faster, but from years 1960 onwards. Worldwide, there are a lot of accelerated payment test facilities that were constructed. Today, there are 40 APT facilities all over the world, US, of course, in some of the European countries, Australia, South Africa. Of course, these are either circular tracks or linear tracks, or there are some kind of mobile APT facilities also there. These are some of the, like California, Texas, all these. And when you come to circular, the France is one of the leading kind of things that is there. And also we have one such kind of facility in that is called heavy vehicle simulator in CRRI is also there. And all these equipments, you can see that they differ in the facility, whether linear, circular, mobile, what is the test section, length or diameter, loading, speed, data collection, environmental conditions. Sometimes they are kept in this kind of hall, and sometimes it is open also. And whether this can fix path or it can leave wander, all these things, and most importantly, very costly. These are very costly to the tune of even 40 crores also. It varies from, because nature of facilities that you have. So therefore, Kharagpur being one of the, like, under late Professor B.B. Pandey, so we have a passion towards developing indigenous equipment, several equipments, right from induction healing to even that APT we have developed in 2001, linear one, small one, to several equipments including FWD. We approach NRRDA, of course, under late Professor B.B. Pandey, to have a indigenously developed, low cost, fast kind of equipment which is called semi-field. So NRRDA has kindly agreed and sponsored this project. So therefore, we developed a circular accelerated test facility which will have a dual wheel, a 20 dia meter this thing, capable of applying a load from, normally we require 40 kilonewtons, but it can apply up to 60 kilonewtons, where effect of overloading can be, and you can operate up to almost like 25 kilometers per hour. Of course, we are trying to even improve that. So lot tire pressure, all these things are there. So this was inaugurated by Sri Amit Shukla ji in the May 30, 2025 recently, and we have started commissioning this, and we are grateful for NREA also to name this facility as Professor B.B. Pandey Accelerated Test Facility, which is now there installed and working. So I'll just also just demonstrate, I'll just show a small video which is also there to show how it works. It has got a data system. It is not coming. I think it is not visible. Can I have? It's not showing. So I'll just skip for a while and continue this presentation. Can you help me out? Just so it has got a facility to induce. Can you show this video? Show video. Screen. Yes. Screen. Just one.
डुप्लीकेट करिए इसको
Duplicate. Sorry for that. Maybe I'll skip this. Maybe at the end I'll show if time permits. Check कर दिया एक बार. नहीं आ रही ना? Yes. Yeah. Sorry for that. Just see this video. This is a data acquisition system that is been which captures the load, repetition, speed, and we also set the. These are two leg actually. Two arms are there. We can also have another two arms so that it can capture the data and it can impose, like, of course, induce 4 wheels actually at a time. So this is a video. So it's indigenously made and all the. So just stop it. So the key features of this is it can simulate any number of repetitions. Okay, if I add 2 more legs, so it can induce the load, whatever load you want, and whatever the payment test section. So it's a load application. We also fitted with some instrumentation over there. We have a pressure cells. We have also some strain gauges we have included, and data is being captured through this. So we can do a lot of laboratory testing, and same materials we can bring it to here and construct some test sections. And like you can effect of loading, effect of moisture, effect of materials, effect of new stabilizers. New stabilizers where there is uncertainty, all these materials can be tested. So like this is the kind of things when somebody brings a new material, so we can modify it, whether traditional or those things, conduct a lot of laboratory testing. Then if you have satisfactory performance, then come to APT facility. We can construct using same materials, same construction practices that are happening in rural roads or high volume roads. Then we see the performance of it, collect the data, analyze, and the analysis can be extended to giving a shift factors. This is a procedure for calculating shift factors. I will not explain this. Based on this, we can even propose some different payment design, etc., etc. So, yeah, suppose if I run it with 5 RPM, you can increase even to 8 RPM also. Maybe every day 10 hours, we can infuse 3,000 repetitions. Maybe in 1 month, we can achieve approximately 1 lakh repetitions. Even so with that, rural roads, definitely 1 lakh, 2 lakh, so we can complete in 1 or 2 months' time and give a performance of this. So we have constructed, 4 test sections. We have constructed 4 test sections, and all these are working. Sorry for this. Okay, we have constructed 4 test sections, and okay. So there are different materials. We ran this accelerated payment test facility. So you can see that the condition of these different test sections, including one the self-heal concrete payment, and even stabilizer, some what you call emulsion-based mixes all being tested under this. You can see the rud depths, etc. It has been there that. So application of this facility is, you can avail the local available materials, marginal materials, even somebody comes with a soil stabilizers, like what they do now, any material stabilization. We can also develop the mechanistic empirical payment designs. We can evaluate lot of applications are load equivalency, relative comparison between one material to other material. All these things are possible. So this will add to the sustainability in payment engineering, which we normally target because of improved performance, durability, all this stuff. So it's a linkage, as I told you, between lab and field. So in conclusions, this indigenously made, very low cost, which we can be affordable by any agency. We have well tested this. This facility can simulate the traffic condition, unable to assess the payment performance, low cost, easy to maintain. We can have relative performance between one material to other material, advanced instrumentation to capture the stresses, strains, rutting, all these things are there. You can correlate this with the laboratory and get a shift factors and use them in the payment design. So it provides a cost-effective solution where, as I said, most of the countries now, they adapt this. Three phase, laboratory, semi-field, and field applications. So thank you very much. And I thank NRDA for their support, and also gesture to name this facility as Professor B.B. Pandey Accelerated Test Facility, who is instrumental in developing, who believes that indigenous instrumentation, equipments are very much required for the country. So this is one effort that we made it to make it workable. Thank you very much, sir.
So thank you, Dr. M.A. Reddy, Professor IIT Kharagpur, for your presentation. Now I invite Dr. Praveen Kumarji for his presentation.
Chairman and DG of NRIDA, Shri Amit Shukla ji, Co-Chair Meghwal Saab, all the fellow presenters, including Dr. I.K. Pateria, who is with PMJSY for a long time, all officials from NRIDA and delegates. I have the honor of working with all DGs of PMJSY, NRIDA, which was earlier NRRDA, starting with the first DG, Shri K.R. Sharma, then Shri S. Vijay Kumar and all the learned DGs of NRIDA, because I am with this Yojana since it was started on 25th of December 2000, or rather before that, when it was being conceived. And I also have the honor to guide first MTech on PMJSY work, first PhD on PMJSY work, and both the students who did first BTech, first MTech on PMJSY and first PhD on PMJSY, fortunately are also sitting here. First, my MTech student who did MTech on PMJSY, he is Umesh Chand Sahu, and he is presently faculty or rather associate professor at IIT Bhubaneswar now. And first PhD was by Dr. Ankit Gupta, who is a professor at IIT BHU. So we are continuously working on PMJSY, and many of you who have come from the streets may be knowing that we are discussing. And this particular presentation today we are discussing is regarding the wet method for use of waste plastic in bituminous layer. Because we have the code on dry method. This is the code which we are having for the dry method by IRC, but we don't have any code on the wet method using the waste plastic. And in dry method also they have used only LDPE and HDPE, not other plastic. So why we are not having any code on wet method of using waste plastic? And PMGSY roads are the best place to test any material, because we have lesser traffic, and even if it fails, then it doesn't matter much. So the process is, first it is done in the lab, and NRIDA sponsored this project to us to test whether we can use the wet method or not. In the worldwide also, we have very limited studies on the wet method of the mixing of waste plastic. So these are some values which are given by some researchers for the various methods. So this is the project which was a project, as I said, for the given by NRIDA, as well as it is a PhD work. And this PhD has been submitted, and maybe in next 10 days this is being awarded. So the motivation was to the effect of different shapes of blending mixes, because the performance of any waste material is also dependent upon the blade, how the blade is working, what is the geometry of the blade, and that is why not much work was done on this, and we found that it is the performance is depending on the blade geometry also. Then we have to see the emission characteristics, because many times when we start using the waste plastic or any waste material, the concern from the society comes whether you are polluting the atmosphere or not. Then since there is no standard specification or the guideline, so we tried to develop this, and for that we collected the waste material, waste plastic from 4 points in the country, that is from Haridwar, Delhi, Mumbai and Chennai, covering almost entire country. These are some photographs we have taken in two forms. We have used in the form of pellets also, and pellets are basically, they are melted, the plastic is melted, and then it is made in the form of tablets. So you can see this. And then we try to find that what are the melting points of these waste materials, because it is important that the material should melt before the point where the bitumen is being heated. You cannot heat the bitumen more than 170 or 180 degree centigrade, because after that it loses all its binding properties. So the material should melt. So you can see here the test for the heat flow we have done, and in that we found that these materials, like 4 materials we have used: polypropylene, that is PP, LDPE means low density plastic, HD is high density plastic, and PET. PET is coming from the Bisleri bottles which you are using. This is a very hard material and it creates a lot of problems. So 4 materials we used, and we found that the PET was having the melting point more than 250 degrees centigrade. So if we heat the bitumen more than 250 degrees centigrade, then it will be difficult to have any binding property in the bitumen. That is why it was discarded mainly. And again we have to see the thermal degradation also. So it is the point above the production temperature, typically more than 200 centigrade it should be there, because we are heating up to 170. So the plastic should not thermally degrade. So that is why we have seen that all these are having higher than 200 degrees centigrade. So from the thermal degradation point of view, it can be used. You can see the photographs of unmelted pellets. This is an aluminum flakes which you have taken. Now you have to understand the basic difference between the dry method and the wet method. In the dry method, we mix the waste plastic with the aggregate, and then the bitumen is added. In the wet method, what we do is we mix the waste plastic with the bitumen, and then that modified bitumen is mixed with the aggregate. This is the difference between the two. These are the blades which we have used, 1, 2 and 3. They are having different geometries, different number of the parts, and we try to use all the three. And of course, there may be number of blades. Of course, we have tried these three. Some persons can try different also. And here we try to find out firstly the normal conventional test like the penetration one, and you can see here that after mixing of the waste plastic, the penetration is coming down. This is showing the results for 2%, 3%, 4% and up to 6%, 7%. And this was done for VG30. Initially we tried for VG30 because VG30 is the grade which is mainly used in the country. And then with increase in the dosage, the value of penetration reduced. The extent of reduction was higher in blade 1 in comparison to 2 and 3. Then we did the softening point. Softening point is also important from the point of view of mixing, and also during the summer season, if the softening point is low, then the material oozes out on the pavements and it creates the problem. So that is to be seen from here also. Then we did the image analysis using the fluorescent microscopy. You can see here, it is showing the photograph FM images of different materials for blade 1, 2 and 3, changing from percentage from 2 to 7. And you will find here as you are moving from 2% to 3%, 7%, the undissolved materials are being seen there. So that is why you can see. And after that, the image J was, this is the software image J, which we use for converting the FM images to binary domain. And then the mean particle size was estimated using the binary images. You can see here, this is showing you the mean particle size in the polypropylene, which was higher than the LDPE. LDPE, as I have told, it is low density plastic material, and this can be attributed to the chemical structure of the individual plastics. This is again showing the storage stability test. Storage stability test means we want to know that if the material is being transported, then whether the top portion and the lower portion will be having the same properties or not. This is the main test which says that the CRMB has failed in our country, because during the transportation, the plastic particles, if their density is more than 1, they settle out. If it is less than 1, it comes up on the top. So the uniformity of the bitumen is reduced. That is why storage stability test was done on the plastic also. So you can see here for LDPE beyond 2%, none of the blends except 3% with, and as per IRC code, it is 3%. The softening point difference between the top level and the bottom level should not be more than 3%. In some codes, it is given as 2.5% also. So this is the softening point difference between top and bottom samples of RWP. So beyond 3%, the results were found to vary with the type of blade. As I have said, the 3 blades were having different geometries, and it is showing you the storage stability test for the DSR test. In this, we have taken G star as the parameter to find it out how the variation is there. Instead of softening point, we have taken the G star value. So based on this delta softening point and the DSR results, it can be concluded that 2% LDPE and 3% PP are suitable for wet modification. Then to validate the result, whether it is only for VG30, can we use it for the VG10 also? Because VG40 is also now being used, but VG40 cannot be used for the modification of the bitumen, because VG40 itself is a harder grade. If you add the plastic in that, it will become further hard. So that is not possible, but VG10 and VG30 we can use both. So this is showing that it is valid for the VG10 also, same results, almost same. It is giving you that. Then we try to find out the emission characteristics using this equipment. We heated the material, and then we captured the fumes and analyzed with that. You can see here in the photograph also. So for that we found the particulate matter for the wet modification. So it says that due to environmental factors, burner efficiency and production inconsistencies, there is a variation. And These variations were influenced by the temperature, wind speed and humidity. Then again we tried to find out the air quality index. So if you say, is it polluting the environment? Actually, the values were definitely higher than the normal condition where there is no heating. But if you compare it with the heating with normal VG30 or normal VG10, then there is no additional pollution to the environment. It is the same. So when we are making the road, actually, so there will be no additional environment pollution due to this material. Then we try to find out the microplastic. Microplastic is the material which comes in the form of small plastics on the road, which is not stick to the road, so that may come out. So you can see this is the image analysis we have tried to find out. In case of dry method, we compared with the dry method also, there were some traces of microplastic, but in the wet method there was no trace of the microplastic. So this is basically the research summary. In nutshell, we can say using 2% recycled waste plastic, LDPE, HDPE and PP from suitable sources can modify the bitumen. It can be used, meeting all the specifications. And again, we will say PET is not suitable for this condition. So this is the report which we have given to NRIDA. These are some publications. We have got one patent also for this work. Recently, this patent has been granted to us, and this is the patent which we have got it. So lastly, this is some may ask the question that what is the amount of consumption in dry and wet? In case of wet, the consumption is less because we are saying it is 2 to 3%. While in case of dry, you may go up to 8% as per code. But the control of the material is better in case of wet plastic, and it is our environment, we have to save it. That is why here the main emphasis on utilization of plastic. Thank you.
Thank you, Dr. Praveen Kumarji, for this wonderful exposition. Now I'll request Dr. I.K. Pateria ji to give his presentation on stage passing for quality assurance.
Make it full screen. So this you can use it for next. Is it working? Yeah, it's working. Respected Chair, DG NRIDA and Joint Secretary, Ministry of Rural Development, respected Co-Chair, Secretary PWD, Government of Rajasthan, my fellow presenters, senior officers in the audience, budding engineers, and persons from industry taking interest in rural roads. This title has been printed in the program in the name State Passing and Routine Inspections, like that. So there was a small print mistake. There is nothing like state passing. States are independent. This is stage passing. So now it stands corrected in the program, which has been put on the dais as well. This is a new concept we are bringing in. Before I start making a presentation on this topic, I will be just running through the concept as to what we have thought of, what are the issues, and how we are trying to resolve them. I would like to appreciate and put our sincere thanks to former DGs of NRIDA, who in the year 2007, when we published the Quality Assurance Handbook for the first time, brought out this concept of stage passing and just put in a word that we should be in future thinking of going towards the stage passing of the construction works. It took almost 18 years in coming to this stage, but finally we have reached. Honorable Secretary, Ministry of Rural Development has approved on file. Honorable Minister has also consented. We have developed the system. DG sir is always with us for any kind of proposal being moved in forward direction. So with his approval, this was initiated, and now we have put in full flash on our website, and we have requested all the states along with guidelines that it needs to be started immediately. It has already started, couple of inspections have been done. So what this concept is and how we are going to make use of it. This is outline of the presentation. I will be focusing particularly on workflow, the concept, various stages, stage passing and routine inspections, how the provisions have been made, how the action taken reports now will be handled after we implement the stage passing system, and how the photographs, etc., will be recorded, which makes this process a little different from the existing process. The basic concept is, in PMGSY we have a 3-tier system. All of you are aware of it. The first tier is by the state implementation agency. The inspections by second tier are through the state quality monitors who are being managed by the state. And in third tier, the inspections are by the national quality monitors who are empaneled by NRIDA, and they are inspecting the works. So as of now, those who are associated with PMGSY are very well aware that the data of second tier and third tier inspections is in public domain, all reports, and is live. This data is live. However, there is no record of the inspections by the owner of the work. Owner I am saying because he is making the payment, the project implementation unit. This does not mean that they are not required to inspect, they are not required to carry out the tests, etc. All those systems have been already brought out in the Quality Assurance Handbook, which was published in 2007 and then revised in 2017. However, that is on paper, in registers, quality control registers. So there is no record on the website, there is no evidence. Whatever is recorded in the register is to be taken as true. Now we are bringing in the system of stage passing, wherein the executive engineer has to visit, and very specifically, the stage passing will be done by the executive engineer himself because he is in charge for making the payments. So the person who is making the payment has to now certify the quality before he can move to the next layer of construction. So this will strengthen the effectiveness of first year quality monitoring, and we have said that all works which have been completed after 31st of March 2025 will have to go through the concept of stage passing. However, certain relaxations have been given for those works which have been already completed, but for all new works in PMGSY 4, ongoing works of all the verticals of PMGSY, including that of PMGSY 3 and Janman program, Vibrant Village program, all these works are to be inspected at different stages of work. This is expected to be a systematic progress-linked quality checks by integrating inspection requirements with physical progress data entry. Data entry is happening now also, but there is no check when the executive engineer has inspected and what are his observations. He is recording in register, maintaining that register, but it is difficult to check it out and put any kind of restrictions on that. So now we are likely to put many restrictions with this stage passing. This is the workflow. A general comparison, what is the system now? As of now, executive engineer is randomly inspecting and recording the test outcome or his remarks in the register. But now he will have to go to the site, use mobile application, take his own selfie that he was present at the site while entering and while taking an exit from the inspection. And whatever tests he is conducting, he will be recording the observations and test results. So observations are being recorded through the mobile app on different items, and test reports will be uploaded on the website as the NQMs are doing. Now, as of now, QCRs are being uploaded, but difficult to verify those PDF copies of QCRs. Now the data will be in stage passing, all the data of tests will be in digital form, so can be easily scrutinized. Frequency of visits at present is, though the frequency of tests has been specified, but frequency of visits of executive engineer are not being recorded. Now this will be definitely there, and at every stage he will be going and inspecting. So if he wants to go in routine during construction also, he can do it, but after completion of every layer, he has to go and mandatorily issue a certificate for going ahead with the next layer of construction. As of now, PIUs focus on quality assurance and gradually shifted to the feeling is that the quality assurance is the responsibility of second tier and third tier. The owner who is supposed to make the payments is feeling that SQM is coming and NQM is coming. So now we are reverting it back. Practically we are reverting to the original concept of NRIDA about the quality monitoring, that these two tiers are just for providing additional support and guidance to the executing agencies. They are not responsible for the quality. The process of ATR submissions, action taken report submission, has also been revised. I will be showing a flow chart. As of now, ATR records are being prepared by the PIUs manually, but now no manual intervention. Everything will come through these inspections, and when he is submitting the action taken report, that will again be done through the mobile application. This broadly I have covered. This is the first page of Quality First app, which has been developed with the support of CDEC Pune. At every stage, after the stage is completed, there will be a message to the PIO that the stage has been completed. As soon as the data of completion of that stage is uploaded on the system, there will be a message, and the PIO has to go within 1 month and check and certify that stage. Once he does that, he can allow the contractor to proceed ahead with the next layer of construction. This is the flow of the first year inspection module. Section creation. We have given complete freedom to the executing agency and the PIU. If a road is 10 kilometers long, how many sections are to be created? He has to decide. 2 sections, 3 sections, 10 sections, 20 sections, or a single section. But he has to now own the responsibility of quality and certify that he has carried out the tests and they are found to be in order. The quality is in order. So first they have to create the sections, then they have to enter the plan of execution, which is being done now as well. Then the progress entry regularly, actual how much progress has been achieved, inspections through mobile app, that is Quality First, then upload the e-test reports, and finally download the certificate. Once he certifies that the quality is as expected as per specifications, he can generate a certificate, and these certificates will be available on OMAS, so can be downloaded at any point of time. As far as roads are concerned, these have been divided in 4 stages. So sections and stages. Sections are longitudinally and stages are in vertical direction. So different layers will constitute different stages of construction, and sections are in terms of length. So we have divided these in 4 stages. First stage up to subgrade. These are the items which will be inspected in stage 1. The items have been defined, sub-items have been defined, and how and what are the tests to be conducted, they are already defined in quality assurance handbook. So these are some photographs of the inspections which have been done by a couple of PIUs, and they have uploaded these images as well. In case of bridges, on recommendations of a group based on a workshop conducted in Dehradun around 10 months back, we have made 5 stages. Earlier these were also 4, so we have made 5 stages. First, earthwork or excavation. Then second stage, laying of foundation or construction of foundations. Third stage is substructure. Fourth stage is stage 4 superstructure, and fifth stage is protection works and completion. This is the workflow, how the inspections will happen in case of roads and in case of bridges. In case of bridges, planning, because the sections mapping is not required, there it will start with progress entry, but in case of roads, it will start with planning. You can just have a look as to what kind of alerts will be coming to PIUs, how he will get the message. In
Dr.
case,
Pateria ji, Dr.
Yes,
Pateria, we have 3 more speakers.
Yes. So he will be carrying out the inspections, uploading the image. This is a sample template of a stage passing of roads. Grading pattern, the same grading pattern as is being used by the SQMs and NQMs, unsatisfactory, satisfactory, satisfactory, requiring improvement. If all items are being graded as satisfactory, he can certify the stage. In case any of the items are being graded as U or SRI, the same PIU will visit again after rectification is done and will certify that now the rectification has been done. So it will be left to the PIU. This is the grading pattern. Here is the certificate. And a couple of such certificates have been already generated by PIUs. We hope that after this IRC, these inspections will pick up. We started in the month of August, but there were certain hiccups with our app as well, which have been now rectified as we got some feedback from various PIUs. Action taken reports will now be handled online. A flow chart for this has also been brought out. There is one important change which we are making, that now the NQMs will be assigned only on those works or on those stages which have been already certified by the PIU. Unless he himself says that the quality of work is satisfactory, the second and third tier inspections will not happen on those works. Another change, SQMs will not test now those layers which have been certified by the PIU. They will be testing prior to that. However, NQMs would continue to test all layers as they are doing now, because that is a third tier, and we are keeping it as a safeguard so that everything is not given in the hands of the PIUs. So with these changes, this is flowchart depicting modified process for action taken reports handling. The ATRs will be submitted online through the web. We will be processing online. As of now, PIU is submitting to SQC and then they are uploading. Now it will start right from PIU. So we have already assigned passwords to all PIUs. These are some more photographs of the inspections which have been done from various states. So the process has started in almost in all the states, but with a very slow pace as of now. Thank you very much. If you have any suggestions, we will be happy to still incorporate those suggestions in our efforts in going towards stage passing. Thank you once again.
Thank you, Dr. Pateria ji, for the very detailed presentation. Now we have Dr. Suresh R. Das ji, Associate Professor, IIT Bhubaneswar, with his presentation, When Rivers Rise.
distinguished chair, co-chair, and the speakers on the dais, and delegates of the dais. Thank you very much for giving me this opportunity to discuss on a very interesting and important topic and concern of the hour about the storage of bridges to flash floods. Bridges serve as one of the important lifeline structures that comes very useful, especially during crises or disasters. And in recent years, India has witnessed a sharp increase in incidents where bridges have failed under sudden onslaught of flash floods. So this presentation will discuss about three major aspects of flash floods and its impact on infrastructure, bridge failure mechanism during these flash floods, and the challenges and way forward, how we should look out for the overcoming these kind of disasters. Just to give you a brief idea about flash floods, typically the floods are divided into four categories as per their genesis. One is riverine floods or fluvial floods. Another is coastal floods, where the flood water from the sea or the rise of the sea level as well as the rise of the river water level causes flood on the coastal areas due to surge, tide and waves. Flash floods are the floods which are due to excess rainfall over a very small area, giving rise to large volume of water being poured down during a very short period of time. And composite floods are possible due to interaction of some of these three flood categories. If you look at India's scenario about the flood hazards, as per the sources of BMTPC, about 12% of India's landmass is vulnerable to flood. However, this number seems to be very less with reference to the many recent observations of about 30 to 40% of landmass is under the flood affected zones during monsoon period. And also the coastal floods are a cause of concern, as our country has around 5,700 kilometers of coastline exposed to cyclones, tsunamis and coastal floods. Now coming to the flash floods. Flash floods, this visual I think most of you have already seen in this year in Dharali, which was a very breathtaking scenario for all of us. If we wish to define the flash flood due to the cloud burst, basically this is a scenario which we classify as very heavy rainfall of more than about 100 millimeter happening in less than 1 hour time over a very short zone of 20 to 30 kilometers square. And this can act as a catalyst for flash floods when intense rain overwhelms terrains and drains. And for this kind of scenarios, our infrastructure is not very resilient. These high velocity flood flows with large debris leads to give a large lateral pressure or the lateral force to the infrastructure. There are heavy scour in the river banks, undermining of the foundations we see, and sweep away of the roads, bridges, culverts, building, etc., making our infrastructure very vulnerable. And there are many design gaps which we must think about and fill to make our infrastructure vulnerability less and make it more resilient. If we look at typically the bridge failure, okay, as a overall scenario, the contribution of hydraulic failure is about 60%. And out of this 60% hydraulic failure scenario, the failure due to scouring or the bed scour and local scour is around 90%. So this issue is really a concerning issue for all bridge engineers across the world to see how we can reduce this number further. If we look at the bridge failure mechanism, how it fails, then that may give some idea about how we take care of it. So many recent flash floods has shown us the ways our these critical infrastructure, how it is vulnerable. Okay, many of these footages you must have seen earlier. This few months back in Darjeeling, the bridge over River Tista also has basically become dysfunctional due to a flash flood. And the major challenge now is how to retrofit it, how to bring back to its operation is a major challenge, and we do not have a regulated way or knowledge, know-how to make it serviceable quickly. So this is a similar scenario in Jammu and Kashmir a few months back, scenario in Himachal Pradesh. So this is just a few to give you an idea, but there are plenty of such cases we are seeing during the monsoon season and during the flash floods in our country. So there are some cases of failure on the landslide zones, and how our temporary bridge, readiness of the temporary bridge could solve the problem temporarily. Well, if we look at the scenario around the world, the scenario is also not very different. We are seeing this kind of failure not only in our country, but it is a global scenario throughout. During flash floods, even for example, this bridge in Pakistan failed a few years back. The flood water was basically designed to pass through small drains, okay? But when flash flood comes with loads of debris and boulders, it really is a devastating aspect for the bridge infrastructure especially. Similarly, lightweight steel bridges are also not resilient for flash floods, especially when we design any structure for gravity loads. All our understanding about gravity load path is very clear, and we do a good design for that. However, when it comes to a lateral load, our structures are very very vulnerable. Okay, any increase in lateral load, the philosophy of design, the way we think about the structure's load path is not very clear to engineers, and that's what causes a lot of failures due to especially lateral loads. So this is a case in Mexico. The failure mechanisms are very similar. Just to give you an highlight, there is scouring, sinking of the intermediate piers, and then cascading effect of superstructure failure. So even developed countries like USA is also contributing to a large number of bridge failure due to floods and hydraulic effects. So if we look at the damages that happens to a bridge, typically we see damages all around the bridge superstructure, including damages to the abutment, damages to the pier, damages to the foundation, and damages to the superstructure as well, and many times complete collapse of it. So if we wish to look at the major observation we see from these kind of failures, these failures during heavy floods is happening throughout the world. Okay? And in many cases, we are experiencing heavy floods, flash floods due to cloudbursts, etc., like never before, which is unexpected. Maybe we contribute these kind of extreme events to climate change effect, and which is obviously real and is affecting us, which the visuals show to us. Although much of our built infrastructure is quite resilient, okay? Do not think that if we see one bridge failure, that doesn't mean other 99 bridges are also in the same suit. No, we do create a lot of good engineering marvels as a civil engineer, but few failures are also guiding us to look back what might be the challenges or mistakes that has been incorporated or inbuilt in the infrastructure, which we can prevent in the future future scenarios. Okay? So the core challenges during flash floods to the bridges are basically threefold. One is cover and erosion, which is a primary killer for the bridges. Then second is buoyancy and overtopping, which creates large lateral force causing drag and lift, and debris accumulation. So if you look at the cover and erosion, basically the bed cover, which we estimate due to the soil particles diameter and the velocity of the flow, gets largely increased due to the flash floods, due to the rapid flow. For example, let's say typically we design the bridge for velocity at the flood level 3 to 4 meter per second, which goes around 7 meter per second during flash floods. and giving rise to a large depth of scour which were not estimated earlier. Similarly, the flash floods, even though we design for a high velocity, the scenario of flash flood is not a very smooth flow even with high velocity. It is having a turbulent flow giving large drag and lift effect to the bridge infrastructure. And the debris accumulation is causing also a large lateral pressure as well as obstruction to the flow path. So if you can think of, we have a 100-meter bridge and the flow path of 70 meter, 80 meter is obstructed by the debris, the flow is only happening in the small 20-meter zone, which causes also again further increase in the velocity of the flow, causing scouring and undermining of the foundations. So the challenges are huge. We are seeing these failures even till date. So how do we take care of it? What is the way forward? Let us give a brief idea about that. So to look at any challenges and their solution, we have to look at how much risk associated with it. So if we classify the risk in the terms of hazard and exposure, basically any risk is classified as the combination of hazard, exposure and vulnerability. In this case, hazard is the flash floods or landslides, exposure is how exposed our structure is, and the vulnerability is the structure's weakness to these exposed hazards. And as these events are so large and we do not have any control over these hazards and very partial control over exposure, maybe we can shift our bridge from a landslide zone to a safer zone, but we cannot do that all the time. However, as engineer, we have significant control over increasing the structure's resilience and reducing the structure's vulnerability in this. So if we reduce the vulnerability, we can reduce the risk of damages to any structure including bridges. So the mitigation strategies for resilience of bridges are basically fourfold. One is we should have a good mechanism for bridge cover evaluation as well as monitoring for the prevailing bridges. We should have a good scour protection measure, river training work, and going for deep foundation in the flood prone regions. There are many, nowadays many techniques are available to see which is the best way to prevent a scour. There are many scour evaluation methodologies and scour monitoring devices are also available. In scour protection, there are many proven schemes are there which are also listed in our codes of practices to follow, including rock riprap, ground filled mattresses, gabion walls or wire enclosed mattresses, articulated concrete blocks, gravel bags, even old bridges like 300-year-old bridges are being protected from scours by dumping gravel bags. This is the London Bridge, Tower Bridge in London. And also,
Dr. Dash, kindly speak.
Just one more. And also there are multiple ways to prevent the mechanism of scour at the bridge side. For example, this bridge has a collar system, okay, intermediate. This is not a structural one, but this is to prevent the uplift of the scour material to going up. So in a way, minimizing the depth of scour. So there are many experimental ways we can think of and minimize the scour around a pier. For example, providing a sacrificial pier can reduce the scouring of the main structure's pier. So this will be not a very expensive solution, but can give rise to a large reduction of the scour at the bridge site. So there are some other protection techniques also. If you look at this video, the middle one has no collar, but there are two different collar schemes have been adopted for these piers, which gives rise to very limited scour possibilities at the collared piers. So these kind of solutions we may adopt. And river training in a wider sense covers all that engineering works which is considered on a river so as to guide and confine their path and control and regulate the river bed configuration change. Depending on the type of river, we can plan the river training work. One example of such river training work, giving an efficient plan of flood water discharge and not causing large scouring, can be seen here in this one, where this is a same bridge under construction. So in conclusion, we can do a plan for a significant risk reduction for bridge failures, considering a risk-based approach, increase free board accounting for possible flash floods in many regions. We need, for this, we need a hazard map, like we have seismic hazard map, we have wind hazard map. We need to have a flood hazard map of our country where we can actually establish which part of the bridge in that zone, and then we can come up with some factor of safety to have a large freeboard. We should have robust structural systems prioritizing continuous span or fixed connection over small spans. Longer span or minimal piers will obviously be a better option in planning stage where the zone is a flood zone. There are national standards available like IRCSP 113, which mandates flood hazard assessment, protective works and maintenance protocols should be followed. Some international practice are very good in these terms, like USA has a scour plan of action for every bridge that is critical for scour critical bridges. So if we can introduce similar kind of a scenario or a evaluation for the scour critical bridges for our country, maybe we can come up with a scour plan for the bridges and minimize to a great extent the bridge failures. And when we are making a rehabilitating a bridge after failure, post-disaster reconstruction must be built back better. And we should learn lessons from extreme flash flood events, highlighting the need for modular bridge. For example, many countries in Europe has a stockpile of modular bridges of different sizes, spans, 30 meter, 40 meter, 20 meter spans, which can be easily mobilized and put for a few months to years, okay, on a hiring basis. So that kind of inventory, if our country can have, that will make the post-disaster management much easier. And always a happy story, ending with a happy story, that even though large infrastructure failure happens, this bridge, being a single span bridge, having a good freeboard, can also sustain during these flash flood events. So with this, I thank IRC NRDA for giving me this opportunity to present this stuff, and IIT Bhubaneswar and many of my students who has contributed in preparing this presentation. So with this, I thank you all for your kind attention.
So thank you, Dr. Suresh R. Das ji. Now I'll request Sri Rishi Baderia, GM, MPRRDA, and Sri Saurabh Jain. I think both of you are. Kindly stick to the time because we have already overshot it. There's one more presentation.
Thank you, sir. Respected DG sir, respected Pateria sir, respected Gupta sir, my guru who are also present here, and respected other seniors and delegates present here. Good afternoon, all of you. As I am here to discuss and present maintenance management towards asset management system. So for this, I would like to first describe about our asset that we have created in past span of 25 years, 20 years. As you can see, our assets include a huge network of roads, nearly about 1,000 kilometers, and pointing specifically 88 more than 80,000 kilometers. So for constructed in different phases of PMGSY described here. So for this, as you can see, this huge network of roads required a specific maintenance also, because if we lack in maintenance, we definitely lose these important core network related to address those who are located in remote areas, which are generally ignored. But with the help of PMGSY and RRDA, now we are in position to service in those areas also and maintaining that network. So for this, I would like to describe our maintenance system on the behalf of MPRRDA. for in MPRRDA, we have maintenance, a specific maintenance management system in which we have basically two parts for the maintenance of each road. First DLP and second is post DLP. DLP means defect liability period, which is started immediately after the construction of completion of road for the next 5 years, which are completely responsible by the same agency who constructed the road. And in post DLP maintenance, we have separate agency for next 5 years onward after the DLP period. So basically the difference between the DLP and post DLP DLP maintenance is post DLP maintenance has some special features which is divided into 4 parts. In first part we have initial rehabilitation works, which are initial rehabilitation, second part routine maintenance, third part renewal, and fourth emergency work. In initial rehabilitation works, we have that kind of works or need which are not covered during construction stage, or basically we can say which are not during not needed during the construct state, but the lapse of time some special works required some kind of attention, which will be provision in this initial rehabilitation work. Next we have the routine maintenance, in which each road, in which we have a provision of inspection of each road on bi-monthly basis and payment also on bi-monthly basis, so that no single road remain uninspected or unmaintained during the course of maintenance period. Third, we have the renewal, and fourth, we have emergency work. I would like to especially mention about the renewal work, in which we have a provision of resurfacing of each road after 5 years as required, as and when required. But we have a specific provision after every 5 years we resurface the road, so that no road remain with potholes or patch during the serviceability. Each road we have, because of this provision, each road remain unaffected by any damages, and free from patches and potholes in the remote areas also. So I'm proudly say that MP has the only state to provide these kind of provision to address the roads for specifically maintenance in remote areas. Last have emergency works. Emergency works included those work which are works generally created or damages during floods, excesses, heavy mining in specific areas. So we in maintenance, basically post DLP maintenance, we have divided the maintenance system in very systematic approach, so that each road will be maintained at each point of time at each point of space. In post DLP maintenance, we have also MTN 4 part, post 5 year, post 10 year, post 15 year. Post 5 year means after DLP period, post 10 year, another 5 year maintenance, post 15 years, another 15 years maintenance. And we are also now introducing by the end during 2026 or by the end 2026 post 20 years maintenance. And I think MP is Madhya Pradesh is only state who has roads of aging more than 20 years of age with proper maintenance. Even after 20 years, road is servicing very well to farmers, marketing places, hospitals, or we can say that at each point of time, our 20 years, in 20-year maintenance period, roads having pavement which are crossing their design life 2 times. So I think I'm proudly to say that TTM post 20 years maintenance also being started. And after that, we have in maintenance another important aspects of upgradation also. So for this, I would like to invite Saurabh Jain to describe uh, another this in depth of this. Thank you.
Thank you, VC. Now with the continuous development of the road and change in the traffic flow patterns, there is a necessary need for the upgradation of the road. Roads are mainly damaged due to the heavy vehicular movement because of the mining and other. Therefore, Madhya Pradesh government has special policies for the upgradation of the road, and it has a clear line of action for each road to be upgraded. For upgradation of the road, we have standard procedure. Firstly, the road which is affected by the heavy traffic is to be inspected by the PIU in charge, that is the GM, General Manager of the PIU. Then he has to report the damages to the higher authorities. Then higher authorities send state quality monitor to justify that road is damaged because of the heavy vehicular movement or any other causes. Then there is joint inspection of two chief general manager who discuss about the technical aspect of the road, and if required they suggest for the Excel road survey or ATCC survey. After the ATCC survey and all the necessary technical aspects, the proposal is being made and is presented before the state technical committee, and the final approval is made. As a result of this, this is truly time-bounded manner. Within 3 to 4 months, we are able to create the proposal and make a tender and have an opportunity to upgrade the road. In last 10 to 15 years, around 825 roads we have proposed for upgradation of the length of about 5,249 kilometers, out of which 755 roads have been completed of a total length of 5,034 kilometers. Now, the second most important challenge is the special repair work. With the change in the climatic condition, there is a fresh flood and other earthquake and other natural calamities. The road which are under the DLP package has to be attended for this work. In this also, the state government has a well-defined right of approach. In this, the road which is affected by the natural calamities has to be inspected by the general manager, then it has to be inspected by the CGM, chief general manager, and have to discuss about the technical aspect of the road, and then there is a approval from the district administration, and the proposal combinedly prepared has to be presented before the state technical committee. Then this proposal is finally approved and proceed for the tender. In last 5 years, we have around 295 work for special repair of total cost of 72.45 crores. Out of which 264 work has been completed and 20 works are in progress. Now the main thing is, at present we have around 26,000 number of roads. In order to maintain this road during its whole life, it is important to create the estimation of that road will due course of time. For this, MP state government has developed a software called Samvik. It is simplified application for monitoring of bridge work through e-governance method. In this software, before 3 months before the completion of present contract, estimate is being prepared for the next 5-year maintenance. It is time-bounded software. As soon as the estimate is finalized, the TS is generated by the chief engineer, chief general manager, and administrative sanction is made within 15 days after the technical sanction is made. And as soon as the administrative sanction is made, this portal is directly integrated to the tender portal. The package is automatically pushed on the tender portal, and tender is made, and the new agency is there for the maintenance of road as soon as the old contract is closed. And this is the way forward. With due duration of time, as a result of well-defined maintenance mechanism, we are able to protect our road for around 20 to 25 years. Now, we have started our maintenance from performance-based routine inspection to now we are we are presently at web-based routine maintenance system. But now we are looking forward towards the comprehensive and budget-oriented maintenance approach, which is MP-WEMS. Now, as a result of continuous maintenance of the road, as a result of this continuous maintenance of the road even have completed their twice the desired life and still are in well condition to serve the rural areas. Due to this regular maintenance of the road, there is a reduction in the travel time, there is a reduction in the total consumption of the fuel. As a result of which, there is a decrease in the carbon footprints also. And these are the some photos which shows the maintenance done under MP-IRDA. Thank you, sir.
So thank you, Shri
I
Saurabh Jain ji.
I would also like to thank Mr. DG sir, Sri Shukla sir and Patelia sir for representing us or that maintenance scheme of MP-IRDA at this platform.
Okay, thank you. So thank you. Now I invite Dr. Anjan Kumar ji for his presentation.
A very good afternoon, everyone. Respected chairs, fellow speakers, fellow engineers, academicians, researchers, and the paving industry present over here. Welcome you all for this session on the rural roads. Today, I am the last speaker of this session. Most of us are waiting for the session to end, but I'll not take much time. I'll try to adhere to the timeline. So I'll be sharing you with the experiences in the field, what we have been introducing in the country from the past 3-4 years. What with NIRIDA I have seen from the past 20 years as an associated from various positions, from academicians to student to a PTA, STA and all is, whenever a new technology perturbates in the country, wherever the largest sector have difficulties, NIRIDA extends the shoulders and lifts the technology. And the people present over here may be fortunate who associated with NIRIDA and we have seen this technology achieving on roads. So in my continued presentation, I will be discussing mostly on full depth reclamation. Some of the keywords for the audience present over here who are aware, full depth reclamation is a in-place recycling technique where the complex payment structure, that is the flexible payment, itself shows a resilience to adapt to the change and requirement of the generations. For example, there are various alternate types of payment compositions where flexible payment offers itself for recycling compared to any other payment structure. So the full depth reclamation technique, how we adopted in the rural roads, what targets we initially had. Now recently we have come up with the IRC guidelines. What NIRIDA's experience in the past 3-4 years has contributed to that guideline fine tuning, where we still have certain challenges, what we have to overcome in the future, I'll be discussing on this. So as we all know, now the unit rate of any of these payment materials, especially the rural road composition, is closely touching as high as 8,000 rupees in most of the parts of the country where we have a lack of raw materials. Given with that, now we are going with recycling. We have seen 4 phases. PMGS phase 4 is under full swing. But whenever we take up any maintenance, as now my fellow speakers were discussing about asset management and all, where we aim for 20 years, 25 years, where we have already created around 8 lakh kilometers of rural roads, maintenance is a big challenge. And one technique we have already honed or we are going progress is full depth reclamation, where the technique is simply to enhance the structural behavior of our rural roads by stabilizing with required additives. It is simple 4-step procedure where it brings a lot of benefits in terms of environmental benefits, cost savings, and most importantly for a rural road where traffic diversion and management is a nightmare to all of us here, productivity. With this technique on a plain and rolling terrain, the productivity can be as high as 800 meter to 1.4 kilometer. Even in challenging steep terrains where I come from, okay, the productivity is somewhere between 400 meter to 600 meter. In not only in terms of longitudinal productivity, it also in terms of vertical productivity, where the twin layers or 3 layers is eliminated by providing a base cum sub-base layer. So thanks to NIRIDA, I'll just go to the content of the presentation. Now, across the country, NIRIDA has encouraged on a pilot basis or a full-scale basis the implementation of full depth reclamation technique. My figure may not be updated. All the NIRIDA officials and the PAUs present over here will have the updated number. Some of the states, if I have missed out, where they are implementing full depth reclamation, kindly excuse me. So this technique consists of basic 4 stages, where we assess the in-situ materials, identify the additive dosage requirements, identify the machinery's requirements. So first step is to reclaim and pulverize with the necessary additives, use compaction devices to ensure we don't fail in compaction, and further we ensure that adequate surface is prepared to the required profile and grade with good quality control. For the first time in NIRIDA, we have introduced PMU, that is Project Management Unit, especially to shoulder the PAU as well as the paving industry, the construction crew, to implement these new technologies, where we started from conventional quality control in terms of gradation, cement additive spreading using distributors, modern machineries, conventional density measurements. We use density gauges, nuclear gauges. We use phenolphthalein tests to ensure pulverization and homogeneity in mixing. We did lot of in-situ casting to understand the strength development, and finally, most of the PAU engineers were happy when they see the core of 300 millimeters coming out with lot of efforts being put on this site. So this we have achieved. To see further where we stand, now recently when NIRIDA started, it was a brainstorming for all of us, where with some minimal laboratory experiences, with some minimal field exposures, with lot of literature in hand, we started looking at with target gradations, where we had a Ministry of Rural Development gradation which served as base cum sub-base layer. However, now IRC has come up with a new modifications. When we look at the field data, the gradation whatever now we see in IRC, it is meeting with the field data which I have presented in the below figure. So now we have a relaxation to go up to 75 millimeter. Earlier that was not supported with the minimum experiences. With this, the conventional understanding of strength development, where now I see a lot of the PAUs, SQMs, NQMs, as well as the academicians are facing little challenges, is the strength gain. When we do it in a very controlled environment in a laboratory at a particular dosages, this is the expected cementitious material strength gain, where it subsidizes over 14 to 20 days and it almost asymptote after 28 days. As well as some of the basic descriptive statistics, if I take out from the data which I have pulled across the states, the moisture content varies from 6 to 11%. The maximum dry density we are targeting varies from 2000 to 2200 kg per meter cube. The cement demand varies from as low as 4% to as high as 7%, and water cement ratio corners around 2%. The earlier NIRIDA, we targeted the 7-day strength should be somewhere as low as 4.5 MPa, that is the unconfined compressive strength. We restricted the maximum strength to 7 MPa to ensure there is no cracking issues which may retard the technology and our learning. If we take this in a laboratory exercise and look at this legend, what it shows, the blue color and the red color line, it is at 2 different timelines. One is at 7-day curing time, and the one is at the 28-day curing time. The window which I have showcased here identifies the cement dosage what we all have been targeting, somewhere between 5 to 7%. And also even the laboratory data supports, not always we can meet the targets, we may have certain challenges. Thanks to IRC again, we have revised this from some of the important input from all the paving engineers. Now the target is relaxed to 3 to 5 MPa for 7 days, and for 28 days the target is given again 4.5 to 7 MPa. From here onwards, I would like to present the field insights, where that 7 MPa upper limit is still a challenge for all of us for various reasons. See, if we see the compaction, these are all very fundamental information. Compaction is the only utmost important thing an highway engineer should accomplish in pavement industry. If you take any layer, either it could be subgrade, embankment, subbase, base layer, asphalt layer, or a concrete layer, compaction is the critical parameter which is very sensitive to performance of any pavement structure. So theoretically, it is very closely dependent and the compressive strength is very sensitive to compaction levels, as well as the compaction delay, the time we work in the field. Sometimes the machineries, the supply of materials and the crew are not groomed to complete the work. The entire PMGSY rural road crew was uplifted in 1-2 years from the waterborne macadam to a stabilized layer. Modern machineries, most of them have not seen a tandem roller. NIRIDA introduced them to pad foot roller. NIRIDA introduced them to reclaimer. At the country where the reclaimers were in single digit, now through NIRIDA, reclaimers yesterday I heard, it is more than 200 across the country available. So all this was done in a short period of time and the most of the PAUs shouldered it. So this is the timeline which we should work. And if I collect the data across the states, the distribution of the strength and the cement dosage required varies. Where it hints as low as minimum 3% cement can be considered, and the strength variation is not always 7%, it can go, not always 7 MPa, it can reach as high as 10-12 MPa as well. And also one critical thing, since most of the PMGSY roads have a typical composition of a granular subbase, 2 layers of waterborne macadam and a premix carpet, when it comes for rehabilitation, it may not be necessary the crust remains always the same. Some states would have locally available gravel base, some states would have used granular subbase, some states would have used WBM grade 1, some states would have used WBM grade 2, grade 3, etc. Various maintenance across the period would have caused variation in the crust composition. To understand this, we bifurcated and studied what could be the impact of coarse to fine aggregate ratio, where it cornered again a balance of 60 to 40%, that is 4.75 mm can be around 60% and the material passing 4.75 can be 40%. If we corner that, most of our strength can be accomplished. And if we don't have that much material left in our pavement crust, definitely we should use only locally available material as long as we are going for a cementitious product. Especially in the hilly terrains, natural river run gravel, we have done extensive study on that with the help of all the PIUs in the northeast. That can be a suitable replacement material. And if we process that with one pass of crushing, cement dosage of 1 to 2% can be minimized. Now comes the field data, as we all have been seeing. Now whenever we go take some course, NQM, SQM, myself and our PIU team, oftenly we have challenges of course getting braked in the middle, and sometimes when we take course, the strengths are substantially high. So again this tells us to relook at the construction process. See, very well documented in the literature that the stabilized layer, whenever the strength is more than 6 MPa, 7 MPa, it is susceptible to cracking. Even though we are providing a crack relieving layer, the cracking intensity and the concentration of stresses could be very high and prematurely section may fail. So that's why in the guidelines it is suggested to restrict the higher strength gain as close as 7 MPa. But in the field, sometimes we get 9 MPa, 10 MPa, 12 MPa, 14 MPa. 14 MPa is what sometimes I have also seen, but mostly cornering around 7 MPa. What could be the possible reasons? See, mostly we are now using cement distributors. Cement distributors, the quantity of cement is controlled by spread rate. This three-dimensional figure will help us to understand. If the target density is around 22 kg per meter cube, you have a cement dosage of 5%. You expect to spread a cement of 25 kg per meter square, provided in most of the works the depth of reclamation is 250 millimeter. Because of the undulations naturally existing and one pass reclamation process what we are adopting, if the thickness is shattered somewhere between the thickness is varied higher than 250 millimeter, the cement dosage is on a shorter stage. If the thickness gets lowered due to the profile variation to 240 millimeter, 230 millimeter, the cement dosage by default increases. Even though PIU check the quantity, because of the profile variation, thickness variation, the cement dosage increases inherently. So because of that, when we take the cores, and if you noticed, cores are mostly concentrated around 200 millimeter height. Very rarely we get a core of 250 millimeter height, maybe because of our reclaiming process itself. Because of that, the cement dosage may increase and you may get a higher UCS in the field. Other thing, very, very important, in the laboratory, we control curing in an ambient condition. I may use a moist room, I may use a desiccator, I may have a super specialized AC laboratory where we maintain the temperature somewhere between 25 to 27 degrees Celsius. In the field, the curing is done intermittently. The crew, whoever he does the curing, whenever the surface is dry, they apply the moisture or a cover. This kind of triggers an accelerated aging in the field, which may further contribute for a higher strength. As we dig the literature, if the strength is achieved, that means stabilization is done. If the strength is not achieved, stabilization is a failure. So in our case, we are getting a higher stabilized strength, maybe because we may have to fine tune our curing process, fine tune our reclaiming process, and make a much more quality control on these factors which I have recommended higher, like cement dosage, reclaimer productivity itself. For example, the operating conditions is somewhere between 3 meters per minute to 6 meters per minute. So that has to be further looked at. So finally the insights, how to design. Now we have a guideline. We can consider a minimum thickness of 200 millimeters, which was eventually available for us in IRC SP 72 as well as IRC 37. It is now recommended, yes, we retain a GSB layer. We can also reduce the target 7-day strength to 3 MPa. In the preparation of DPRs, we don't have to always go with a minimum 5% cement dosage. We can also look at collating all the data across the states. NIRIDA can collate and check whether a minimum 3% dosage as a starting for the estimation of the DPRs can be considered. And PIU should also make provisions for 1 pass or 2 pass based on the site-specific conditions. And how to avoid multiple mixed designs. This PIU, most of the PIU will ask me often, see, this is governed by only 3 variables. You have to ensure your plasticity of the material is relatively cornering between somewhere 8 to 15%, and the coarse fine aggregates is not significantly varying. Then only you have to vary at site after 10 minutes of gradation checking and PIU checking maybe 1 day is only the cement spread rate. Some integrated quality control is required wherever the UCS alone may not certify the quantity. For example, use of lightweight deflectometer, dynamic cone penetrometer, falling weight deflectometer, some guidelines. This I have given a rough guideline based on the Swedish method to develop deflection bowl parameters, which will help us to identify quality of construction is sound, warning, or which needs, or otherwise it needs to be relooked. With this, I would also like to thank NIRIDA. We have done significant resource development in the country. In Northeast alone, we would have conducted several programs, around close to 1,000 engineers we have trained on implementation of new technologies, utilization of local materials. Most of you here would have attended us. With this, I extend my thanks to NIRIDA, MORD, SRDA Assam, Arunachal Pradesh, Meghalaya, Mizoram, Nagaland, and most importantly Uttar Pradesh, who has sent me the significant amount of data and required inputs, MRTH and relevant IRC publications. Thank you everyone.
So thank you, Dr. Anjan Kumarji. Now we'll take a few questions we have received from the audience. So I'll hand over the mic to the co-chair.
We take the question answer. Mr. Lakshmikant Tripathi is available here. I read the question. Please list the component of old good bridge material and contemporary bridge material to find out the region of durability with the difference of material and mixed design etc. I think it is related to Mr. Suresh, Dr. Suresh Das. Another question, P.S. Khandelwal, use of plastic in BT road. I read the question. Why more road are not included in this process? Which state use the maximum such plastic being in India, is this suitable for the hot weather state? And last question we received, design of bridge from Mr. M.S. Kulkarni, SCPWD Circle, Ratnagiri. Any codal provision modification are made in the progress in view of the persistent flash flood occurrence? Also for combination of flash flood and coastal flood in view of climate resilient design.
Yeah, okay, I can answer the questions regarding the use of plastic in BT roads. Why more roads are not included in this process? Actually, this is the human tendency that unless anything is proved, we don't use that. So that is why there is a process. If you see, there are many circulars by Ministry of Road Transport also to use the waste plastic in roads. And RIDA has also issued several circulars to use it in that. But still people are having some hesitation. Though in PMJSY many times we have said if you are doing anything on the experiment basis and if it fails, then the blame will not be to the PI because this is the experiment only. But still I can say that people are hesitating, they are shying in using the waste plastic. But in near future it will be done. Which state use maximum such plastic layer in India? Actually, state-wise data we don't have, but we have the compilation of various works where we have used the waste plastic, and not only in this form, waste plastic is being used in different other forms also. Like one road was made in BPCL complex, Mumbai, where this BPCL has given this project and we use the boards in the form of plastic. So various different forms of plastic are being used, but right now I cannot say that which state is having the maximum use. Is this suitable for hot weather, etc.? Hot weather state. So actually it is more suitable for hot weather state because after introducing the plastic, it is good for stopping the rutting. But if you ask for the fatigue, then it is not so good. So that is why I will say that your question, hot weather state will use it or not, it will definitely use by the hot weather state and less use by the cold weather states. These are three questions by Mr. P.S. Khandekar. Thank you.
Very good question has been raised on codal provision modifications made in our guidelines and in progress in view of the persistent flash flood occurrence. In fact, if you remember, there was a major flash flood in 2013 in Kedarnath that has actually give rise to think about flash floods and their strategies to mitigate in our country. We come up with a guideline in 2018 for flash flood, how to deal with mostly highways in flash flood scenarios. But as such, we do not have a plan as such yet for thinking of flash flood considerations into bridge design. Okay, we need to deliberate on this. We need to come up with some ways of preparing a scour protection plan for bridges which are susceptible to flash floods or critical to flood zones. And next question was also for combination flash flood plus coastal floods. Well, there is possibility of flash floods and coastal floods, but again, we need to have some ways of dealing with that in design, in maintenance, in measuring the scour for the existing bridges so that we can make it more resilient. So we need to work further on that regard.
Sir, addition to the point which I raised in the earlier session also, you are the right person to ask this question, sir. Since we are facing this kind of flash flood which you talked about in the Ashpur catchment area in Nepal, we are having this problem in Kosi and Bakra as well as Parman River. We are getting the pier sinking which I had discussed with you, sir. We want a written and in detail attachment. You have talked about the precaution. What is then some piers are sinking, then what we do? Entire length you have talked about the precaution and afterward, jacketing and lifting. What is to be done for the new bridges, but what is to be done which has already been built? And how to go about these kind of flat feathers to hash on with, sir. We'll have a discussion later on. And thank you, Mr. Pateria, for including this, sir, as a stage passing, which I was announcing for very long time. It is late that it at least came, but it should be implemented. Whatever we have implemented in PMGIS5, we are also implementing, sir, in the rural roads in Bihar. Now we have done 1,25,000 kilometer tender. We are going to implement that. Thank you for doing that, sir. So nice of you. And sir, as far as your waste plastic material is concerned, we are pioneer in doing it, sir. Because of the initial initiation by Mr. Pateria, we started doing it in Purnia. We already have a godown of waste plastic material. And we are also implementing it into Bihar, in the rural roads. We have given, being the chief engineer, now we've given that in confirmation to the BOQ. And it is mandatory nowadays to use it, since it is a win-win situation, sir. Please implement it according to the PMGIS5. Sir, we will follow it the rest of the states also, in all the rest of the schemes.
So please give your name and designation.
Sir, my name is Arvind Chaudhary. I'm the chief engineer recently. Sir knows me personally very well. And my younger brother is the minister of the department. That's the reason we have been able to so much in detail. We have done it for state of Bihar. He knows me personally, sir. Thank you so much.
Okay, so Dr. Das, Mr. Basa wants to make an intervention.
Thank you, sir, for the permission. I will just continue with what Dr. Das has said. You know, IRC has already been intimated by Government of India to take care of the flash floods, and we are taking care both in B1 and B3 committee, number one. Number two, regarding your query, sir, as the chair of the foundation committee, I request you that you write to IRC or to me. I have given my email ID. We will definitely take care of it, because the foundation failure is a matter of great concern, not only in PMGIS bridges, but also in the rural bridges and the highway bridges everywhere. So we are there to take care of it, sir. But we need the specific information, and give it to us. We will definitely take care of you. Thank you very much.
Okay. So one question I'm reminded by the...
A great presentation by Dr. Pateria. Question to Dr. Das. Integrated bridge, performance of the same worldwide, has it been covered? Or is it recommended with large span structures? For Dr. Das, yes. Integrated bridges without bearings, and as you suggested, large span. Has it been covered in your study, and is it a way forward?
Well, integrated bridges are really good in sharing the forces from the superstructure to substructure. So I feel they could be much better solution for flood regions. Yeah. Okay. Integrated bridges can sustain. They are more resilient than the simply supported bridges.
So we are a bit short of time. Ji.
I am Arvind Kumar Jain, former Engineering Chief UPPWD. I have two questions. One question to the first presenter and another one to the last presenter. So coming to the first, to Dr. Reddy, who presented very well and very timely presentation on the APT test facility. Here I want to make raise few points for his clarification. My concern is that your facility has the wheel moving in on a repetitive track. It doesn't digress from that track. And the second one is that the wheel movement is in a circular fashion. And third one is that it is unidirectional. And fourth one is the weather. So how do you account for these four aberrations in the final prediction of the performance evaluation of the pavement?
Yeah. You want, like, it's a circular, yeah, it's unidirectional, okay, and it moves. And what is your concern, like how you integrate or something?
Yeah, I mean the real life performance, how will it be predicted? Because it is not the real life situation of a road.
Yeah, real life, okay, fine, good question. So, like now, most of the wheels, generally in rural roads, other roads, they channelize in one lane, but there will be some distribution on other lanes. Yeah. So here, this facility can be also extended for wheel wandering also. We can even laterally move it. But right now, as I said, no, it's money is very limited, and we are only doing only one particular direction. But money is available. We can also make the wheel wander. That we can do it. But right now, it is only in one direction,
And only on a one path we are doing. And we can extend it to even for wheel wandering also we can do that. And
weather
load also
conditions?
we can increase. This is capable of introducing a load from 3 tons to 6 tons, even 10 tons also it can go.
Okay.
So overloading effect and all other things like somebody said that FDR, all these things, before testing, before using in the field, we can use it here.
And sir, the
Actually, we have already run out of time, so
sir,
you can
just
continue.
very small question to the last presenter. Actually, he talked about the FDR. What he talked about the FDR, that FDR is not being practiced by the PMGSY per se. PMGSY is practicing the FDR, including the subgrade soil. Whereas the definition of FDR in that IRC 142 doesn't include the subgrade soil. So, what's your comment on this?
Yeah, see, updated IRC suggests to exclude the subgrade. Wherever the subgrade was included, if it is a suitable material only in the initial trials, it was recommended.
But you people are shy, including the subgrade actually. In Lucknow conference also I raised this issue, that the FDR which is being practiced by PMGSY is not the FDR which is being defined in the code. So either you change the term of FDR for the PMGSY model, or you revise the definition of FDR in the code.
There also, excluding subgrade, it says if the subgrade material is unsuitable for stabilization, which would attract higher additive rates and all, it should be excluded. And most of the cases, if that is not
the
case,
subgrade material is the ordinary soil on the roads. Subgrade material is just
ordinary soil. If the PA characteristics may permit, and if there are no locally available material, at that time it would have been done utilizing that so-called subgrade soil. Otherwise, it is always recommended to exclude.
Then why to exclude that subgrade? You include the subgrade.
We have to maintain an FRL, so we have to exclude the subgrade, and reclaiming the subgrade sometimes causes low structural
I think that's a larger issue. That's a larger issue. It was raised during the IRC special session. I think the IRC would respond to it. So before I pass on the mic to my co-chair for giving comments on the presentations, I'd like to mention that all of the presentations were concerning real issues on the ground, and these would be very useful going forward. And the spirit of innovation is alive. I would request all my colleagues and stakeholders to carry this spirit forward. So over to you for the comments on the presentation.
Thank you to all presentation, which was on the rural road challenge and success story. First presentation was from development of accelerated payment test facility to evaluate the payment of village roads by Dr. M.A. Reddy. I think it is a revolution in the rural road area, and it is time taken for this is almost 1 month. We can evaluate the facility before we approach to construction, such as rural road sanction, and then we do this exercise. It is better to use this facility initial stage pay, and I think that it is a very wonderful presentation and revolution in the rural road. Wet method of use of waste plastic in bituminous layer. We are have a IRC code in the use of the waste plastic in the dry method, and now they have presented that wet method of use of waste plastic will be useful, and it is very useful that the plastic will not disintegrated in the hot mix batch before mixing to the aggregate. We appreciate the Mr. Dr. Parveen Kumar, IIT Roorkee, and he is also principal technical advisor and coordinator to the NRDA. Very good presentation. Stage passing for quality assurance, I think this is a new idea, and we have the almost 3 pages in the PMGSY, and now we are proceeding to the 4th page, and this will be a new era that it will enhance the quality of the roads, that we have stage passing such as subgrade, base course and the wearing course. So it will be also a corruption free and available to the public on the Obamas. I thank Mr. I.K. Pateria ji for their wonderful presentation. When river use storage of bridge and plus flood, this is the need of hour that we have almost many places that plus flood arises and our infrastructure has been washed away with the flash flood. They have pointed out that region of failure are the score and erosion, drag and lift, debris and impact, and buoyancy. So, according to Professor Suresh Das, we must see these factors before design the structure. And so our structure shall and should be resilient, eco-friendly and sustainable. A presentation was made by the MPRRDA, that maintenance management toward the assess management. This is a lead taken by the MPRRDA, and if this is regularly maintained by the IT system, we will have the better roads in the rural area. And last presentation was the full depth recumulation. I think it is the today almost in all areas we have FDR, and must continue this process, as the FDR technology is recycling the material, and it is eco-friendly, because we are using our natural resource in road and infrastructure day by day, and we have created eco problems also, that we have more and more natural resources used in our construction. So we must use recycling process as FDR in full depth reclamation as well as the layer reclamation. I thanks all the presenters for their wonderful presentation from academia as from the field officer and their institution like IIT Kharagpur, IIT Roorkee, IIT Guwahati, IIT Bhubaneswar, and from NRDA and MPRDA. All these presentations will enhance the quality of rural roads and the problem raised by the new issue as flood plus flood. There must be a coordination, that theoretical as well as practical. We must learn from the experiment that the result we obtained in the field as well as the laboratory must be harmonious and must be useful in our rural road construction. Thanks, sir. I hand it over to Chair, sir.
So with everybody's permission, we close this session, but the the announcer has to say something.
Yeah. Thank you so much, sir. And thank you all the presenters for your insightful and thought-provoking presentations. We truly gained valuable knowledge on innovations in pavement technology, quality assurance, and asset management. With that, we conclude this technical session, and let's start the felicitation. And to do the honor, may I please request our chairperson and co-chairperson to kindly come forward for our presenters' felicitation. We'll start with Dr. M.A. Reddy, Professor IIT Kharagpur, STA Coordinator. Next we have Dr. Praveen Kumar, IIT Roorkee PTA Coordinator. I know it's a lunch time and we are not done with our lunch, but still we can show some energy. Dr. I.K. Pateria, Director, NRIDA. Dr. Suresh R. Dash, Associate Professor, IIT Bhubaneswar, STA team member. Shri Rishi Baderia, GM, MPRRDA, Ujjain. Shri Saurav Jain, GM, MPRRDA, Sagar 1. Dr. Anjan Kumar S., Department of Civil Engineering, IIT Guwahati. And now it's time for the felicitation of our chairperson and co-chairperson of the session. And to do the honor, may I please request on stage Engineer Sashmita Nayak, Chief Engineer, Works Department, Odisha. Can we? So as the chairperson of the session, we had Shri Amit Shukla ji. As a co-chair, we had Shri D.R. Meghwal. Thank you all our presenters, our chairperson and co-chairperson. Everybody please come forward for a group photograph. And with this, that's a closing of technical session 16, Rural Roads, Challenges and Success Stories. We're going to resume our technical session after 15 minutes. So everybody go grab your tea or coffee or have your lunch and come back after 15 minutes. We are about to start the next technical session. Thank you so much.
Good afternoon, Chair, Co-Chair, fellow panelists, members of the distinguished audience. This session happens just after lunch, and the session concluded only about a little while ago, and therefore probably we have a smaller audience. Nevertheless, those who are here are people who are interested in these developments, or I mean, at least that's a sign of happiness, and we are very grateful that this opportunity has been provided to us. Digital is the technology which allows us to do wonderful things. I remember I had joined the Ministry of Rural Development in 2020 April, just after COVID, and the government had announced that they will pass about 500 rupees to every woman for next 3 months, and this was to be done immediately after the announcement. And you would be very happy to know that we were able to do it immediately in about 7 days, because we had the data of the women who had opened Jan Dhan accounts, and the data was sourced from the public sector and private sector banks, having had a specific identifier for Jan Dhan accounts, and then this was immediately passed on. So digital has that kind of potential, and we see its application everywhere, be it railway booking, airline booking, cane management. So you take an area and there is application. Even in the airports where you go, you have this DG Yatra, and you immediately, without the need of any frisking by the security person, you immediately get through. So how, having had this kind of potential, how do we harness this for the highway sector application is a task that we set before us. And I would like to share with you that Rodic is a company which is about 25-year-old company, but since 2015 we are striving towards having a digital backbone, and I'm very happy to share with you that our operations are completely digital now. There is no operation which is happening manually at this moment. In fact, some of the solutions that we will be presenting to you and are the solutions that we had designed for ourselves, and then we showed it to the client, and client felt interested. For example, taking a very simple example, your field engineers do inspection, but you are not sure if the guy has really inspected, or if the inspection has passed, whether the quality of the judgment of that person is indeed of the sound one, and whether it should have been passed. So for our purposes, we designed this process, and now we have extended it. So it's a 25-year-old company. We have about 2,500 professionals. We have executed about 170 plus projects in our life, and 35 of them have been funded by multilateral banks. So we have presence in multiple sectors, bridges, highways, tunnels, railways, urban infrastructure, and most importantly, digital transformation. In fact, I head its digital transformation and advisory business. So our specialty is that we provide comprehensive solution for the entire project life cycle. It's not concentrated to or focused on one aspect, but all from inception till execution till the project gets closed after completing its operation. So entire life cycle is area of our focus, and we apply technology very intensively for deriving the transparency, the accountability, and such other efficiency and such other benefits that we can derive out of it. The segments that in which we are working are digital transformation. One of the very significant work that we have done, and it's not related to the highway, but it's quite dear to us, and I can't hold myself back from sharing it. In Bihar, we have been able to digitize the entire health system from sub-center till district hospitals. And entire workflow of the patient, both in the OPD and IPD, are entirely online, and the health department at any level can view the flow of patients, the performance of the doctor, the dispensation of medicine, the utilization of the diagnostic equipment, everything is available online. And there are multiple other projects that we have done in the digital transformation space. Project management services, of course, is what is traditional bread and butter. Infrastructure advisory services is one area which where we have worked, and we continue to expand our presence. And engineering and design services is also bread and butter for any consultancy firm in the infrastructure sector. So the what is digital project management? So basically, digital project management is project management, first of all, but where you bring all the elements of the project management together by bringing all the operations online, from planning to execution to monitoring, reporting, everything is brought online. And this will include contract management, financial flows, safety compliance, citizen engagement, quality checks. All of it are included in the digital project management. So what enables digital project management? What are the elements of digital project management? One, the collaboration platform. So everyone gets to know there is one single source of truth, and everyone accesses that, and the project management tool enables everyone to collaborate together. The workflow digitization is another area that we attempt. The AI ML analytics is now becoming the core of our activity. So we can, by analyzing the images that we capture, we can estimate where the defects are there, what kind of defects are there. We can do a predictive analysis. We can not only find out what kind of environmental challenges we face, we can also automate some of the workflows, and many other benefits are there which can be handled by using AI ML analytics. GIS mapping and digital twins are tools with which all the audience in this house, I believe, are familiar with. What we also feel is important is central command and control systems. And I had first-hand experience when I went to Korea and saw their Korea Highway Corporation. In about that was in 2019, and I think they had set it up not less than 20 years ago. So for any self-respecting public works department or road holding agency, the centralized command and control system for controlling and monitoring the project execution and the project maintenance, the highway maintenance and operation, is a critical activity, and sooner we focus upon that, the better it would be for the country as a whole. So what kind of benefits do we derive out of it? You can see we all know the kind of benefits, but I want you to expose some of the data which is there as part of the literature. So in design and engineering phase, by using digital tools, you can achieve a cost saving of about 15%. In the entire construction workflow, you can achieve cost savings of about 8%. You can have time savings of about 17%. Why we are concerned? In NHAI, when the projects were analyzed, we found that only about 1/3 of the projects were completed within original cost and original time. Rest of them either had time overrun or cost overrun. In the real benefit that derives is when we link the digital with the project operation. In Bangalore, what they did is that at these signals at cross sections, they introduced AI based vehicle actuated control, where the signal duration was dependent on the length of the line. And when they did it, they found that the travel time had reduced from 15 to 33%, and the manual intervention was reduced to about 5% from about 1/3 at that point of time. And also the benefit in terms of the enforcement improve about 700%. So you can see the benefit that one can derive out of it. Obviously, data collection efficiency, etc., are of course there. In RODIC's road asset management is one of the key offerings from our side, and we not only do road surface assessment but also defect identification using artificial intelligence, and we also integrate public grievance redressal management because the grievance about the status of road can not only come from people within the system, but people outside the system are the ones who actually experience the road condition, and therefore their feedback is important, and we involve them as our part of design. We also include that as one of the key element. So we use another tool called digital platform R360, and it has multiple modules, and it's an in-house platform, and which is adapted for clients' condition. It involves stakeholder management, it involves document management, contract management, compliance reinforcement, process management, and ultimately project closure and asset handover. So this is the kind of tool and which is has different components depending on the phase of work that you are in. In the pre-construction, it would monitor tender flow, it would also issue LOA, it will monitor PBGs, contractor onboarding, mobilization, etc. would also be done out of it. At the construction phase, we will monitor the utility shifting, we will monitor the request for inspection. You would be very happy to know that the RODIC has about over 5 lakh requests for inspection within its system, and all of it has been part of it, and it enables us to learn out of it, and therefore the system gets smarter over time. The document repository, drawing repository, their workflow is an important thing. Health, safety and ES environment monitoring is also key to large-scale project management, particularly involving national highways, state highways now. Risk management is one of the key dimensions of the project management now, and we need to have a very structured approach, and RODIC 360 enables us to do that. Post-construction, we do document management, analytics and dashboarding, and preventive maintenance scheduling, and among many others items of work that we can get out of it. So, linear infrastructure, which the highway is, we have specific solutions, and this involves mobile application which can be used by multiple stakeholders, the engineers, the contractors. So all of it are part of the system. The highways are geo-fenced, and therefore when you do some inspection, you confine yourselves to the highway. It's not some other place that you will take a photograph and post it. So for another component is a web application which has multiple elements, which is for use checking compliances. It can also display map view, so all the defects can be displayed out there. Performance analytics can also be displayed on the web application, and I will show it as I proceed along. So it brings transparency, efficiency, effectiveness, and accuracy in the project management. So I have already mentioned LiDAR is one of the tools that we use. We can identify defects like potholes and cracks. We can map signages and markings. We can also assess traffic volume and density besides asset features. So I will showcase two type of projects, one involving the monitoring of the project progress, that is execution of project, and another relating to maintenance monitoring, and which we have done for Bihar, Maharashtra and Assam. This is a project that we are currently undertaking for the state of Maharashtra for a newly set up corporation called Maharashtra State Infrastructure Development Corporation. This corporation was set up only in 2023, and today you can see the portfolio of its work. It is handling about 145 contracts. It is handling close to about 6,000 kilometers of road, and it's not in lane kilometers but linear kilometers kind of sense, and costing about 36,000 kilometers. And this has enabled this newly set up organization to undertake and monitor through digital workflows and having different elements of the project management to monitor such a large volume of projects. And you see, you can see from this, you have different kind of roads. So you have 4 lanes, you have 2 lanes, you have 5 intermediate lanes, you have flexible, you have rigid. So all kinds of complexities are there, but we are able to handle. So you can I mentioned many of the elements. Alert and escalation management is one area which is good. Utility shifting, tracking, etc. is good. We also have a feature whereby independent test firms can also be integrated. So they can come and inspect, and their outputs get integrated with the overall monitoring of the project. So we don't only have the people within the system or the authority engineer within the system, but people from outside the system who can come in and do independent inspection, and all of this data is available for that particular segment online, and anybody can draw them at any point in time. There could be role-based restrictions, but it's available. You see, I mentioned about the complexity of the project. So some area of complexity also arises here. You can see you have some projects in the HAM mode, some projects in the EPC mode. So multiple kind of formats. I don't know if you can see them well, because so what benefits do we see, and which we show to the client? It minimizes cost overruns. In this project, what we have seen is that only about 5% has been the cost overrun, excess cost over the estimated ones. It increases operational efficiency, it improves the response time, it improves the real-time visibility, be it MD, be it superintending engineer, be it the junior engineer, everyone can see his or her segment of the road, and with that can take necessary decision. Improved stakeholder collaboration is of course an important thing. If during inspection it is noticed that some part of the work is not of the requisite quality, it can be reverted with remarks to the contractor, and contractor can undertake the necessary correction. You don't need to depend on the lengthy documentation to inform the contractor of the substandard quality. So in a sense, the turnaround time can be enforced, and contractor can't take the plea that they were not informed of the deficiency in time and therefore they were unable to do. So it's a great tool in that sense, and that doing all this protects the project timelines, and so we think it's a very critical project tool which helps everyone. This is an inspection tool, and where we can see not only the inspection that has been done, number of pending inspections which have been approved by the team leader. So all these can be monitored by any point in time, and anybody who is deficient in his or her performance can be immediately spotted, and necessary corrective action can be taken. This is another project which we are extremely proud of. This relates to a project called OPRMC, and OPRMC stands for Output and Performance Road Maintenance Contract. In this, the payment to the contractor is dependent on maintaining the service levels in the maintenance contract, and if they fail to do that, there are penalties. So the contractors are forced, the engineers who are part of the system, and please note that this system, generally it is believed that all these new kind of IT systems exclude the stakeholders on the ground. Here this system has not excluded. In fact, they are part of the entire workflow, and they are included in the decision making. So nearly about 500 plus stakeholders are there, about 10,000 plus kilometers road length. We are monitoring through it. More than 1,300 roads are there, and of till now 5,19,000 inspections have been done, and 85% defects have been closed within the response time. What benefits do we derive out of it? It is possible to remotely monitor what kind of when these inspections were done, whether they have been done by visiting the site. The data is available real time, round the clock availability of the data is there. The alerts and reminders are automatically generated, and therefore anyone who misses out gets reminder, and timely and informed decision makings are done. How many more
3-4 minutes? 3-4 minutes.
Sure. So you can see the number of inspections that have been done, the defects that have been identified. I would like you to note the bars in the lower boxes. You will see that everyone has, all the stakeholders have done the number of inspections that they were supposed to do. Say, take the junior engineer. In week 1, they were supposed to carry out about 13-18 inspections. The person did about 13-17. If you see the AE, he was supposed to carry out 1321 inspection. He did about 1312. So everyone is, it has brought that kind of accountability within the system so that everyone is attending to his or her role within the system. And everyone is ranked actually, so nobody can, the data is available in the public domain and to his peers, so you can't take shelter of anonymity which was there earlier in this system. This is the benefit that we see. In this, you see previously about people were carrying out inspection in about 55%. Now almost close to 100% inspections are being done. Within the turnaround time, 90% of the defects are being rectified. If you see the defect-free road length, it's about 90%. So quite a significant benefit has emerged out of implementation of this application. You can also see in the lower green and red bars that the defect-free lengths have improved significantly. This, in this we have shown the kind of defects which were closed within time, the defects which were not closed at the end of the month, how many of them were within the turnaround time. So you can also see that some of the defects, they are still taking more time, so probably it also gives us some pointer towards policy. If the let's say potholes, that is OM 101 is not being attended to in the say turnaround time that has been specified, what are those elements which are holding back people from attending to that? So it's a great tool for policy development as well. This is a project that we had done for the Assam using LiDAR and AI/ML. We divided the roads in about 100-meter segment, did PCI scoring with defect identification using AI and ML, and then informed the contractor for its maintenance and rectification. This is another project for Bombay Municipal Corporation that we have been doing. It involves about 2,400 kilometers of road length. It has about 450 plus stakeholders. And we are using AI/ML and LiDAR-based solution for road maintenance, largely similar to what we have done for Assam, not going into detail because of the time constraints that I'm currently under. What has changed is that BMC is no longer a reactive authority. It's it can take preventive actions so that the defects are rectified within time. We all are aware of the saying, a stitch in time saves 9. So therefore, if we are able to do it in time, we can save a lot of money. I don't have firm data, but I heard that Bihar government's own presentation mentioned that they were able to bring down significant reduction in the budget they had kept for maintenance using the OPRMC kind of solution. And I'm sure this kind of benefit can be derived for all the authorities. So these are the different elements of the BMC project. What I would like you to notice is the war room, that is command and control centers that we have established. 4 of them have been established, and so it enables those people heading those areas to monitor the status of road and to be responsive to the citizens' woes that are faced. This is the kind of laser profiling technology, Trimble MX9 machine, which has been used in the LiDAR survey. This is the topographical survey asset mapping done out of the LiDAR survey. This is the road condition assessment using this kind of vehicle. In this you would see that we have been able to segment this road in about 20 meters sections, and we can identify different kind of defects. I'm sure if it is visible from behind as well. This is another part of the OPI RMC where we have used AIML for the defect inspection. What I would like you to notice is the fact that people using visual inspections were able to identify about 9,300 defects, whereas using AIML 12,327 defects were identified. I am not saying what has been identified using AIML is the number that we should totally go by, but at least it enables you to dig deeper, think deeper, and only when ground truth and verified and validated by ground level engineers, then the truth will emerge, and we will be able to keep our highways in a better state of maintenance and let's say extract more juice out of the investment that we have made. So that's the end. Thank you very much for giving us the opportunity.
Sir, thank you very much for that wonderful presentation. For sure, Government of Orissa is looking for some kind of solution which is in these lines, digital project management and maintenance solutions for the projects, and you have demonstrated that the solution works really well for a road network of 5,000 to 10,000 kilometers. Already the Orissa team has visited Bihar. They have gone through the details of that. And you mentioned about the Korean, especially Korean Expressway Corporation has that digital traffic command and control center. So that once you create an infrastructure, you look at it. You don't leave it like that. And you mentioned war room. In fact, that's one which is going to be very critical to ensure that the infrastructure you are creating is going to be serviceable. I think, sir, the presentation, if it is shared with the people, not just the government of Orissa, but I understand we have people from other states, they will be greatly benefited if they are thinking of completing projects in a time-bound manner. So, share with IRC and IRC. Yes, sir. Yes, sir. We can share because today at 4:30, Honorable Minister of PWD is visiting the exhibition, and this is one question today morning he has asked me. So thank you very much. Please send the questions which are addressed to Sri N.N. Sinha. We'll pick up only 2-3 questions. So thank you very much, sir. With that, we move to the second presentation by Professor Prithvi Singh Kandhal, who is Associate Director Emeritus, U.S. National Center for Asphalt Technology, Auburn University, USA. It's on troubleshooting of bituminous pavements, worldwide experience. Professor Kandhal has been bestowed with the IRC Lifetime Achievement Award this annual session. So with that, I would like to extend warm welcome to Professor Kandhal. He will be making the presentation online. I hope you can hear me, sir.
Yeah. Can you hear me?
Sir, you can go ahead with the presentation.
Okay. Okay, I would like I'll try to share my screen here. Please bear with me.
Sir, if you can hear me, Professor Kandhal.
Yeah.
Yeah, sir, you can go ahead with the presentation. 25 minutes for you, sir.
Okay. Can you see my screen now?
Yeah, we started the session a little late, so please, you have 25 minutes, sir. Thank you.
Yeah. Can you see my screen?
Yes, sir. I can see the screen, and we can hear you very clearly.
Okay, very good. Let me share. I'll share screen. How about this? We have to do start sharing it. Okay, can you see my screen?
Yes, sir. We can see the screen.
Okay. Yeah, first of all, good afternoon to everybody, including chair and co-chair and my fellow highway colleagues. I'm sorry I'm presenting from Jaipur. I have been attending many IRSC sessions in the past and had presented 7 or 8 formal papers. So I'm going to miss you in person this time. So please excuse for me that. Now, the title of the presentation, as you can see, is Troubleshooting of Bituminous Pavements Worldwide Experience. Now, if you have a road like that, then we don't need any troubleshooting. Life will be very simple. But fortunately, we do have bituminous pavements throughout the world. And sometimes we see premature failure of these bituminous pavement. And that's why we need some troubleshooting there. Now, I would like to share this is the first ever textbook ever published in India on bituminous road construction in India, and it is very comprehensive. And as our honorable minister told day for yesterday, that we need recycling to cut cost, and this book has the largest chapter is on recycling. So there are many chapters in this book, and we got to know all aspects of bituminous road pavement before we start troubleshooting. So I recommend that we do read all the material about bituminous pavements. I had the privilege of investigating many premature failures of bituminous pavements across the world, including India. As I said before, the knowledge of pavement materials, mixed design, and construction procedure is helpful. Obviously, the experience is also very helpful. So, my presentation is divided into 3 parts. First is the general approach for troubleshooting, which I've developed. And then there are 2 case histories I'm going to present. So 3 parts
Excuse me,
only.
sir. The slides are not moving. We are still at the title slide.
Is it moving now?
You need to move. Yeah, it's moving to the second. Yeah, your book. We can see the cover page of your book.
Okay, then after that, this one?
Yeah, it's now moving.
Okay. Is it moving now?
Yes, sir. Yes, sir. Please go ahead. It's moving.
Okay. So first I'll talk about general approach for troubleshooting. Some of that I have developed over the years. So I'll describe that. And then I'll talk about shooting of 2 case histories only. The book which I showed to you before has 8 case histories. So that's in the last chapter. So they are all very interesting, like very much like detective type things, So interesting to read. So I recommend you to read the last chapter of that book. So the general approach which I do was that I select a representative 500-meter long poor section which is showing distress such as raveling, bleeding, rutting, and cracking. Any of these or combination of all these. So I select a 500-meter. I'll show you the plan in the next slide. Then I also select a 500-meter section which is relatively free of distress, which I'll call it as a good section. What might have been a little bit better than the poor, so I'll call it fair. So from the comparison of the test data, which includes mean and standard deviation of both the sections, usually the cause or causes become evident. For example, if the standard deviation of one test section is larger than the other one, that shows that there is a lack of good quality control on that project. So let me show it here that I have a good or poor test sections here and 500-meter length. So I'll take 5 cores in equal distance, and then I'll also take pits at the edge of the pavement. These pits will be used to test the subgrade GSB and WMM. Near these cores, I'll also have a 18-inch 18 by pit made by uh, using a jackhammer, so I don't add any water in there. Now in this case, you can see that these one lane I have chosen is near the median because that's where the heaviest traffic is occurring in India, unlike any other countries in the world. So we have to sample the lane which carries the heaviest truckload. So personally, I would like to see that such signs should be posted every 5 kilometers on four-lane Indian highways. Very easy, very simple sign. Trucks and buses should use the left lane, and cars should use the right lane, which is not the case in India, unfortunately. That's why we have so many accidental deaths, especially when overspeeding. Discipline is very much important. So I'm showing some pictures here that we have to take course. We also have to take sample of the some with the jackhammer so that we can get sample to test the moisture content because moisture content is very important to find the percent saturation of the voids. Also, this sampling will give us extra material for the theoretical maximum specific gravity, which will be used in the analysis. And also, I can see the stripping if there is any. With the core, it's not possible to see which layer is stripping or which layer is not stripping. So it is multifunction to take a sample with the jackhammer. Now here you see a coring operation because cores we do need to get the volumetrics calculated. And again you can see here that this is the lane carrying the heaviest traffic near the median. Now here is a very rare picture. There are three textbook stages of stripping visible on road surface. First, appearance of fines. You can see here, you can see the whitish appearance of fines. And then we see flushing. The bitumen is coming up to the surface. And then we see a pothole. I was very lucky to get all these stages of stripping in one picture. Sometimes we just see fines and we see pothole. There is no flushing. So, but these are the stages because what happens is that if the stripping is taking place in the binder course, then after the bitumen film is detached, the fines are exposed and the fines are brought to the surface by moisture or moisture vapor. And so we see the fines here first here. Then after the fines have been brought up, now the aggregate is exposed, so the bitumen which has been detached, that starts to be brought up to surface by moisture vapor or moisture. So we see flushing. Once you see the flushing, now the moisture cannot escape at all. So after flushing, the pothole develops very rapidly. In other words, the stripping starts to occur very rapidly. So this is what you see in this here sample from jackhammer. You see this stripping of the it's not a white aggregate, that's why in the blackish aggregate you don't see stripping, but you can see here to some extent. What I have developed in India is that a crude field permeability test, which I called grease ring test, because it's not, we don't have access to the field permeameter here in India. So what I just make a grease kind of wall here, 9 inches or 12 inches diameter, and put 12.5 millimeter water, like half inch of water, and then measure the time it takes for the water to penetrate. And thereby I can know relatively which surface is more porous than the other. I've seen that the premix carpet really absorbs water very fast, and if we have a BC, bituminous concrete, the water can stand for forever. So, having discussed the general approach, now let me talk about two case histories. One was in Australia and the other one was in Europe. So I'll start with the Australian one. There is a Hume Highway just south of Sydney on Sydney-Melbourne National Highway. Now let's take a look at all these composition of the overlay because we have to know these to keep in mind how the trouble occurs. So the overlay work was performed on this highway in June 1993. 80 millimeter thick dense HMA, hard mix asphalt, was at the bottom. Then over that they laid 35 millimeter thick dense hard mix asphalt on the top, and over that we had 30 millimeter thick OZFC, which is open graded friction course, very highly permeable, similar to previous carpet we have in there. So after these three layers were put in there in the overlay, they started to see the potholes in southbound lanes in February of 1995, primarily on the left slow lane where the trucks were plying, just 20 minutes after construction. So the question is why? That's the problem we are going to solve here. The other thing was that no potholing in the northbound lanes where the same contractor, same overlay, everything was same, was constructed at the same time. And I'll get to that in the next. So the question now is that why we have the potholes in the southbound lanes. And here you can see the picture of that expressway from Sydney to Melbourne, and you can see there potholes are there in the left lane, only where the traffic is heaviest. What I saw on that project was that there was a chicken wire or alligator cracks were there through which the fines were coming out on the surface. You saw my previous slide where fines will come out, because of the moisture vapor, and then a pothole will develop at that place. So that's why I suspected that on this project some sort of a stripping is taking place in the binder course or the surface course underneath. Mostly stripping start at the bottom in the binder course. So I asked them, they had a milling machine nearby. So I requested them that why don't we bring a milling machine here and mill it off layer by layer so we can obtain samples to find the saturation level and also see what's happening in there. So the milling machine was brought in there, and you can see here we have made a big cut in there. Part of the overlay was also on the shoulder. So that's why we have milling done also in the shoulder. But as I expected, there were no potholes in the shoulder area because there was no traffic. And for stripping to occur, we not only we need moisture, we also need traffic. So there was no traffic on the shoulder, so no pothole in there. And when we took out the sample of the binder course and the surface course, we saw a lot of stripping there. And I'll discuss the layer-wise system later on. And here you can see here in the top big, is the binder course where the stripping is taking place. And at the bottom you see some samples where the stripping has taken place in the wearing course. So let's talk about construction of the Hume Highway. I gathered from them this is what happened. They did use basalt coarse aggregate and crushed gravel fine aggregate. Now both are susceptible to stripping. And I found out that ineffective liquid anti-stripping agent was used. As at that time, we were seeing more of the case histories of stripping throughout the world, and liquid anti-stripping agents were being developed at that time. So at that time, I think the hydrated lime was the best solution to take care of the stripping problem. The third thing I found out from the people in charge of construction was that the OZFC, open graded friction course, which is highly permeable, was placed immediately after the surface course, which had interconnected air voids. In other words, it has not been densified by the traffic. So the water from the OZFC, which was highly permeable, that is the purpose of the OZFC, easily penetrated both the surface course and the binder course. I'll show you the cross section here. So you can see in the top road surface, let me see that. OZFC has 18 to 20% voids as per design. That's the way it's designed. So the bottom one third was stripped there. So the water from the OZFC penetrated into the surface course, which has 8% voids, and it was stripped. Binder course also has 8% voids, and it was stripped. Here are the existing bituminous courses. So you can see here that the water is having access down to the binder course. So that's why the stripping will take place. So when we did the milling machine, we found out that the top surface course was heavily saturated and the water started to ooze out. It was very dramatic appearance there. So not only this surface course, the binder course was also stripped and saturated, but surface course was more saturated because it was near the OGFC. So now the question is, I told them all these things, how things happen, how the water penetrated, all that, how stripping takes place. They said that's fine. They were convinced about that. But then the question they asked on the first day was that how come there is no potholing in the northbound lanes, which same contractor, everything was same. So that kind of threw me a question which I had to ask them. But luckily, I had seen in Pennsylvania in the United States is that in the afternoon, I could see sometimes the water oozing out of the pavement in the afternoon. And also, if I compress the surface, some water will also come out. So based upon that, I thought that the traffic has to be very heavy in the afternoon. So that experience kind of saved my grace in there. So I told them, okay, over the night you gather some traffic data, like so many vehicles per hour on hourly basis on southbound lanes and the northbound lanes. So I was very lucky that to find out next day that in the southbound lanes where the potholes were developing, peak traffic was in the late afternoon when the pavement has become very hot. So the high moisture vapor buildup was there. It is very surprising to note that the volume of moisture vapor is 1,700 times that of the moisture. So there's a lot of vapor buildup, uplift takes place. And the other thing is the viscosity of the binder is also low at 60-degree pavement temperature. So stripping, it also helps in stripping. So the northbound lanes, when they gave me the data, we found out that the peak traffic was early in the morning before sunrise, and low moisture vapor buildup was occurring at that time. So the binder was also stiff at low temperature. So I told them that it's a matter of time before the potholes will start to show up in the northbound lane. And so lessons learned was that evaluate water saturation level in bituminous courses through samples obtained by jackhammer so that we can get the actual moisture content. Use hydrated lime as an anti-stripping agent. Delay placing of the OZFC for at least 2 summers so that the underlying surface course is densified under traffic. Otherwise, provide a fog seal to close the surface voids. And that's what has been done throughout the world now. So now the second case history, that was in Europe, in Azerbaijan in 2004. They built a 21-kilometer of two-lane highway which was exhibiting central line crack in both lanes. Usually you don't find central line crack in any lane actually, and it was occurring on that case. So it was a nuisance. Crack sealing had to be done every year as new cracks develop. Crack sealer would not penetrate the fine cracks and just smear the surface. I'll show you some picture of that. So the project was investigated in 2007 to determine the cause of the center line crack. So that's the main problem we are going to solve here in this case. That why we have a crack in the center of each lane. Now this project involved uh, complete overlay over a deteriorated Soviet era road. So let's take a look at the cross section here, keep that in mind so that we can look at the problem. First of all, from the top down, 50 millimeter bituminous wearing course. Below that, 75 millimeter bituminous upper binder course. Below that, 100 millimeter bituminous lower binder course. So the binder course was constructed in two layers. Below that, we have 250 crust gravel base course. One thing I would like to point out here is that they did not use any anti-stripping agent at all, because with the gravel, we do need an anti-stripping agent. The gravel is very prone to stripping. Now here you can see the construction joint. I'm not showing there is some sort of a central line joint is appearing here, but it's not very clear. So the construction joint was also not done very bad, was very bad. Now here is the central line cracking, which initially shows up like that, like one crack, and then after some time, one crack will develop into multiple narrow cracks, and now they're all very narrow, so sealer would not penetrate these cracks, so just smear the surface. It was a nuisance. So every year more cracks will develop, and they have to keep on sealing that. So now here you can see the central line crack. Now I must say that a part of the overlay was also on the shoulder. So here you can see the construction joint crack. So it was not done a good job. And then, I'm sorry. And here is the central line crack. You can see there's a lot of smearing is taking place. So let me see if I can see the pointer. Here is the construction joint. Here is the central line joint. You can see a lot of smearing is taking place. This is central line because the part of the shoulder was also done in the single paver. So what I did was that I told them that let's take some core samples right on the center line crack and also away from the crack. So they brought a coring machine. So the condition of the asphalt mix just below the center line crack, I saw this thing, that the core showed honeycombing low density binder mix, which usually disintegrated in the coring operation. Also a picture of that. The binder mix was very coarse and it was severely stripped. Now here you can see the picture of that binder course, and in the top of the lower binder course was intact, and then we went gradually, and then at the bottom it was almost completely stripped, as you can see here. So this is the picture of you can see here that I have a low density zone on the left side, and that's where, let me show the picture here. So the lower binder course is kind of stripped here as per the core I took. So because of that there was a poor support, so the crack would migrate from there to up there, and then more cracks will develop. So the question is that this area, low density, has a lot of honeycombing. So the question is that why is that so? That was my question. That was the question which I have to think about that, and that's what you also have to think it now. And let me show you the reason for that was that here is a good paver where we have these augers, and there is one reverse auger on this side and that side. Reverse auger in a good paver pushes the material below this auger drive box, because here there is no auger, so it has to push it below that, so density is achieved. What I told them that let me see the paver which was used on this job, and I could see there that in that case there were no reverse auger. All augers were just pushing the material on this side, so nothing was being pushed under the dry box. So that's why the zone which we saw a lot of honeycombing was taking place right below it. So, so I told them that it was a very poor designed paver. Because I knew about that. There were some pavers were done with this kind of a defective thing, that there were no reverse auger. So that was the question, and they were satisfied with that question. So the lesson learned on the second uh, case history was that use anti-stripping agents such as hydrated lime for stripping prone aggregates such as gravel. Now, in their case, the optimum binder content was selected at 7% aeroids, not 4% as we do. So that also reduced the bitumen content. And the third thing was that make sure that you use a paver with the reverse augers on both sides of the auger drive box to push the material behind that. Now, when you, this is the last slide, when you go out on a project which is to be troubleshooted, usually you have to walk on the road, along the road and look at the whole thing. And sometimes you find like beer bottles and soda cans and all that. And once in a while, you also see something like that. In some states of the United States, there is a big rat, which is called armadillo. It crosses the road and gets killed. Now, in this case, the state PWD, when they were using the yellow stripe in the central lane, they did not care to remove this big rat and striped on top of things. So that's a very strange scene there. With that, thanks very much for your attention, and I'll be glad to answer any questions that you might have. Thank you.
So thank you very much. We'll be taking up the questions at the end of all the presentations. We have one more presentation to go. Sir, thank you very much.
Okay,
With
thank
that,
you.
we'll go to the third presentation by Mr. Hughes Benbow, who is the Global Support Manager at ARRB Systems Limited at Great Melbourne. So his presentation is on traffic speed deflectometer, new innovations. So 25 minutes. Thank you. So I request the audience to send me the questions if you have a question.
Good afternoon, ladies and gentlemen. Namaste. A warm welcome to all our distinguished representatives from the road authorities and research institutes across India and the world. My name is Hugh Benbow, Global Support Manager for ARB Systems. It's a very proud moment for me today as I stand before you as we announce the arrival of the iPave into India. The iPave, the first and only proven comprehensive pavement measurement system in the world, capable of measuring surface, structural and subsurface elements in a single pass. There are systems around that measure these parameters separately or individually, but this is the only system in the world proven to collect all of these parameters in a single pass. Let's talk first about our current technologies. What is our current state of play here in India and in much of the world? So our current technologies, the NSV, it measures our functional and surface condition data using a combination of 3D lasers, point lasers, scanning lasers, coupled with INS systems, 360 cameras, right-of-way cameras, as well as the world-renowned LCMS system, which is used broadly across the world as well as for quality control purposes here in India. This essentially is the gold standard for measurement of surface condition, and this is widely accepted around the world. You find these type of machines on different vehicles in this configuration globally. In terms of structural condition measurement and bearing capacity, the most common technology at the moment is the FWD. The FWD is synonymous with structural assessment, and it is the industry standard. However, we are moving forward. There are downsides with the FWD. It is slow, it is dangerous. Having a vehicle stop in traffic for up to 30 seconds a minute to perform tests, dealing with the lack of data that this system generates. Fundamentally, we have a very low number of test points that an FWD can generate in a single day. And that's one of the major limitations. We can only essentially perform spot tests with an FWD. We never have a full understanding of the structural capacity and the bearing capacity of our roadways. It's impossible with an FWD. It will take a lifetime. The other technology which is newer and more emerging is GPR. It is becoming more widely used, but there is still kind of a concept of a little bit of black magic behind the idea of GPR. These waveforms that we see underground the road surface. But as we are progressing with GPR, we are learning more and more how to use this information and how to avoid situations like having to go out and do expensive core sampling on roads. Again, a dangerous practice, going out, having vehicles performing coring on public roads. We often have to have traffic control in place, and if we don't have traffic control, we present ourselves with significant safety issues. But in order to get accurate data, that was the historical method of performing these inspections and determining these layer thicknesses so we can perform our back calculations. So we lay out some of our challenges here. The FWD is stationary, disrupts traffic, it's unsafe. It has a low spatial resolution. Generally, if we're trying to do network level surveys, there might be 200 metre to 500 metre spacing. Otherwise, we might go out with our network survey vehicle first and do an initial screening, identify areas where there is significant degradation in the pavement, and then we'll take our FWD out and we'll go and perform testing in those locations. The problem is that our pavement has already started to degrade. We don't understand the structure before we actually see a problem on the surface. The NSV is great, but it only provides us that information on surface defects. We have to combine that with our structural information, our subsurface information, in order to paint a better picture of what we're doing. GPR is not currently being widely used. There is an argument to say that we should be using more and more GPR and focusing on adopting that technology, moving away from core sampling. A major issue that we face is that the data is collected in multiple vehicles, on separate days at separate times, perhaps in separate climatic conditions. How can we practically compare our data when the data is not collected simultaneously and consistently? This also presents challenges with data alignment. In order to align our data correctly, we must spend a lot of time in ensuring that the data alignment is correct and valid. And in many cases, there will be errors that are introduced into the process that we cannot eliminate. And sometimes it becomes impossible to align these data sets. This manual consolidation process is slow and it can lead to misalignment. So what are the solutions for our current challenges? Okay. What do we need to do? What is the way forward? So more often than not, roads are designed by strength characteristics. Pavement and civil engineers spend weeks and weeks, they spend their lives determining. We just watched a very interesting presentation from an emeritus professor who spent his life dedicated to understanding pavement failure. And I'm sure when he stops and thinks about how to design a pavement, he thinks about how do I define the strength of that pavement? How strong do I need to make it? Okay, and how do I define those strength capabilities? But once we have built the road, the aspects that define the strength of the pavement are hidden to us. They are sealed under our wearing course. Okay? We then manage the roads based on surface characteristics. We kind of forget, for the most part, about those structural characteristics. Okay? We wait until we see fatigue cracking on the surface and then we go out and test with an FWD in order to determine the way forward. But what if we have a smooth surface with a strong subbase? What if we have a rough surface with a weak subbase? But what if the inverse is true? What if we have a good surface and we have laid a good surface, but we have a weak subbase? How do we know? Knowing the difference can save us a lot of money, can save many, many crores. So let me introduce the iPave. I hope some of you have taken the time to look at the iPave. We have the trailer here this week, and I hope you've taken the opportunity to go and look through the iPave so that we've had the opportunity to talk to you about the iPave, the technology, and get you up close with the equipment. If you haven't, I encourage you to do that. The iPave combines all of these elements together. Okay? We have functionally the heart of an NSV installed onto a rolling weight deflectometer capable of measuring continuous structural capacity. Added on to that, we also have ground penetrating radar, full vehicle width ground penetrating radar, which is measuring full scans of the lane at various depth, various frequencies, a spread frequency antenna that we're using in order to get the most accurate data that we can have. This system collects continuous high-resolution structural and surface data at traffic speeds. It provides a holistic pavement condition profile in a single pass. There is no other system in the world that can present this information to you in a single pass that has been tested and proven and approved by road authorities around the world. Some of the most prestigious road authorities, road research institutes have adopted the iPave. Organisations like Highways England and TRL, BAST in Germany, the NTRO in Australia, the Federal Highway Administration in the United States, TxDOT. All of these organisations, they believe in iPave and the technology and what it can offer to them in understanding and managing their road assets. This enables faster, safer and more cost-effective network level assessments. It supports proactive maintenance planning through predictive analysis based on comprehensive data. Another amazing part of the system is the data is so detailed that we can perform network level surveys, but then when the time comes, we can take that same data and we can break it down so that we are performing essentially project level investigations on that data. And there are very few other systems that enable you to do that. Normally we perform a network level survey, we will identify areas that are of fatiguing and failing, and we will go out and perform project level assessments once we've identified them in a works program. This is not the case with the iPave. We can go from network to project in one step. The system operates within traffic flow with no external traffic control requirements. It looks just like a normal truck for the most part, except if you look at the back, it really just looks like a normal truck, big refrigeration truck. This system can and has completed 12,000 lane kilometre network in 9 weeks. This was a demonstration that we did for the DNIT in Brazil. The equivalent FWD network testing, 1.2 million test points, it would take you 24 years with a single FWD, or 1 year with 24 FWDs. It's a significant investment. It also reduces the risk exposure and severity considerably over other stationary or slow-moving objects. So if we consider the FWD or even some of the rolling deflectometers of the past, the Lacroix deflectometer, the curviometer, these systems operate at maybe 10 to 30 kilometres per hour maximum. They still weren't a safe vehicle to use in traffic. They still needed traffic control, safety measures in place. This system is used across the world, as I mentioned. Okay, currently 12 iPaves operate globally. The platform that the iPave sits on, the Greenwood TSD, the number of the TSD out here is TSD number 24. So 12 of those TSDs in operation are iPave systems from ARB Systems. We operate in the US, Canada, and Mexico in North America, Brazil, throughout Latin America. We have 2 systems in South Africa. We have taken our iPave across Europe from the north of Scandinavia down to the south of Spain. We operate 4 systems in Australia and New Zealand. And now we are here in India. The This can be used for comprehensive network level, project level assessments, as well as research studies, which has been proven by many of the research institutes around the world, including BAST in Germany. So how does the system work? Essentially, we have a rolling wheel. The rolling wheel has a continuous loading of 10 tonnes, 5 tonnes per axle. That is configurable. We can bring the loading down in some circumstances where road authorities are very concerned about the bearing capacity of their pavements. They haven't built their pavements to the structural capacity. They have load limits on their roads. In some of those cases, we may reduce the total loading. As an example, 10 tonnes is 22,000 pounds. In the United States, we use 20,000 pounds as their specification. Or we can bring it up. We can increase the loading. We go up to 12 tonnes, 6 tonnes per side for a 60 kilonewton axle loading. We have an array of Doppler laser heads. These Doppler laser heads are measuring the velocity of the pavement. So as the truck moves across the pavement, it is physically bending the pavement. It's imperceptible to the human eye. We cannot see it, but it is physically happening. We know this because we can measure it. We can measure it with an FWD. We've done that for many, many years. But we can also measure it with high accuracy velocimeters. These velocimeters are traditionally used in vibrometer testing. So for vibration testing, they might have a shake table. They place a device on the shake table and they shake it, and then they point the sensor at it and they measure the oscillating frequencies. Using this laser sensor and changing it so that we point it down at the pavement surface and roll a heavy weight along the pavement surface, we can now measure the acceleration of the pavement surface as we bend the pavement. So bending the pavement, it pushes down, and using these laser heads, we can see essentially the movement of the pavement in real time. At the very right-hand side of the image, you'll see what we call the reference laser. This laser is positioned 3.5 metres in front of a load. This laser should be measuring zero deflection under normal circumstances. Progressively, the other lasers, as we move forward, will measure increasing values of acceleration, velocity. We then integrate those velocity values, we convert those into those velocity values, and then we integrate those values into slope values. So we take the vertical velocity and the horizontal velocity of the vehicle, and we then convert that into a slope value. Once we have our measured slope, we can then determine, using our calculation methods, the calculated deflection at D0. Now, while we may not have lasers specifically at D0, our field studies, our field trials have demonstrated that we are able to accurately define what D0 is, exactly the same as an FWD would, with excellent repeatability. The TSD is non-destructive. It uses Doppler lasers to measure the traffic response, the pavement response at traffic speed. It's measuring deflection velocity. Okay, we have a 10-tonne axle load, and this generation 4 TSD that we are using in the iPave has 11 lasers with 8 in front and 3 laser sensors behind the load in order to measure the viscoelastic response or the load dynamics and on stiff pavements and slab shift between slabs on concrete pavements. The iPave itself, as we mentioned, is a fully integrated network survey vehicle as well at the same time. So on the rear we have our LCMS2 system as well as a rear right-of-way camera. We have our deflection measurement, we have INS and GPS measurement in order to get our positioning. We have a front digital imaging system, up to 3 cameras. We can also include 360 cameras. We're currently working on developments which will appropriately create a 360 environment on a vehicle that is 15 metres long. We also have our 3D GPR as well as our regular point laser texture measurement and roughness measurement that is industry standard. So in terms of the data that the iPave or the deflection measurement and system fully can generate for us, what is all this data that it could generate? Okay, we generate deflections from our slopes. We can generate SCI 300 as well as D0, absolute deflection values. Greenwood have got a new SCI TSD calculation, which they'll be releasing a research study on soon, which gives us a SCI TSD, which looks at the deflection bowl in a slightly different way than traditional methods. We can measure our layer thickness with our GPR. We can measure our surface conditions with our 3D laser and our inertial laser profiler. We can calculate our strains and our modulus by back calculating the information that we receive from this vehicle and get those results very, very quickly, very rapidly from a single data set. We can also obviously perform our viscoelastic back calculations. And it's not that we can perform those in a single area, we can perform them anywhere along the pavement. That's one of the greatest advantages of this system, is that we don't have to choose, go out, please do 5 test pits for me. Where do you want those test pits? 50 metres apart, let's say. But at the end of the day, if the problem was in between those test pits, we never would have seen the problem. And that happens in more cases than you might imagine. So the IPAVE system and the TSD system, the calculation of the deflection is using this model here, using this AUTC model, area under the curve. So on top of here we see the slopes that have been calculated from the velocities, and then by looking at the area under the curve, we can then determine the deflection bowl. And this is how we determine the deflection bowls, by looking at that area under the curve and then plotting that as a negative value, as a deflection in microns. Using this method and a curve fit, it also allows us to perform or determine the deflection at any point along that curve. So by determining deflection at any point along that curve, we can calculate the deflection at any point along that curve. And we can use that information in order to better understand the condition and the structure of the pavement. So here's some examples here of just some of the moving values. This is essentially what we would see if we were looking at the data and clicking through 10 metre or 1 metre intervals, depending on the data that you're looking at. So TSD versus FWD, okay? 27,000 test points a day. I probably would have made it a nice round 30,000 test points a day if I was doing this graph myself. If we compare that to an FWD, the number of test points is minimal, very, very minimal. Okay? The speed and difference in terms of the volume of data, the amount of data that you get, the rapidity of collection. Normally an FWD might do 30 kilometres a day. The IPAVE will comfortably do 300 kilometres a day. In perfect environments, perhaps in the outback of Australia and things like that, when we have no traffic and just a direct opportunity to drive into the sunset, we can do 600-700 kilometres in a day. Imagine that, 700 kilometres of structural, subsurface and surface data collected in a single day. So I want to show you this example here. So this is an example from a case study that was done in South Africa. And what we wanted to do is we wanted to compare and determine that back calculations, viscoelastic back calculations, are consistent between an FWD and the IPAVE. So we performed a case study and we found a defined area, a reference area for strong pavement and a reference area for a weak pavement, and we tested both of those critically using the FWD and the IPAVE. We then had independent and internal civil and construction engineers, research engineers analyse that data, run it through their viscoelastic back calculations, and we ended up with these results. Okay, so we have FWD in yellow, and we then have IPAVE in red. And these are the different layer calculations based on the data inputs. For our layer thicknesses, in this case, we used core sampling in order to get the highest accuracy and to ensure that we were using the correct information when performing these back calculations. It was a research level study, not a network level. But this just goes to show that the FWD and the IPAVE, they are consistent, they are the same, they measure the same data, they give you the same results. This has been proven and accepted by road authorities around the world. So the IPAVE has been here for a short time, We brought it into the country a couple of months ago, and we've been getting it ready, and we've been doing some initial discussions and test trials. Cube Highways Corporation asked us to come in and do an initial test trial for them on the NH44 between Delhi and Agra. So we performed a test on this section, and we essentially performed two types of tests. One was a repeatability test, okay, to ensure that the equipment itself was repeatable, to demonstrate the repeatability of the equipment in terms of its deflection measurement, its roughness measurement, all of its parameters. The other aspect that we did was a reference check against an FWD. So on that site, at the same time, and to ensure that we weren't using old data, that we collected the data on around the same days, we had the FWD there collecting data at 20-metre intervals. We wanted as much data as we could get out of the FWD. And we then collected that data, and we then performed an analysis on that data, cross-correlation, cross-referencing of that data. And then I'd like to present to you the results of that test here.
3 minutes. 3 minutes.
My clock has stopped on the screen here, unfortunately. It stopped at 16 minutes. So this data here that we have from the NH44, as you can see, the blue data is very high resolution data. This is the data from the iPave, okay? This is our, essentially our D0 deflection. In the red spots, you can see that we have essentially the FWD data cross-sectioned against that. And as you can see, there is a very good correlation between those two data sets. The FWD generally follows the iPave system and the iPave deflections. There are some outliers, but that is to be expected, particularly when we are doing singular spot tests. But what this demonstrates to us is there is a high level of repeatability when comparing, or a high level of comparability and accuracy when comparing the iPave and the FWD. Here is the repeatability charts, okay? Again, looking at the D0 deflections from the southbound and then the northbound lanes. And as you can see, we have a very, very high level of correlation between those two data sets. Great level of consistency, a great level of agreement. Our ground penetrating radar, we're using a contour ground penetrating radar. It's a spread frequency radar. It's a full width radar, multi-channel. We get an enormous amount of data from this system. Some would say too much data sometimes, but we then analyse that in-house and just present to you the information that you require. You can also analyse the data yourself. We can present the raw data to you, but you can also just provide to you the layer thickness information, and that way you have the layer thickness, the critical information that you require from this subsurface inspection. It's a very useful tool for understanding what is happening below the pavement. So why the iPave? Focus on improved accuracy of structural and condition data. More test points means more information. More information means better decision making. Trying to make decisions, I feel for the engineers of the past because they only were able to make decisions based on very, very limited information. But the engineers of the future will be empowered with big data, with lots of information, with an abundance of knowledge that can drive their decision makings. It helps us make better decisions. We can optimise our maintenance and rehabilitation planning by identifying early signs of structural and surface issues. The comprehensive machine helps target preventative treatments before costly failures occur. This proactive approach extends pavement life, minimises high-cost interventions, improving cost efficiency over the pavement life cycle. We generate, obviously, our data in standardised formats, CSV formats, Excel formats. We can then use that data to perform additional analysis, safety ratings, back calculations, mechanistic analysis, and then we can also then use it to influence our maintenance strategy. This is the purpose of this data. Influence our maintenance strategy, influence our engineering decisions. We also have a system called Hawkeye Insight, which we take this data together and we place it on an online viewing platform to allow that data to come together in a single space. And we're happy to do a demonstration for that. If you'd like to come past our booth, we can show you the Hawkeye Insight platform. We can show you some demonstration data that we have. I can show you some live data that we have from some of our clients who are kind enough to allow that to be shared from some of our international clients who have different rules around how they can share government and public data. This allows us to view our deflection data, our imagery. We can have heat maps, overlays, all this information, and multiple data sets plotted together. And we know that the data is aligned. We know that the data is accurate. Okay? It's driving better decision making. It allows us to categorize our roads better. Okay? We know whether a road is going to have a short lifespan because we can look at the bearing capacity. We could build a road and 1 week later we could go out and test that entire length of road and know that the information that we're putting into our predictive modelling is going to tell us the life cycle of that road and not just a close estimate. It will be very, very accurate, much more accurate than historically possible. Categorising these pavements so that we can make appropriate decisions about how we rehabilitate our roadways and how we manage and maintain our roadways. Thank you all very much. Dahanya.
Thank you very much, Mr. Hugh. So the vehicle is just outside the exhibition hall. You can visit that, and specifically for the IRC H6 committee, the maintenance committee can invite Mr. Hugh. If they are here, they can visit the vehicle, they can have detailed discussion, and it's good to understand the detailed functionality behind the presentation. Now we'll have a brief floor intervention. So in terms of the slips, I have not received much slips except for one intervention from Mr. Rajesh Naik, MP RDC, but like it was after a presentation by Mr. Sinha. He says that it's good appreciating the presentation, which is like the presentations are highly informative, well-structured, offering valuable insight into emerging technology and various type of practice adopted in road construction. So that is one part. And the depth of discussion and practical relevance of each presentation in the session is truly enriching. So that's a very positive comment, which says that why we should have annual sessions, why we should have these discussions. And in case anyone wants to speak, please raise your hand. Maybe I can, otherwise I can take some names. Dr. Bhavesh Jain, Dr. Pateria, Professor Venugopal Mahapatra. In case you want to speak, you can come forward, can share your viewpoint. So Dr. Bhavesh Jain, want to use the stage? No? Okay, so we have a slip. So that is from Mr. Indrajit Ghai. Ghai sir, you can go ahead. Please use a mic and you can speak.
Hello, R.F. Mahalaha from Rodig. I want to know what is the cost per kilometer of your survey? Per kilometer for a 2-lane road.
So you want to understand the cost of the collection? Yeah?
Data collection.
Okay. So essentially, realistically, it would be anywhere starting from about $250 US dollars. I would have to back calculate that into rupees for you, moving up from that point. So at a basic level, that collection would be about $250 US dollars moving up at that point. So per kilometre, sir, per kilometre. So we've had some discussions recently, and it raises a good discussion topic in that respect, and thinking about our maintenance, and think about how much 1 kilometre of road network costs you to build, and think about that number, and then think about how much you are prepared to spend in maintenance on that section. So our observation would be, think about what is a reasonable percentage that you would spend on a yearly basis in terms of maintenance on that section, and what value that actually is. The example that I give is our automobile, the car that carries our family and our children. If we were to spend, say, $10,000 on an automobile, it would be reasonable for us to spend $100 per year on the servicing, 1% of the value of that vehicle per year on the servicing.
Yeah, I'll suggest that maybe you have an interaction with them at the exhibition hall, and they are going to do trials for national highways for 200 kilometers of road network in the state of Odisha. So any further questions you have, one-to-one interaction with Mr. Hugh. Now there is a question for Mr. Kandal. What is the effect of median with plants? That was the third case study which you are showing in the last slide on performance of pavement. Professor Kandal, if you can hear me, you can respond. I'm not sure he was connected online. Okay. Yeah, if there is any other question, yeah, please. Please address to the particular speaker who is supposed to.
I have a question to Mr. Sinha. He has said that digital, it was a quite good presentation. I just want to know that ministry has mandated all its agency to have data on data lake also. So is there any pilot? Have you studied that your system can be integrated with data lake data that is already we are using for our project management, or?
We are actually examining it and soon reach out to the ministry. I have had discussions with DG Saab, DG RD and SS, but we are formulating our proposal in this regard.
I think since most of the work has been done in linear project, so probably that what ministry or NHI is struggling in data lake to have meaningful interpretive data in our project monitoring. It will be great, sir, if that collaboration work out.
We will soon reach out to the ministry.
Thank you very much. I'll just request that please send your written comment so that it is also kept on record, and we'll share with the ministry in a formal way. Thank you. Any other comment?
Can I answer the question raised to me? Can you hear me?
Yes, sir. We can hear you.
Okay. Yeah, somebody mentioned about the raised median.
Yes, sir.
I had two slides which I did not show because of lack of time. I just want to mention that I was traveling from Jaipur to Delhi, and I saw a raised median, and the lane just next to raised median has carried the heavy traffic, and it had a lot of potholes. Wherever the raised median would end at the intersection, there won't be any potholes. So that means the water from the raised median, if it has soil which is not permeable, then it will go towards the pavement layers. It can saturate the WMM and GSB and cause these potholes. So I have this concern about it won't happen at all the places for raised median, but somewhere it can occur, as it appeared on Jaipur Delhi highway. The other is safety feature. If I am driving my car on the lane next to median, if there's a truck is coming in the left lane, he can squeeze me out, you know. I don't have any place to go. There's no shoulder, nothing. So that's a safety concern. So I think we are building a lot of raised median, so we should give it a second thought.
So thank you, sir. I think with that we'll close the floor intervention. Now it's over to the co-chair of the session to wrap it up. He'll provide a brief summary. After that, we'll close the session.
Yes. Thank you, sir. Good afternoon, esteemed chairman, sir, esteemed speakers, and dear delegates. It's an honor to share the stage with you, sir. Professor Mananjan Padi, President, Indian Road Congress, a visionary leader guiding the national road sector towards innovation, safety, and sustainability. From the land of Konark to a leader in national scenario. So, on behalf of Indian Road Congress, I extend my heartfelt appreciation to all the three distinguished speakers for their innovative, insightful, and modern presentations. Each of you brought a unique perspective that blended technical depth and forward-looking ideas. So I will start with my first speaker. Uh, Nagendranath Sinha, esteemed speaker, Sri Nagendranath Sinha, MD, Rodic Digital and Advisory. All operations of the main, before I asked, giving the insightful details regarding the speakers, just I want to make a point here in this esteemed gathering. It's a time has come for the Indian Road Congress to look at civil engineering through a new lens, one shaped by data, intelligence and innovation. The artificial intelligence holds transformative potential to revolution how we design, construct and maintain, govern roads. From prospective maintenance and predictive maintenance and safety analysis to real-time quality monitoring and transparent project management. AI empowers engineers to move from reactive decision to proactive solutions. As the custodian of Indian road standards, IRC must now lead this digital transition in integrating AI into codes, practices and capacity building. By enhancing AI, we can ensure that our roads are not only stronger and smarter, but also safer, greener and more accountable, truly affecting the vision of smart infrastructure for new India. So, in the presentation of MD Rodic, all operations are digital. Every organization across the globe is now transforming the data and digital project management in the same way. AI and ML is transforming civil engineering. My humble request to all state PWDs and corporations, explore potential of AI for transformation. A digital platform like R360 for AI, I think it can affect the in the all stages of a project, like feasibility stage, DPR stage, procurement stage, construction stage, project monitoring stage, and quality assurance stage, as well as completion stage. Project initiative in Maharashtra, Bihar, Assam are really interesting. And in Odisha, there are more than 60. In Odisha also, we have started the initiative of AI for building and as well as highway sectors. And we find out there are more 60 processes and applications where we can use AI in building sector as well as in road sectors. Then to our second esteemed presentation, troubleshooting of bituminous pavement worldwide experience by Professor Prithvi Singh Khandal, Associate Director of Emeritus. Sir, your presentation was really insightful. It's a regarding the good or poor sections. A good section reflects to the stretches of road that performs well and meets the expert desired standards in terms of ride quality, safety, drainage and durability. Flushing occurs due to excessive binder, inadequate air void mix, high temperature, heavy traffic loading, poor drainage bases. The Hume Highway is one of the leading highway of Australian road. You have presented about the Hume Highway. Why no potholes in northbound roads is one of the aspects of your presentation. And peak traffic in early morning before sunrise, low moisture vapor buildup, binder stiff in low pavement transparent. These are the factors why there is no potholes. Impact of moisture on pavement, that's quite interesting. Moisture is one of the leading causes of pavement distress and structural failure. Then impact of temperature on pavement condition. Temperature affects binders, properties, volume, changes stress and durability. And when there is a combined effect, it's more interesting. Like moisture and temperature, when both combinedly affect on the highway pavement, moisture weakens structures, high temperature stiffen binders, and combinedly it causes rattling or swaying. Similarly, wet and cold condition causes toe damages, and alternate wet and dry cycle causes fatigue cracking. Similarly, traffic speed deflectometer is one of the criteria. So then, my third esteemed presenter, he is traffic speed deflectometer, new innovation by Hook Bonbo. Global Support Manager at ARF system, IPAV system. IPAV is an Intelligent Payment Assessment System. In a specialized vehicle-based payment assessment system, it uses advanced sensors including a traffic speed reflectometer. The advantages, very well he explains the advantages. The IPAV vehicle drives along a highway, on road network, on traffic speed, collecting data continuously. Then the system records structural responses, functional measurements also. The collected data is geolocated and time-stamped and enabling mapping and analysis of conditions across the network. Highway engineers use these data to infra-viewing capacity, fatigue life, structural strength, as well as decide on maintenance needs precisely. Why IPAV we need in India? Why we need in India? Efficiency and speed, holistic condition assessment, better maintenance planning, and resource allocation. Key challenges for adaptation in India. One of our delegates also raised the same question. It's regarding the cost first. Second is data handling capacity. Third is integration with the existing asset management system. Fourth is adaptation of local conditions. These are some of the key findings. So I once again thanks to all the speakers. Thank you so much. Now, Honorable Chairman, sir.
So we now hand over to our hostess for the closing of the session.
Thank you so much, sir. And thank you to all our esteemed speakers for your insightful presentations. And with this, we conclude the session on our digital project management and maintenance solutions. We truly appreciate your valuable contribution and thank you for being such an engaging audience. So now it's time for some felicitations. So may I please request our chairperson and co-chairperson of the session to kindly come forward to felicitate our speaker of this session. Starting with Sri Nagendranath Sinha, Managing Director, Rodic Digital and Advisory. Thank you so much, sir, for sharing all the knowledge with us. Next, we have Mr. Hugh Benbow, Global Support Manager at ARRB Systems Limited, Greater Melbourne. And we also had Professor Prithvi Singh Kandal, but he has joined us online. But heartily congratulate him and thank you so much, sir, for sharing all this knowledge and insightfuls in your presentations. Thank you. And now it's time to felicitate our chairperson and co-chairperson of the session. And to do the honor, may I please request on stage Engineer Pradeep Kumar Chena, Engineer-in-Chief, Rural Works Department, Odisha. We'll start with our chairperson of the session, Professor Manoranjan Parida. And co-chair, Sri Trinath Behera. As all our gentlemen are at the front, be there, stay back. We are going to take a group photograph. And please take the photograph with the screen, as also we are having Professor Prithvi Singh Kandal. He's right there on the screen. We all can see you, sir. Thank you so much. And we'll start our next technical session in next 10 minutes. So everybody, now it's time for a tea and coffee break. Go grab your tea and coffee and have some chit chat. We'll be back after 10 minutes with our next technical session. Thank you. All right, ladies and gentlemen, as we are running a little late, may I please request everybody to kindly settle down, grab your tea and coffee, and you can have a seat and enjoy your tea and coffee and enjoy the session as well. May I please request everybody to kindly join us as soon as possible. Settle yourself. We are about to start the technical session 18. Requesting all our delegates to kindly settle themselves as soon as possible. In a few moments, we are going to start the technical session 18. And in the meanwhile, if you want, you can click some good pictures as well. Shall we start? Yeah. So before we start the session, may I please request everybody to kindly put their phone on a silent mode. If your messages and calls are not that important, kindly don't answer it. Thank you. I can see a lot of people are still standing. Please take your seats. We have a lot, trust me. All right, how many of you did grab a chai, a tea? How many of you are tea person? Raise your hands. There's 1, 2, 3. So I got only 7 members in my family. All right. How many of you are coffee persons? A lot of people who don't take tea and coffee. My God. Yes, sir, coffee. Oh. All right. So as per your convenience, you have grabbed your tea and coffee, and let's start the technical session 18. Shall I start? All right, ladies and gentlemen, now it's time to say good evening to all of you. So good evening, and I welcome you all to the technical session 18. Presentation by Officer of State Government Departments, PWDs, local bodies and PSUs. And the session will be chaired by Sri N.C. Pal, Engineer-in-Chief, retired Odisha, and co-convener IRC Bridge Committee. May I please request you, sir, to kindly join us on the dais. And the session will be co-chaired by Sri B.T. Sridhar, Chief Engineer, Ministry of Road Transport and Highway and Regional Officer, Kerala. And now it's time to welcome our session chairperson and co-chairperson. And to do the honor, may I please request on stage Engineer Pragya Purnimasi, Superintending Engineer, Works Department, Odisha. Let's start with our chairperson, Sri N.C. Pal. Ladies and gentlemen, we can give a round of applause. And our co-chairperson, Sri B.T. Sridhar. Now I invite all our presenters of the session to please come to the dais, starting with Engineer M. Saravanan, Director HRS, and Engineer M. Anandraj, Assistant Engineer, HRS, Tamil Nadu. Next we have Sri Sanjay Patel, Superintending Engineer, Capital Roads and Building Department, Gujarat, and Sri Patanjali Mishra, Chief Engineer, Capital Roads and Building Department, Gujarat. Next we have Engineer Lakshmikant Padhi, Engineer-in-Chief, cum Special Secretary to Government, Works Department, Government of Odisha, and Sri Santanu Sahu, Superintending Engineer, NH Division, Sambalpur. And lastly, we have Engineer Jeet Singh Thakur, Superintending Engineer, HP PWD Bilaspur, Government of Himachal Pradesh. May I request all our presenters to kindly join us on the dais. And now I request our chairperson, Sri N.C. Pal, to start the session with his opening remarks. Please, sir.
Thank you. Very good afternoon to all of you on this technical session by respective state government. We have 4 presentations in this session. Each presentation will be given about 13-minute time, followed by 2-minute discussion, because each presentation limited to 15 minutes. And maybe at the end of discussion, if the time permits, then we'll have open house session. And maybe Mr. Patel from Gujarat is not here right now. Another presenter, sir, he can join substantially. So now I request the first presenter from HRS Chennai on sustainable utilization of non-degradable solid waste in highway infrastructure. Engineer M. Sarvanan, Director, and M. Anandaraj. Who is going to present? Okay, please. Yeah. I'll request the audience to keep their mobile in silent mode and maintain discipline during the presentation. Mic.
Okay. Vanakkam, Namaste. Good afternoon to chairperson, co-chairperson, engineers, academicians, scholars and press personalities. பயந்துக்கார் செய்த உதவி நயந்துக்கின் நன்மை கடலில் பெரிது. இது குறள் 103. எந்த பயனையும் எதிர்பார்க்காமல் செய்த நன்மையினை ஆராய்ந்தால் அந்த நன்மையின் அளவு கடலை விட பெரியதாகும். Yes, this is the tablet from Tirukkural written by Valluvar, who was adored by our father of nation since his maxim touched his soul. So I thank Government of Tamil Nadu, Government of Odisha, Government of India, the IRC, the chairperson, the co-chairperson for having given us the opportunity to present this research paper in this prestigious forum. The research paper is about the sustainable utilization of the non-degradable solid waste in highway infrastructure development. Now I present the abstract. Rapid urbanization and population growth have led to a dramatic rise in municipal solid waste generation across in India. India generates over 62 million tons of municipal solid waste per year. Tamil Nadu generates about 15,000 tons municipal solid waste daily, with Chennai city alone generates approximately 6,150 tons per day. This solid waste, most of which is disposed of landfills or incinerators at Kodungayur and Perungudi, causing serious environmental problems such as groundwater contamination, methane emissions, and loss of usable land. To address these challenges, the Greater Chennai Corporation has initiated biomining to recover recyclable refuse-derived fuel, bioair, and inert materials. Now this study focuses on the reuse of inert, non-degradable municipal solid waste in highway embankment construction, thereby transforming a persistent urban waste challenge into a sustainable resources for the road sector. Reuse of inert material reduces landfill dependency, lowers the extraction of the natural soils, and contributes to carbon footprint reduction through circular economic principles. Laboratory experiments were conducted, including Atterberg limits, free swell index, a maximum dry density, a California bearing ratio, Searson test, as well as scanning electron microscopy and X-ray diffraction analysis to evaluate the effect of the inert solid waste in road embankment. The results indicate that the reclaimed inert solid waste exhibits favorable geotechnical properties such as high internal friction angle, non-plasticity, and adequate compaction characteristics. These properties ensure the stability and load-bearing capacity required for road embankment applications. The study proposes the construction of the trial embankment stretch within the highway resuscitation campus, along with an additional field trial stretch wherein the embankment will be filled with processed inert solid waste material for performance evaluation. To ensure scientific evaluation, Sensor will be embedded in both embankments to continuously monitor strain values and settlement behavior over time. Further, pavements will be constructed over both type of embankments, that is inert solid waste embankment and conventional embankment, and their performance will be compared and analyzed in terms of load bearing capacity, deformation response, and serviceability. Based on the observed results, the suitability of utilizing non-degradable solid waste in field applications for highway embankments and related infrastructure will be recommended to IRC. Now, with the permission of Chair, I request the engineer Anand Raj to continue the detailed presentation on this project. Thank you.
Thank you, sir. Good evening to all. Thank you for giving the opportunity to present this topic. India is the third largest producer of municipal solid waste in the world, following United States and China. These municipal solid waste causes soil pollution due to leached seepage from dump sites. It leads to groundwater contamination with the toxic substances. It generates air pollution from open burning of the waste. Due to decomposition of organic matters and absence of the oxidation, it emits the methane and greenhouse gases. It creates water pollution when waste enters rivers and lakes. In order to reduce this problem, the biomining process were introduced and installed all over the cities. In this process, the legacy waste or old municipal solid waste is excavated and screened using the Dremel machines. Then the waste is separated into compostable, recyclable, and inert fractions. The organic part is stabilized through bioremediation process. In this process, the microorganism, that is the bacteria and fungi attacks, are used to break down or remove pollutants from the contaminated soil. Then the recyclable are sent for recycling. In the entire process, the passing material, that is less than 20 mm fractions, are called as bio-earth or bio-soil. It is generally used for landscaping purpose or land filling in the low-lying areas. Coming to highways, while construction of highways, it requires huge quantities of borrow soil for formation of embankment and subgrade. However, for the continuous extraction from the natural sources is causing rapid depletions. So reusing this processed solid waste in highway embankment construction minimize the need for natural material extraction, thus conserving the natural resources. Generally, the solid waste is disposed by landfilling or burning, which has its own drawback. Whereas in this project, the waste material are proposed to be used in the road construction. The necessity of the project is to explore sustainable waste-based alternative in the fill material, to test and validate the municipal solid waste as a potential embankment fill material, to evaluate the engineering performance and environmental safety and structural reliability of the processed solid waste embankment, to analyze the field data and formulate the guidelines for the practical use of such material in highway projects. The objective of the project, the research aims to scientifically investigate the feasibility of reusing processed waste from the municipal sources as a fill material in highway embankment construction. It includes the laboratory characterization, embankment construction of a trial stage, and instrumentation for performance monitoring, and comparison with the conventional fill as per the relevant standards. We categorize this project into various phases. The phase 1 includes the collection of waste solid material from the selected dump site. The phase 2 includes for the characterization. All the physical and engineering properties will be tested, including the leachate analysis as per the Central Pollution Control Board norms. Then the results will be compared with the conventional soil. The phase 3 includes for the experimental embankment construction. The embankment will be designed with the processed municipal solid waste based fill, and we construct the 2 test tracks, one with the processed solid waste as embankment and another with the natural soil. And then the instrumentation were filtered into all the layers for analyzing the settlement, pore water pressure, and lateral deformation of the pavement. Then the entire process will be monitored for 1 year. Then phase 4 includes the economic and environmental evaluation. The cost will compare with the conventional fill. Then the detailed report will be prepared by this research station, and the report will be submitted to the government to make policy guidelines and recommendations. This is the one of our solid waste management plant located at Kodungayur. This was maintaining by Greater Chennai Corporation and Chennai City. The final output of the plant is called as bio-earth or bio-soil. Sometimes it is called as a filtered inert material. This is another solid waste management plant located at Perungudi, Chennai City. The proposed laboratories are the grain size analysis, specific gravity test, Atterberg limit test, Proctor compaction test, freeze welding index test, CBR value test, direct shear test, UCS test, permeability test, scanning electron microscopic analysis, X-ray diffraction analysis, Poisson ratio, resilient modulus, and finally the important study, that is the leachate analysis to be calculated. And we were collected some of the samples from the selected dump site, and we conducted the CO analysis, and we categorized in the various fraction. Generally, we are using the embankment purpose is less than 19 mm. So we categorize in various fractions, that is 19 mm passing to up to 75 micron. Then the CO analysis indicate that the material could be used for the embankment fill materials. And another geotechnical properties also conducted. The specific gravity value obtained 1.96, and this is ensured as a non-plastic material. The freeze welding index test is achieved 14%. The maximum drainage density we obtained 1.62 gram per cc. If minimum 1.6 is enough for embankment purpose. And optimum moisture content is 16.50%. The CBR value we achieved 5%, and it is a cohesionless soil. The angle of internal friction we achieved 34.86 degree, that indicates it is a coarse grained soil. And we analyze the scanning electron microscope for the processed solid waste. The SEM analysis reveals that materials has the rough textured materials, and it has the irregularity in the shape, and it includes some fibrous material also. And the final results indicates that the material could be used with the appropriate design control. And we analyze through the energy spectrum X-ray analysis also. This indicates the material having mineral diffraction testing, that is having various mineral, it includes organic metals and organic structures, heavy metals like titanium. Thus finally indicates the material could be used for the geotechnical applications. The proposed study is we construct the trial embankment using solid waste material. Then we embed the sensor with the embankments to monitor strain and settlement over time. We build the pavement over both trial and control embankment for comparison. Collect and analyze the data on load bearing capacity, deformation and serviceability. And we compare performance between solid waste and conventional materials. Then we recommend the suitability of non-degradable or processed solid waste for highway embankments based on the scientific observation. This is the test track we proposed in our HRS campus. The total length of the test track is 200 meter. For 100 meter length, we are going to using the processed solid waste as embankment, and another meter length we are going to use the natural soil as the embankment construction. This is a typical cross section of the proposed test track. Or about 1.5 meter depth, we are going to use the processed solid waste. To protect the solid waste, we are going to use the soil cover with a length of 2 meter on both the side. This is the 2-lane proposed pavement. And another 100 meter length or about 1.5 meter depth, we are going to use the natural soil for comparative analysis. And various sensors like load cell, strain gauge, temperature sensor, yes, sir. Temperature sensor, pressure cell, moisture sensor are also to be used to monitor the performance of the pavement. And this is the image of we are using the sensors to be used in the pavement. And separate laboratory will be provided for conducting the leachate testing, because for this material, leachating testing is very important. And lightweight falling deflectometer to be used to conduct the load bearing capacity and other deflection techniques for the formation of a embankment and subgrade. After construction of the pavement, the horizontal tensile strain and vertical compressive strain will be calculated through the sensors, and it will be compared with the conventional fill and the processed solid waste. Addition to the stability analysis and settlement analysis also to be calculated. Environmental impacts is very important for this project, so all the parameters will be checked for Pollution Control Board permissible limits. The steps will be taken to protect the groundwater, and the steps will be taken to control foul odors and dust. And carbon emission is very important, it is also to be calculated. While using this material, we are going to face various challenges. For waste segregation, we are tied up with some partner with certified waste handlers. For material non-uniformity, we are going to blending with the various material ratios. For compaction, we are going to conduct various trials with the Proctor compaction test. For long-term performance, we are going to fixing the instrumentation and continuous field monitoring to be done. Supply chain limitation, formal tie-up with the municipalities and recyclers will be done. Advantages of this project is huge things. So it reduces the quantum of natural soil required for landfill. It minimizes the natural resource depletion and it controls pollutions. It reduces health hazard to the segment of society, aligns with the national and state policies promoting reuse and recycling, cost saving in embankment construction. Field data can support IRC and more guidelines on sustainable construction. Finally, the conclusion is the use of processed municipal solid waste in highway embankment is a sustainable solution for waste management and resource conservation. It reduces landfill burden and minimizes the use of natural soil and aggregates. Future highways can incorporate processed solid waste as fill and subgrade material after proper testing. With continuous monitoring and standard guidelines, this approach can become a key step toward the eco-friendly infrastructure development. Last year, the More Circular has released for using this solid waste. Recently, our Honorable Union Minister, Road Transport and Highways also speaks in our Chennai city to utilizing the solid waste throughout the state, throughout the country. Regarding this, our respected HRS director also discussing with our government to utilize this processed solid waste throughout the state for making a greener environment in our roads. Thank you all.
Thank you, Mr. Anandraj and Sarvanan, for excellent presentation and excellent work of research. I think the delegates, you can remember in the inaugural function, Honorable Union Minister Gadkari ji has emphasized on use of solid waste, particularly for ring roads and earthfill embankment type of thing. And I think Highway Research Station Chennai has taken that a lead. What I can understand that you have gone up to gradation and saving only, and subgrade CVR is about 5%, and phi is about 35, and C almost 0. It is similar to a coarse grain soils. So that's the beauty of this process product. Now, house is open. We can take about 2 questions before you go for next presentation. It's open for discussion. We can have 2 questions. Please introduce yourself and mic, please.
Hello, good evening to all. It is very good.
Sir, please introduce yourself.
Sir, I am Chief General Manager, Tamil Nadu Road Development Corporation, Chennai. What your director is a good presentation made by HRS direction. They have taken the trial stretches to be conducted in 100-meter stretch of solid waste management, comparative with the separate 100 meters only for earth. Why can't we make both combination? Some 60-40 or 70-30. Earth can be mixed. We can make a study. If it is possible, it can be done. Okay? Okay, sir. Thank you.
Anything you have to say on this? You can respond.
That will be considered, sir. That will be also experimented, sir.
Thank you. Any others? Okay, Professor Venu Mahapatra. Can you give a mic to him?
Good evening. Myself, Professor Venugopal Mahapatra. I am from KIT University. So it's a wonderful work because it's really required. My only just question is, it's you have shown that phi equal to 35 degree, and it's behaving like a coarse grain soil. So it's a very good thing. But only thing, have you done any durability test of this one? Because it's going to be inside the ground, and how it will behave with the long-term point of view.
I think their base material, what they said is non-degradable materials. I think they can supplement.
Sir,
Yeah.
sir,
No,
it is a,
you have done.
sir, it is an ongoing piloting study. We are doing all the environmental and the chemical and durability study will be conducted because it is dumped in the year-wise. So many years it is dumped in the dump sites. Each material contains in a different values. That is, it is some materials having biodegradation material, some are having non-degradable, some of the having inert material, some of having non-inert material, even bio-waste also coming. So we are analyzing various testing methods, including in the various material in the various depth of the dump sites. So after final discussion, we will definitely submit the detailed report in the HRB upcoming years.
Because only one thing, leaching effect, just you have to see, and then you have groundwater pollution, that also from my point of
Yes,
view.
sir, that is the biggest
So,
challenge, because all the leachate, that is column method, normal method, during in the field method also we are going to conduct. Our HRS director giving so much of interest in this project. So definitely, because we are going to use in the Chennai city in the opposite of the governor building. So
Yeah.
we are very much aware to use this SAR pointers also we are consider. So definitely we'll do this.
Thank you,
action.
thank you.
Thank
Wish you all the best.
Thank you, sir. Thank you.
I think Professor Mohapatra, in their presentation, the leaching is one of the next study in the projects. Yeah, Mr. Acharya, last question. We can take the last question on this. Please introduce yourself.
Myself, Ram Prasad Acharya, retired support engineer and ex-engineer at BDA. Actually, during my BDA period, our higher authority interested for solid waste material to be used for the town planning scheme. But after that, we sent that material to the RDQP, government laboratory. They have given the report, and then we sent to the IIT Bhubaneswar. But they refused that. They told us that don't use that material. That is not good.
Means we have given a material and process and report to IIT Bhubaneswar, and they refuse about that. We'll have a discussion on that.
Sir,
Maybe some of the
now my report is with me.
because the use of solid waste management is call of the day. And that's why Union Minister on that inauguration also said. He said in our proposed Bhubaneswar ring road, at least Bhubaneswar solid waste has to be used extensively. And there are already pilot projects in this country. So we have to encourage this. We'll discuss about with the IIT Bhubaneswar. Thank you. I think we can go ahead for the next presentation.
I'll add something.
Yeah, please.
Just I'll add some of the, see, the basic thing, getting the uniformity in this waste is a big challenge. So better during the, while collecting the waste, construction manager, the construction waste and building waste should be separate area should be identified so that that can be used directly. Instead of mixing all with the organic, this, that and all, so it is not so easy to use and segregate. So better to segregate some of the site areas so that it can be dumped there, that can be directly used. That is going to give a more insightful thought. Otherwise, simply by telling this kind of a word, it is not so easy to adopt. That we can understand, because getting the uniformity with the waste is not so easy, and also it is a challenge to the engineer. And after adopting, there may be responsibility fix. So all these things will come in the real implementation. So during the municipality level itself, they have to identify the separate areas so that directly which can be used, that is going to give a good result in the field. Thank you.
Thank you, thank you. I think the second presenter from Gujarat, Mr. Sanjay Patel, they are not here. So I'll request the third presenter, Mr. Lakshmi Prasad Padi, Engineer Chief cum Special Secretary Government of Odisha. His presentation on climate change induced landslide in Eastern Ghat, assessing highway vulnerability and resilience strategy in Odisha. I think he's going to present with a case study. Mr. Padi, please. This by Mr. Padi and Sri Santoni Sau, Superengineer NH Division. I think Mr. Padi will present it.
Good afternoon. Respected Chairman of this technical session 18, Dr. N.C. Pal sir, and respected co-chairperson B.T. Sridhar sir, and the distinguished guests on the dais and off the dais, and ladies and gentlemen. My topic is climate change induced landslides in the Eastern Ghats, assessing the highway vulnerability and resilient strategies in Odisha. So the extreme weather events occur due to climate change, which has become a major threat to the infrastructure. Here you can see the recent cloud bursting in Himachal Pradesh and Uttarakhand. Now climate change, the increased frequency of high intensity rainfall, cyclones and extreme temperature has demonstrated a critical vulnerability in the current infrastructure assets. Further, there is a global shift towards incorporating greener construction materials and methods having the pivotal role in addressing the climate change challenge. Now, what is climate change? Climate is formally defined as the long-term regional or global average of temperature, humidity, wind and rainfall patterns typically assessed over seasons, years or decades. A key distinction is that while weather can fluctuate dramatically over a period of mere hours, climate represents patterns of change that unfold over significantly longer time frames. The climate change constitutes the significant sustained variation of average weather conditions such as becoming warmer, wetter or drier that persists over several decades and longer. This is the climate change effects. So this blue color is, you can see this 21,000 years ago our climate change, Earth's climate was minus 12 degrees centigrade, and now the mixed with blue and yellow, it was 6,000 years ago, and we predict that in the year 2071 to 2095, the climate change will increase by 6 degree more temperature than the present. So these climate change are due to the human activities. What we are making the changes in our lifestyles, our day-to-day functions by emission of greenhouse gases, this climate change occurs. This is the greenhouse gases. This is the graph between the greenhouse gases versus the years. We can see the greenhouse nitrous oxide, methane, carbon dioxide from the graph we have presented here. So global warming of the earth due to increase in the concentration of greenhouse is a major threat. The global average temperature in the last century has gone up by 1.1 degrees centigrade, and it is apprehended that the average surface Earth's temperature over India could rise up to 4.4 degrees centigrade in the end of this century. So these are the climate change, global warming. In North America, the highest recorded temperature is 56.7 degrees centigrade. In South America, it is 48.9 degrees centigrade. And these are the climate change global warming parameters in the different parts of the world. Now, the amount of climate change by the end of century is presented in the graph, projected temperature versus the years of subsequent years. And after 2020, the global climate of California experienced in the 2021 is 54.4 degree centigrade, the highest ever temperature in the world. Just months after, the record low temperature were reported in Asia and the US. So global climate change, global average precipitation increased by 7% for 1 degree centigrade temperature rise. These are the urban floodings. These pictures are urban floodings occurred due to climate change and heavy precipitation within a shorter duration of period. The runoff is increasing and leading to urban flooding in these cities, in the urban areas. So these are the climate change impacts. The climate extreme flood events are increasing in both frequency and magnitude. The distress of pavements occurs due to higher temperature is also causing thermal discomfort to the users. Next, climate change impact on the eastern Ghat of India. The eastern Ghats particularly traverse through the states like Odisha and Andhra Pradesh are highly prone to the tropical cyclones originating in the Bay of Bengal. The entire eastern India region is facing a significant rise in ecological droughts, a severe form of long-term moisture stress. The eastern Ghats are now officially recognized as a landslide-prone zone, and the risk that is significantly triggered by the intense and heavy rainfall brought by cyclones and extreme monsoons, the highlights is serious and it is a geohazard. Now we'll go to our topic. We have made some case studies in our state, the Eastern Ghats range. The Eastern Ghats in Odisha is a discontinuous ghat starting from the state Odisha, Andhra Pradesh and Tamil Nadu, Telangana. So we have a case study of the climate change impact at Kalinga Ghat. The Kalinga Ghat in the district of Gajapati is situated at a height of 1300 meter above the mean sea level, and this Kalinga Ghat is passing through the National Highway 157, which is starting from National Highway 57 at Charichak, and it ends and converging into the National Highway 59 at Aska, connecting the districts of Kandhamal, Baud, Balangir. The National Highway passes through these districts. It is a lifeline for trade, transport and connectivity for large number of districts. This mountainous Ghat section is known for its sharp U-turn bends and challenging terrain. So this geological and geotechnical characteristics of Kalinga Ghat is the disintegrated rocks of Kandalite and Charnokite formations. It is bounded by loose gravel and soil arcs. When these formations are prone to weathering and shear failure under prolonged and intense rainfall, particularly where jointed and fractured. So this event has occurred in the month of September 16, 2025. There is an incessant and heavy rainfall occurred with 300 mm of rainfall within a duration of 3 to 4 hours. And due to that, the cloud bursting and the saturation of, due to this cloud bursting and flash flood, they led to the saturation of soil and loosening of rocks. This portion is the midway of the Kalinga Ghat, that is 5 kilometers ahead of the Durga Prasad and in the mid of the Kalinga Ghat hill area. As a result, massive boulders and heaps of mud cascaded into the road, and flash floods washed away the road base completely. Approximately 40 to 50 meters wide strip of the road was severely damaged. Approach road and culvert and retaining wall were washed away. That damaged some sections to the tune of 10 to 12 meters deep below the finished road level. So, due to this impact, the road connection between major districts of Ganjam and Kandhamal was cut off, and the complete disruption of traffic movement through the critical transport corridor happened. The increase in travel time due to diversion of traffic through derouting through other roads, causing inconvenience to the passengers and the public, and there was a high risk of further rockfall boulders due to loose soil and continuous rainfall. The creation of a new stream due to flash flood. Originally, there was a small culvert in this location. So, due to this flash flood, the culvert was completely washed away, and there is a new stream and a big stream has created due to this flash flood. This landslide caused loss of solid road base. So, for reconstruction and restoration, more than 2,000 cm of boulders are used to stabilize the base. So, despite boulder filling, insufficient width led to the controlled blasting for base widening. That made us the controlled rock blasting procedure was adopted, letter within a duration of 5 days to begin the process of road widening. The initial blast achieved a degree of width expansion. A subsequent blasting operation was deemed necessary to achieve the required operational width. While some widening was accomplished with the first control blast, further action was mandated to ensure the adequate road width. Then a second landslide also occurred after few days of within a week, with flash floods recorded on September 22 following heavy rainfall for days together. This event involved the descent of massive rocks from the hilltop, creating a significant hazard for road widening. Again, the second controlled blasting operation was adopted to increase the road width on hillside, as the initial blast did not achieve the required operational access, because this is a national highway and the minimum road width required was up to the double lane with paved shoulder, that is 10 meter. So after the first and second blasting operation, we hardly achieved 5 meters width for operational movement. The all debris generated from the blasting was actively cleaned, and site clearance was done to prepare the next phase of restoration. Then gabion walls were constructed on the valley side to retain the slope. The anchorage of gabion structures to the surrounding solid to ensure enhanced stability and long-term performance. The implementation of the anchored gabion wall is a critical measure in reinforcing the slope and mitigating the risk of future soil erosion. A PCC base of thickness 150 mm was successfully laid on the valley side to establish a stable and solid foundation to carry out the subsequent construction of road. Then the after completion of the PCC work, which was delayed by 5 days due to intermittent interruptions caused by the continuous rainfall. Then the construction of the CD structures were started. The CD structure was completed over a period of 4 days, and due to subsequent rainfall resulted in damage of sections of the newly constructed structure. Hume pipes were strategically positioned for passage of water from the hillside, which was a necessary measure for managing water flow from across the site. Because after this incident of landsliding, for a prolonged period of 1 month, there was continuous rain, and in order to drain off the rainwater from the hillside, these Hume pipes were provided to discharge the hill water rain from the hillside to the valley. Then after laying the Hume pipes, the PCC filling was filled, the gaps between the Hume pipes, ensuring a continuous and stable surface of the causeway. Then ramps were constructed using PCC on both sides, and completion of PCC fitting and ramp formation required for a few days, with the process of experiencing delays due to intermittent heavy rainfalls. After that, the PQC work was finished, and as a corrective measures, the damaged PQC layers were entirely during the operation of PQC work. Again the flash flood came, and that washed away the earlier laid the PCC work. So subsequently, the corrective measures, the damaged PQC layer was entirely removed and subsequently reconstructed to meet quality specifications. Then the third controlled blasting was required for removal of the process of the hill range. Following the blast, it was observed some residual rock remains in the position. The additional controlled detonation was scheduled to address the residual rock and complete the mountain excavation. The drainage work was
Mr. Pade, you have 2 minutes to complete.
So I am going quickly. So after that restoration, we provided a drain for catching the rainwater from the hillside and to be discharged through the Hume pipes through the valley side. The safety measures were also provided. The debris flow guard wall thickness with weebles also provided to facilitate adequate drainage. And another case study is there is an ongoing project sanctioned by MORTH for widening of existing Kalinga Ghat. Uh, this is this portion is at 86 by 700 kilometer of National Highway 157. The road width was very low, so it was requiring to enhance the road width for the capacity of the traffic flow. So here we have adopted the concept of hybrid construction of wall, that is hybrid reinforced soil slope wall. This is a combination of soil nailing and reinforced soil. Due to this, the in the conventional RE wall system, we require a larger base in the valley side for widening of the road. But by providing the hybrid reinforced soil along with soil nailing, so the road of the surcharge mass will be transferred through soil nailing to the hillside, that requiring a very minimum width for the widening of the road. The RS wall geogrid reinforced fill materials with gabion face to resist lateral pressure. Because the time is short, I have to finish it quickly. I am skipping some slides. The advantages of hybrid retaining structures are reinforced earth with geogrids that improves tensile resistance and soil confinement. Gabion walls provide mass drainage and erosion resistance. Next. The excavation was carried out in benching with control slope. Excavated face was kept smooth and uniform to ensure the nail alignment. Earth moving equipment, the excavators and dozers were deployed. The foundation and preparation, while making the foundation preparation, we removed all vegetation, topsoil and loose materials from the foundation area, excavated the trench for the gabion wall, then leveling course was provided for 150 mm thick M10 grade. The PCC was well completed, finished smooth and cured adequately before the gabion placement. The placement of gabions, one PCC was set, placed empty gabion boxes of 800 mm height in position, securely tied and interconnected and filled with approved boulder stone as per specification, ensuring proper packing and interlocking. This is the drilling in nail holes in the Kalinga Ghat hillside. The drilling was carried out using ROC hydraulic pneumatic drill rig capable of inclined drilling. The hole depth is 6 to 22 meter depending on the slope profile and design length of nails. These soil nails were provided on the hillside for the stabilization of the hill slope. Then nail installation and grouting. The cement grout was prepared with a water cement ratio of 0.4 to 0.45. Grout was mixed mechanically in a high-speed colloidal mixer. For SDA anchors, grout was injected simultaneously during drilling through the hollow bar, reducing the risk of boreal collapse and ensuring continuous bonding. The drains over bombs, 150 mm thick aggregate drainage layer, prefabricated geocomposite placed against scotch-rope. The previous build-up of pore pressure beyond enforced soil structure, and the filter criteria is provided as per Morse section 2500 to ensure avoid clogging of the materials in the hole. Then the steel gabion baskets were placed and interconnected. The alignment checked using total station to maintain the true face profile, tied with binding wire to avoid displacement during compaction. This is the geogrid placement in the valley side. After providing the gabion wall and proper filling and compaction of the earth, we have laid the geogrid mat. Geogrid mats were laid over the compacted surface. The U-pins were used, fixing geogrid at required tensions to minimize the slack. The fixing of MS plate and not fixing, mild steel plates of 200 into 200 mm into 10 mm installed on the nail heads. These are provided in the hillside slopes. A cast into concrete pad of 500 is provided. The coir mat as per Morse table 715 placed in face to retain the fine soil particles. Topsoil layer placed beside mat with locally suitable seats. Hooks fixed to formak for coil mat anchorage. Then the backfilling and compaction. We have selected granular fill as per Morse section 3104 placed in 300 lifts. The vibratory rollers were used for compaction within 1.5 meter of face to avoid geogrid damage. The density were checked by sand core method and nuclear gauge. This is the completed hybrid structure. Vegetated reinforced slope, well constructed with integrated soil knolls, provides long-term slope stability against landslide erosion. Then we will go for a case study of National Highway 59.
Please conclude.
Yes, sir.
It's running
So,
out of time.
I will finish. This is another case study on NS 59, the rehabilitation of Daringbadi Ghat. This Daringbadi Ghat was, portion of Daringbadi Ghat was damaged in the cyclone Titli. I will skip some slides. The disaster cyclone Titli struck Odisha in October 2018, causing devastating damage to National Highway 59. This infrastructure impact, the NH50 connects Khariar to Berhampur. The geological challenges are the steep hilly terrain with condolite rocks, well-developed joint systems and inadequate drainage made the area prone to mass movement and slope failures. So I will skip this slide. Next we will go for the RCC. Conventional RCC retaining walls are requiring more width for accommodating the widening of the road. So instead of providing conventional RCC retaining wall, we have adopted the innovative reinforced earth composite hybrid structure. This high strength galvanized soil nails to stabilize the existing valley slope. The high tensile polymeric straps are used as a reinforcement directly connected to the soil nail bars to transfer the load to the soil slope, thereby reducing the width of the RSS. So this is the innovative sword mechanical stabilized earth system. These are the mechanical stabilized earth systems adopted in the slope of Daringbadi Ghat, damaged due to Titli in 2018. I am skipping some slides because of constraint of time. The design philosophies were adopted as per the standard designs prescribed by the experts. The design philosophy we will skip. Then the typical cross sections of the structures constructed in the Daringbadi Ghat section on NS 59 is here provided here. The construction materials are also given. Now I am also skipping this. So these are the construction process. We provided these soil nails, then we have provided the wire mesh, then we were giving the nailing through drilling the hillside slope. So these are the construction process, the pictures of construction process we have adopted during the construction of this hill stabilization we have given. So quality control test also carried out, soil nail pull-out test for validation, material compliance with IRC SP 48 2033 and IRC 102-2014 more specification have been followed, and continuous supervision and monitoring were also conducted during construction phases. So this is the completed structure of Daringbadi Ghat after restoration of the damage caused in the year 2018 due to Titli. The performance and the lessons learned, the innovative benefits, the reduced carbon footprint through mineral excavation, lower by use of these innovation reinforced hybrid reinforced soil slopes, we have reduced the carbon footprint, and we have lowered the granular fill requirements and adopted construction techniques suitable for remote disaster-prone regions with challenging terrain conditions. The performance structure is also equally good, and there is no settlement, nothing. The slope, no erosion of soils already 7 to 8 years, probably 2018, probably 7 years also elapsed, but there is no failure of the road surface or the slope. These are the project success summary and future applications.
Please conclude.
Yes, sir, I will conclude, sir. These is only 2 more slides, sir. Way forward and suggestive resilience measures. The climate informed planning and policy, integrate real-time rainfall, enforce strict regulations on hill cutting and mining near highways, institutional and community engagement, establish a dedicated Eastern Ghats Highway Resilience Cell under MORTH to entire NH to coordinate monitoring. Now I conclude, the climate change is amplifying extreme rainfall hazards in Odisha, with Eastern Ghats facing heightened landslide risks due to its fragile geology and astrophysical pressure. The 2025 Kalinga Ghat landslide exemplifies the cascading impacts of climate geology, interactions on critical infrastructure. Long-term resilience requires integrating climate projections into engineering design, adopting nature-based solutions, and strengthening institutional frameworks. Thank you. I conclude my presentation.
Thank you, Mr. Padi, for an excellent presentation and 2 excellent case studies. Actually, one of his case studies is a recent one in September, October, repeated precipitation and repeated collapse and fall of the rock slopes. So because of paucity of time, we stop him. And there is a request from Mr. Sarvanan. He has a flight, the first presenter. I will ask the organizer, will felicitate him. Then we will go for third presentation. After that, question discussion for both the presentation, because he has to take a flight.
All right, everyone, we have to interrupt this technical session as one of our presenter, he's having his flight. So we need to felicitate him before he left this place. I hope you like Bhubaneswar. I hope you like Odisha. And now may I kindly request our chairperson and co-chairperson to kindly come forward to felicitate our presenter, Engineer M. Sarvanan, Director HRS, and Engineer M. Anandraj, Assistant Engineer HRS, Tamil Nadu. Thank you so much, sir, for your knowledgeable presentation. He's leaving this place. We can give him a goodbye clap at least.
Thank you.
Thank you so much, and let's continue the session, please.
Now I think we'll go for the third presentation. After that, we'll have open house discussion for both the presentations. This is the last presentation. Actually, Mr. Patel from Gujarat has not come. This from Himal. Okay, please.
Thank you all, sir. I am seeking excuse from you all for going intermittently. I like Orissa. I thank Orissa for having given us the opportunity.
Okay, thank you. And any question do you have, you can give in the slip that will send to Mr. Savanan for his response. Thank you. Now this is the presentation by Himachal Pradesh PWD on disaster response to recovery. What is the role of HP PWD? That will be presented by Engineer Jit Singh, who is super engineer in Bilaspur PWD. Mr. Singh, you can take about 13-minute time for your presentation.
Respected Chairman, sir, respected co-chairman, sir, distinguished delegates, and fellow engineers. Good evening to everyone. Sir, I had 2 topics in mind for this presentation. One was very highly technical. That was a longest cantilever bridge constructed in Himachal Pradesh in district Bilaspur. And second topic is the one I am presenting today. Today's scenario, Himachal has occurred massive disasters during this year and last 3 years. And due to massive disasters, I felt that discussing disaster in IRC session will divide the attention of all the delegates present in the discussions, and such an important issue, no IRC code except 106/2015 was published by the IRC. Through your esteemed sir, I request the Indian Road Congress to kindly publish some IRC code for hilly terrain, particularly landslide mitigation, so that we can strengthen the roads in hilly terrain for more resilience and strengthening our road infrastructure. Through this representation, I will also share a case study of Hello. When a disaster occurred in Chamba district of Himachal Pradesh, and about 21 people lost their lives. Sir, my topic for today is disaster response to recovery, role of HPPWD, a case study with key learnings and suggestions. Sir, almost all the districts in Himachal Pradesh are prone to landslides. You can see, sir, map B shows all the 12 districts are having a huge landslide points. Second B, if we see that all districts having more than 60 to 70% have high landslide susceptibility. If we go district-wise landslide counts, Chamba district in Himachal Pradesh has more than 1,000 landslide points, more than 1,000 landslide points. It's a huge number. Second, Sirmaur has more than 560 landslide points. Third, Shimla about 460 landslide points. And least Lahaul Spiti and Hamirpur having 75 district-wise landslide counts. If we go district-wise share of landslide, Chamba again tops the list with 26%. Thereafter, Sirmaur with 14.3%, Shimla 11.7%, and least Lahaul Spiti having 1.3%, even though this district is more prone to avalanches and glaciers. If you go excess rainfall in Himachal Pradesh, 6 districts have excess rainfall during this year, more than 60% than the normal rainfall. 3 districts of Himachal Pradesh have excess rainfall between 20 to 59%. 2 districts have normal rainfall between 19 to minus 19. And 1 district, that is Lahaul Spiti, have deficient rainfall of minus 20 to 59%. Sir, I want to share the district management plan of Himachal Pradesh, which was framed by HPPWD during the year 2015. The purpose of district management plan was how to mitigate the disaster, what is the preparedness and capacity building of road sector, what is our response, and what is recovery and reconstruction and rehabilitation. So these are the key strategies. Before occurrence of any disaster, mitigation is required. In mitigation stage, there is a recovery, and thereafter, how to reconstruct the existing damaged infrastructure by mitigation measures. Thereafter, preparation. After the occurrence of disaster, what is our response and what is the recovery of that disaster which has been damaged massively. Sir, I want to share that Himachal Pradesh during the month of August and September, massive disaster occurred in district Chamba, district Kullu and district Mandi. About more than 40 to 86% rainfall was above the average rainfall recorded in the districts, in all the districts. PWD assessed about 3,000 crore rupee losses. It's a huge number. Although prevention is better than cure, but what and how to control such calamity, it is a big question. Sir, in the audience, can anyone guess what is the estimated losses were recorded in Himachal Pradesh during the current financial year? Can anyone have idea some? Sir, about indirect and direct losses, there are 20,000 crore 20,000 करोड़ लॉस जो है हिमाचल प्रदेश में इस करंट फाइनेंशियल ईयर में हुआ है, और टोटल अगर हम बजट की बात करें 58,000 करोड़ जो है टोटल हिमाचल का बजट होता है। और अगर परसेंटेज वाइज हम बात करें विच इज़ कम्स अराउंड 35% जो है वो डिज़ास्टर में लॉसेस हुए हैं। इट्स ए ह्यूज नंबर है, इसलिए लैंडस्लाइड मिटिगेशंस को टॉप प्रायोरिटी में देना पड़ेगा, कोड्स को इवॉल्व करना पड़ेगा, डेवलप करना पड़ेगा, और एक स्टडी जो है हिली टेरेन के लिए करनी पड़ेगी सर। एक केस स्टडी है सर, चंबा डिस्ट्रिक्ट एक मणिमेश पिलग्रिम यात्रा होती है, ये पीरियड बिटवीन 23 to 2 सितंबर की डेट है। नेशनल हाईवे 154 का केस स्टडी मैं प्रेजेंट कर रहा हूँ सर। इसमें सर 60% टोटल इसका रोड लेंथ था, 62%, अबाउट 12.5 किलोमीटर वाज कम्प्लीटली डैमेज्ड एंड वॉश्ड अवे। अबाउट 92 लोकेशन जो था टोटली रिटेनिंग वाल सेटल थे, कोलैप्स थे एंड वॉश्ड अवे। 128 नंबर्स लैंडस्लाइड्स जो थे वो अक्कर किए हुए थे। दीज आर द डैमेज पिक्स ऑफ नेशनल हाईवे सर। Repair and restoration work immediately started after the occurrence of the disaster. What are the challenges during rescue and restoration? All the connected roads to district Chamba, including major national highway, were blocked severely at multiple locations. More than 20,000 pilgrims and 10,000 vehicles stranded at Bhubaneswar before ongoing Holy Manimesh Yatra. Complete breakdown of mobile communication network, massive landslide and road subsidence, and complete road washed away. Shooting stone was a big problem, sir. Shooting stone and continuous rainfall further triggered the landslide, which made restoration work highly risky and slow. Other challenges, restoration. Fake news went viral on social media. Misleading statements were given to media by some people that nearly 3,000 people, pilgrims, had died, and videos were getting viral on social media. मैं सर एक वीडियो सर्कुलेट करना चाहूँगा, कैसा पैनिक क्रिएट किया जाता है पब्लिक में।
ऊपर 30,000 बंदा 3,000 बंदा मरा ऊपर, ऐसे लाशें पड़ी हैं, कोई नहीं खा रहा कोई।
एक साल लग जाएगा।
25 फुट सड़क नीचे गई हुई है।
वहाँ पे कम से कम 3,000 बंदों की मौत हो गई है।
ये खुद बोल रहे नहीं 100 बंदा मर गया, 50 बंदा, ऐसा कुछ नहीं। 30,000 बंदा, 3,000 बंदा मरा ऊपर, ऐसी लाशें पड़ी हैं साइड में, कोई नहीं खा रहा, कोई इसका वो नहीं है।
कोई ऊपर
वायरल वीडियो में सर मुझे लगता क्लैरिटी नहीं था। वीडियो में बता रहे हैं 3,000 लोग की डेथ हो चुकी है। जो आदमी वहाँ से मतलब वो पैदल चल रहे थे, तो एक बिग सोशल मीडिया में फेक न्यूज़ जो थी सर्कुलेट की थी, जिससे बहुत ज़्यादा बिग पैनिक जो था क्रिएट आया था। देन इन चैलेंजेस में हम लोगों ने क्या करना है? परसेप्शन इन जनरल पब्लिक वाज दैट it will take around 6 months to 1 year to get the road open. Then third one is the traffic management issues. Big management issues होता है during सर हमारा जब response होता है किसी भी department का। Immediately after the disaster, PWD का response उस केस में क्या रहा था? एक केस स्टडी में सर प्रेजेंट कर रहा हूँ मैं। फिजिकल रेकी हुआ था और उसमें कंप्लीट 62 किलोमीटर्स जो था उसका फिजिकल रेकी करने के बाद डिफरेंट डेट्स में देन हमारा टास्क क्या था? टू प्रोवाइड इमीडिएट कनेक्टिविटी भरमौर एंड इवैक्यूएशन ऑफ स्टैंडर्ड पिलग्रिम मणिमेश यात्रा फ्रॉम भरमौर एरिया। एक डेडिकेटेड टीम सर हमारे इंजीनियर इन चीफ हेड ऑफ द डिपार्टमेंट ने उसको कंस्टिट्यूट किया हुआ था एंड 5 इंपॉर्टेंट लोकेशंस उसमें डिवाइड किया हुआ था, 5 सेक्टर्स बनाए हुए थे। और डिपार्टमेंटल मशीनरी और जितना भी लेबर था दैट हैज़ बीन डिप्लॉयड ऑन वेरियस वल्नरेबल लोकेशंस। 55 मशीनरीज को डिप्लॉय किया था, 150 लेबरर्स जो थी मैन पावर था उसको डिप्लॉय किया हुआ था। ये जितना भी जो पिक्स हैं सर, ये हम लोगों ने ये जो शो हो रही हैं रेस्टोरेशन वर्क की वो डिपिक्ट कर रही हैं। दीज आर ऑल रेस्टोरेशन वर्क कैरिड आउट आफ्टर द डिज़ास्टर। सक्सेस पीडब्ल्यूडी में इस केस में क्या रहा था, केस स्टडी में लोग बता रहे थे कि 6 महीने से 1 साल लगेगा ओपन करने का। वी ओपन द रोड विद इन 7 days फॉर लाइट मोटर व्हीकल and within 10 days it was opened for heavy motor vehicle. All the pilgrims, tourists were rescued successfully and the whole team of HPPWD got appreciated by the Honorable Chief Minister and SDMA. Sir, आपके नॉलेज में बताना चाहूँगा, only 5 people died. As per the list जो था, जो डिस्ट्रिक्ट एडमिनिस्ट्रेशन जो गवर्नमेंट का रिकॉर्ड में है, लेकिन फेक न्यूज़ स्प्रेड किया था कि 3000 लोगों की डेथ हो चुकी है। तो ऐसे फेक न्यूज़ से लोगों में जो पैनिक क्रिएट किया जाता है उसको कैसे हमने डील करना है, उसके लिए भी डिस्ट्रिक्ट जो डिज़ास्टर मैनेजमेंट प्लान्स हैं उनमें उन चीज़ों में इसमें इनकॉर्पोरेट होना चाहिए। ये सर ऑनरेबल चीफ मिनिस्टर पीडब्ल्यूडी को फैसिलिटेट कर रहे हैं, सेक्रेटरी पीडब्ल्यूडी फैसिलिटेट कर रहे हैं, हमारी हेड ऑफ द डिपार्टमेंट इंजीनियर इन चीफ NP सिंह जी वो हैं, और साथ में SDMA की टीम है सर, स्टेट डिज़ास्टर मैनेजमेंट अथॉरिटी की टीम जो है वो पीडब्ल्यूडी की टीम को अप्रिशिएट कर रही है। रीज़न बीइंग कि जो 1 year या 6 month का बता रहे थे उसको 7 days and 10 days में उसको ओपन किया गया था। सर इस केस स्टडी में बेसिकली हमारा की लर्निंग क्या रहा था उसको मैं प्रेजेंट कर रहा हूँ। पहला लर्निंग ये था कि एंश्योर मैन पावर एंड इक्विपमेंट रेडीनेस, प्लेस स्किल्ड वार्निंग स्टाफ एट हजार्ड स्लोप्स, use shelters, wire mesh barriers, fog lights for worker safety, deploy traffic control team for traffic diversions and sign especially at night, in advocate slope stabilization. इन केस मिटिगेशन अगर हम लोगों ने पहले किया होता तो ये जितना मैसिव डिज़ास्टर शायद नहीं हो सकता, इसलिए स्लोप स्टेबलाइजेशन का और उसके लिए फंडिंग जो डिज़ास्टर मैनेजमेंट एक्ट सेक्शन जो है 49 में अलाउ करता है कि फंडिंग जो है डिज़ास्टर में इमिडिएटली उसको रिलीज होना चाहिए, जो कि नॉर्मली होता नहीं है। अदरवाइज इनएडुकेट स्लोप स्टेबलाइजेशन अगर होता है तो लैंडस्लाइड जो होता है वो बिग मैसिव लैंडस्लाइड होते हैं। सेकंड है सर, उस एरिया में हमेशा डिज़ास्टर मैनेजमेंट एक्ट को इमीडिएटली रेनफोर्समेंट करना होता है, उसको इमीडिएटली एक्ट को एनफोर्स करना होता है। अडॉप्ट एडवांस टेक्नोलॉजी जैसे सॉइल नीलिंग है, हेड्रो सेडिंग है, बायो इंजीनियरिंग है, दीज आर ऑल मिटिगेशन मेजर्स सर। प्रेफर बायोडक्ट, फ्लाईओवर्स एट रिस्की पॉइंट, अवॉइड रिपीटेड हिल कटिंग्स, community based early warning system to be installed, lack of real time monitoring system for landslide prone zones बहुत इंपॉर्टेंट सर, ये हम लोगों को इसमें बहुत प्रॉब्लम्स आई थी। फ्यूचर में हम लोग क्या कर सकते हैं सर? IRC में इशू लेटेस्ट डिजास्टर रेजिलेंट गाइडलाइंस एंड टेम्परेरी स्ट्रक्चर डिजाइन, कंडक्ट वल्नरेबिलिटी मैपिंग एंड जियो टेक्निकल सर्वेज ऑन हाई रिस्क हाईवेज, डेवलप अर्ली वार्निंग सिस्टम यूजिंग रिमोट सेंसिंग एंड वेदर डाटा, pre-positioning of emergency machinery and stop before monsoon, organize regular training and mock drills for engineers and workers. इंस्टीट्यूशनल फ्रेमवर्क हमारा सर अभी मुझे लगता है कि कोई भी डिपार्टमेंट है अंडर सेक्शन 40 ऑफ द डिजास्टर मैनेजमेंट एक्ट, एवरी डिपार्टमेंट हैज टू फ्रेम द डिजास्टर मैनेजमेंट प्लान। मुझे लगता है कि सर अभी मैं गवर्नमेंट ऑफ इंडिया का देख रहा था, 19 अगस्त 2025 को फर्स्ट टाइम जो है मॉर्थ ने मिनिस्ट्री ऑफ रोड ट्रांसपोर्ट एंड हाईवेज ने पब्लिश किया हुआ है आफ्टर द अप्रूवल ऑफ NDMA। इवन सर गवर्नमेंट जो सेंट्रल गवर्नमेंट की डिपार्टमेंट्स है उसमें भी डिजास्टर मैनेजमेंट प्लान डिपार्टमेंट ने फ्रेम नहीं किया था। रिसेंटली ओनली मॉर्थ ने अगस्त 2025 को फ्रेम किया हुआ है। रोल्स एंड रिस्पॉन्सिबिलिटी सर किसी की अभी तक जो है वो नहीं दी गई हुई है, इसलिए उस प्लान में किसी भी डिपार्टमेंट का डेलीगेशन ऑफ पावर सर, डेलीगेशन ऑफ पावर्स अगर हम जनरल फाइनेंशियल रूल देखा जाए 136(1) नॉर्मली नो वर्क शैल कमेंस अंटिल अप्रूवल हैज़ बीन अकॉर्डेड बाय द कॉम्पिटेंट अथॉरिटी। सर इसको हम यूज़ करके 136(2) जो डिज़ास्टर के लिए हमारा जनरल फाइनेंशियल रूल 2017 जो है वो बताता है, हमें इसके रोल्स एंड रिस्पॉन्सिबिलिटी और ये अप्रूवल स्टेट अगर उड़ीसा इज़ द फर्स्ट स्टेट इज़ पॉनियर इन फ्रेमिंग द डिज़ास्टर मैनेजमेंट एक्ट prior to the enforcement of disaster management act 2005, state of Odisha has already enacted the Odisha Disaster Management Act during 1990 and 2000 between उनके बीच में हुआ था और उसी को सर बेस मानकर नेशनल लेवल में डिजास्टर मैनेजमेंट एक्ट को बनाया गया था। तो मैं चाहूँगा सर उड़ीसा की इस धरती में डिजास्टर मैनेजमेंट प्लान पर्टिकुलरली फॉर PWD इंस्टीट्यूशनल ऑर्गेनाइजेशन के साथ साथ उसमें रोल्स एंड रिस्पॉन्सिबिलिटीज़ एवरी ऑफिसर राइट फ्रॉम SDO टू चीफ इंजीनियर जो है उसमें टाइमलाइन फ्रेम होना चाहिए और टाइमलाइन फ्रेम होने के बाद उनका फाइनेंशियल पावर डेलीगेशन होना चाहिए और इमरजेंसी में अगर वो लोग फाइनेंशियली कोई अगर उसको एम्पावर होते हैं उसको सेंक्शन देते हैं अकॉर्ड करते हैं वो गवर्नमेंट को विद इन 1 मंथ उसको अप्रूवल डीम्ड अप्रूवल उसको माना जाना चाहिए। ऐसा एक रूल्स जो है 78 रूल यही बताता है कि कोई भी स्टेट जो होती है रूल्स बना सकती है। अगर सर सारी स्टेट्स अगर इस तरह के मैनेजमेंट प्लान बनाएंगे मुझे लगता है कि इंजीनियर्स के लिए एक बहुत ज़्यादा बेनिफिशियल हो जाएगा। अदरवाइज जो हमारा रिस्पॉन्स रहता है वो रिस्पॉन्स जो है जिस लेवल का होना चाहिए उस लेवल का नहीं हो पाता है। तो मेरा रिक्वेस्ट आपके माध्यम से सब स्टेट्स को कि एक डिज़ास्टर मैनेजमेंट प्लान एटलीस्ट फॉर रोड सेक्टर्स जो है वो दोबारा उड़ीसा से बनकर अदर स्टेट्स में वो उसका एक मेमोरेंडम दिया जाए, उसका एक ड्राफ्ट बनाया जाए और उसको अप्रूवल जो है इन फ्यूचर में किया जाए। फाइनेंशियल डेलीगेशन सर हमारा मैं वही बता रहा हूँ 136(2) में होना चाहिए। एग्जिस्टिंग सर अगर हम मॉर्थ की बात करें उन्होंने एक ऑप्शन दिया हुआ है कि कोई भी डिजास्टर होता है तो ऑप्शन 1 में क्या होना चाहिए कि कोई भी वर्क अगर एग्जिस्टिंग वर्क जो है एग्जिस्टिंग कॉन्ट्रैक्टर को नियर बाई उस डिजास्टर के एरिया में उसको अवार्डेड है उसी को हम पावर किया चाहिए। विद डिविजन पावर्स जो है कॉम्पिटेंट अथॉरिटी का एक्सीन से लेकर SC से लेकर चीफ तक उसको दिया होना चाहिए। अदरवाइज हमारा रिस्पॉन्स जिस लेवल का होना चाहिए वो उस लेवल का नहीं हो पाता है। सेकंड सर शॉर्ट टेंडर नोटिस जो है प्रोक्योरमेंट के लिए है 166 रूल जो है जनरल फाइनेंशियल रूल 2017 एंड क्लॉज हमारा 3.5.11 मैनुअल फॉर प्रोक्योरमेंट वर्क्स का 2022 में ये मेंशन किया हुआ है बट दिस इज ओनली फॉर प्रोक्योरमेंट ऑफ एनी मशीनरी जो प्रिंसिपल मैन्युफैक्चरर है। सर कहीं भी सिंगल टेंडर या कोई भी ऐसा गाइडलाइंस जो है डिजास्टर में नहीं दिया गया है कि लिमिटेड टेंडर्स करने हैं उसका डेज क्या होगा उसकी डेलीगेशन ऑफ पावर्स क्या होने चाहिए। तो जो 136(1) में डेलीगेशन ऑफ पावर्स है उसी को ही रोल एंड रिस्पॉन्सिबिलिटीज़ में डिफरेंट जो अथॉरिटीज़ हैं उनको वो पावर दी जाए तभी हमारा जो रिस्पॉन्स जो है वो बहुत अच्छा हो सकता है। फंड एलोकेशन बड़ा इंपॉर्टेंट रोल है सर। अगर हम किसी कॉन्ट्रैक्टर से काम करवाते हैं हमारे पास फंड एलोकेशन नहीं होता है तो डिजास्टर मैनेजमेंट में बताता है कि इसमें क्लॉज जो है सेक्शन 49 में फंड एलोकेशन मैंडेटरी किया गया है। तो इट मस्ट बी एंश्योर्ड बाय द स्टेट अथॉरिटीज़ और द सेंट्रल अथॉरिटी टू एलोकेट फंड्स फॉर एनी डिजास्टर अकर्ड एंड वर्क एग्जीक्यूटेड एट साइट।
प्लीज
देन सर परमानेंट रेस्टोरेशन की बात करें तो एक्सटेंट गाइडलाइंस अभी तक जो है ना वो क्लियर नहीं है क्योंकि अभी न्यू मैं बताया कि मॉर्थ में तो उन्होंने 1 मंथ का टाइम लाइन फ्रेम किया है। 1 मंथ के अंदर पॉलिसी प्लान बना होना चाहिए हमने एग्जीक्यूशन क्या क्या करना है परमानेंट रेस्टोरेशन का उसके बाद ही उसमें टेंडर्स वगैरह प्रोसेस हो सकता है। सर हमारा मेजरेबल गोल्स जो है सबको शायद पता होगा सेंडाई फ्रेमवर्क जो है वो 2015 से एनफोर्स किया हुआ है। UN जनरल असेंबली ने उसको पास किया हुआ है और अभी तक जो है उस पर बहुत ज़्यादा काम इसलिए नहीं हो पाया हुआ है क्योंकि उसमें जो टाइमलाइन फ्रेम किया हुआ है 2030 तक सर 10% हम लोगों ने रिडक्शन करना है लैंडस्लाइड्स को, कोई भी ब्रिज कोलैप्स नहीं होना चाहिए, रिडक्शन ऑफ नंबर ऑफ इंजरीज एंड फैटिलिटीज़ बाय 50% इन 2030 के टारगेट जो है UN जनरल असेंबली में 187 नेशंस ने जो है इसको पास किया हुआ है। लेकिन ग्राउंड में सर सभी स्टेट्स को मुझे लगता है कि अभी काम करने की इसमें
प्लीज कंक्लूड मिस्टर ठाकुर प्लीज कंक्लूड।
रिकवरी एंड रिकंस्ट्रक्शन सर इसमें बिल्ड बैक बेटर जो है एक संडाई का जो एक फ्रेमवर्क है इसको एनफोर्स करना बहुत ज़रूरी है इन ऑर्डर टू एनहांस द रेजिडेंस। देन सर हमारा प्रायोरिटाइज करना है रिपेयर एंड लिवरेजिंग एडवांस टेक्नोलॉजीज एंड मटेरियल फॉर रिकंस्ट्रक्शन। ये सर IRC कोड ओनली 106/2015 जो है लैंडस्लाइड मिटिगेशन के लिए, नो अदर कोड जो अभी तक अवेलेबल नहीं है पब्लिश नहीं किए गए हैं। थैंक यू सर।
Thank you Mr. Thakur for an excellent case studies and what the department particularly PWD and Government of India and also at IRC level has to do. He has a good suggestion. Now the house is open for any question. We can take 3-4 questions maximum because both the cases presented by Mr. Padi and Mr. Thakur and based on climate change, disaster response and case studies. So House is open for any questions. I think then if there is no question, I will request my co-chair, Mr. Sridhar, to sum up these three excellent presentations.
Good evening. I think the three topics which were discussed today are all of some kind of a innovative and research kind of a topics which were almost a live examples. One is for the waste management. So it is a very challenging thing. People may tell to utilize the waste management, but the execution engineers who are there on the field will have some kind of a fear. If something goes wrong, it will be responsibility will fixed. So for this, the all kind of a waste cannot be chosen, and there should be some kind of a mechanism at the collection stage itself of the waste, and just like that construction waste and the building demolition waste, it should be separately collected and directly it can be used. And instead of mixing with all, I think that is one approach. It is going to give some kind of a result. Instead of collecting all with the organic material and finally segregation, it is going to be a very complicated issue in long run for the practicality. And the other one, which is the climate change and other thing, what the Mr. what is it? Paddy has presented. It's a kind of a case study with performance study also. It is so it gives a good performance as well as the confidence with the people to adopt this kind of a retaining wall structures and the mitigation measures so that it can be adopted directly. So because there is a fear that without the structure how it can be built. So that fear we can leave and we can adopt this kind of a mitigation measures and finally come to the disaster responsibility. So it is the one which is a very vulnerable situation for the engineers in the site. During the disaster management, so there is no sanction, there is no nothing, and people will expect the output from the engineers. So during that time it is very difficult, so you have to take active role, no doubt. But nowadays ministry has given some delegation of powers to the regional officers and other people, and also there is some kind of a norms which directly you can adopt the adjacent contractor to the work and directly you can start doing the work. That gives a good relief. So with that you can send the variation or change of scope to the existing work. And in another way we can take the umbrella of the disaster management of the collector, who can he can engage the agency and he can engage the even DPR consultancy also without tender directly, because the collector can sometimes in our system the collector is the superpower, so he can take decision with the disaster management. So I also facing this kind of a problem in Kerala. Recently in Wayanad, I have faced this kind of a landslide mitigation measure. That too in a Wayanad, that VIP MP is there. So she is writing on top to form a committee and nothing is going to happen. So we have cleared, but often and often the stone pieces are coming from top. It has to be removed, the agency has to be engaged, some DPR consultancy has to be done. So then I finally thought that we will reimburse the amount to the collector, so that let him engage the agency, so that we can avoid all this kind of audit and other kind of engaging agency problems. We can take the umbrella of the disaster management with the collector, we can start doing the work. Only during the final mitigation measures, that can be reviewed from proof consultancy. That is going to be a good option. Otherwise, with all the laws and sanctions, it is very difficult. So within the framework, how we are going to achieve, how we are going to give the output, is the main thing for the engineers. So with the administrative and with the facility, existing facility we have to achieve. With this, all these three topics which were interesting and practically applicable. With this, I'll conclude my parts.
Thank you, Mr. Sridhar, for summing up on the presentation. In fact, we had three excellent presentations. I also thank all the delegates for their patience hearing. And these are very interesting presentations. If you have any queries, you can send through IRC to the respective presenter. Now, stage is open to the anchor.
Thank you so much, sir. And thank you all our esteemed presenters for sharing such insightful perspectives on sustainable practices, climate resilience and disaster response in highway infrastructure. From Tamil Nadu's innovative waste utilization approaches to Odisha's resilience strategies and Himachal Pradesh disaster management case study, this session has truly reflected the diverse challenges and creative solutions shaping our nation's infrastructure development. So let's give a round of applause to all our speakers for their valuable contribution. And with that, we conclude this technical session and thank you all for your attention and your engagement. Now may I please request our chairperson and co-chairperson to come forward for some felicitation to our presenters. So we have Engineer Lakshmikant Padhi, Engineer-in-Chief, come Special Secretary to Government, Works Department, Government of Odisha. May I please request our chairperson and co-chairperson to kindly felicitate them with a lovely memento. Next we have Sri Shantanu Sahu, Superintending Engineer, NS Division, Sambalpur. And next we have Engineer Jeet Singh Thakur, Superintending Engineer, HP PWD Bilaspur, Government of Himachal Pradesh. And now it's time for our chairperson and co-chairperson's felicitation. And to do the honor, may I please request on stage Engineer Prasanna Kumar Sahu, Engineer-in-Chief, Rural Works Department, Odisha. We'll start with our chairperson of the session, Sri N.C. Pal. Ladies and gentlemen, let's give a round of applause. And our co-chair of the session, Sri B.T. Sridhar. And now may I kindly request all the presenters to kindly come forward. We'll take a group photograph with our chairperson and co-chairperson. So thank you, ladies and gentlemen. That's all from our side. And this is the last technical session here in Hall 2. And after this, we are going to have a business meeting. Thank you so much once again for making it so engaging. And thank you so much all our chairperson, co-chairperson, and all our presenters for sharing their knowledge with all of us. Thank you so much, everybody. Jai Jagannath, Bande Utkal Janani.
गिलास नहीं रखा है, यहाँ गिलास नहीं रखा है, गिलास लेकर जाओ। गिलास
थैंक यू सर। ज़्यादा है सर, ये नॉन माइक पे अनाउंस कीजिएगा। ये वाला? हाँ, ये वाला एजेंडा में नहीं एनी अदर आइटम में तो कर सकते हैं। जरा सबसे बेस्ट डाइक रहा चालू करते हैं। आई विल हैंड इट ओवर टू यू। एजेंडा तो ये मैंने सबमिट नहीं हो तो आप ओवर कर दो।
एक सकते हैं क्या ये मिनट्स का क्या करना है खत्म हुआ तो खत्म हुए ना इनको इसको इससे
हमने दो की है सर अनाउंसमेंट ये है ये एजेंडा के अकॉर्डिंग अनाउंसमेंट है तो ऑब्जर्वर अपॉइंट किए थे विशाल अग्रवाल जी ये मौलिक हमारे ई प्लान में तो उनके उसमें इलेक्शन हुआ और नॉमिनेशन आएगी
इस साल के बताना मुझे तो ये पिछले साल का एजेंडा क्यों क्या कर रहा है
ये रखा है एजेंडा
इसको पढ़ने की जरूरत
नहीं
ले जाओ फिर
Good evening, everyone. So please settle down. Now I extend warm welcome to all of you, all the delegates, other invited members, those who are here for the 84th business meeting to be held at Bhubaneswar. So it was scheduled for 6 o'clock, but it got slightly delayed. Nevertheless, now I'll request Secretary General. Largely, the item is with respect to the announcement of the various results with respect to the elections for the formation of the council. So I'll now invite Sri Rahul Gupta, ADG, MRTH, and Secretary General for making all the announcements. Thank you.
Yeah, I welcome all of you for the 84th business meeting of IRC. So this pertains to announcement under agenda item number 2 of the business meeting, that appoint 2 observers for election under rule